And sound check, sound check, sound check. This is the Worldwide Software Architecture Summit from Geekle. This is not the start of the event. We just do this sound check and stream check. If you can hear me and see me well, let me know in comments. I hope you do, and I hope everything is good. And I'm waiting from our technicians who will like let me know if everything okay and I can get out of here and we will set some music. Um, can what we see? Just let us know. They say everything is perfect. They like my cap. So yeah, should we do some music right now? Few minutes, people. I'm sure like 10 minutes, and we'll get back and will be the grand opening of this Software Architecture Summit. Can't wait. And finally, this is the beginning of this Worldwide Software Architecture Summit. So excited. Dear people, thank you very much for watching us. Thank you for joining us. This is super amazing event. I think it's the really so special event ever we had, because this is the first community for software architectures we do, and I have lots of my friends and family, of Geekle around me. They shooting some backstage videos, and we're so excited. This is software architecture community we're launching today. First of all, I'd like to introduce our goddess, Anna Shevchenko. She is the one who prepared, the chair, but it's empty, and Anna is here.
Hi everyone.
Wait a second. I gotta turn the mic on, and it's audio, and we do this. Another audio. I hope you can see and hear as well.
Hi everyone. I hope you can hear me. And first, I'm so glad to welcome you to our Worldwide Software Architecture Summit. And thank you so much for joining us and for your support.
Anna is a person who actually talked with all speakers, who mixed up all the agenda and prepared all this event. Actually, 12 people was working on this event, and we calculated something like 4,000 hours we spent on this preparation. And how many speakers you've been contacting? Some hundreds, I believe.
Yeah, actually, I've managed to talk to outstanding and leading professionals, nearly 100 speakers. I've talked to them, and they were really great, and I'm happy I managed to meet them. As well as our program board team. As Ed mentioned, there are 12 people who helped me a lot.
Yeah. So did you say 100 or hundreds of speakers you talked with?
Yep. Both chatting and speaking via Zoom or any other platform.
4 months. Yeah. And this event is really special for us, because usually we've been doing, these 24-hour events to have all the world and give possibility to people from any country jump in and participate for some hours. But we realized 24 hours is not that comfortable format, because lots of people wasn't sleep for 24 hours. Somebody woke up in the midnight to watch some precious speakers, and it's a kind of people was suffering of our content. It was, of course, super exciting that somebody doesn't sleep on other side of the planet, but that's what we figured out. We decided to do 2 events within one. So we decided to repeat this event twice. First part is for a European time zone, and same speakers. Can you imagine? Same speakers will talk twice for European time zone and America's time zone to deliver better experience, attendees experience. And instead of 24 hours, we'll have something like 40 probably hours.
Total overall amount, definitely. So we will have nearly 20 hours per day, and this is today event. That is
like 40 hours. Yeah. So how to manage this time zone for you, this time zone stuff? Just jump in anytime you really want, and any speaker you want. If some speaker is too late for you or too early for you, just find the same speaker, this speaker, on another part of our event. By the way, where should our people find the schedule, I mean, agenda?
You can find the agenda on our webpage as well as in your platform. So
yeah, just go on our website.
So please enter our website. You'll find full agenda for each speaker, their time slots, and Q&A sessions.
Yeah, and schedule the talk you are interested in, or jump in for all this time, and we'll spend great time together. We'll have lots of different moderators, maybe some, I heard about something like giveaways and some, what else you prepared,
really,
guys?
Really, friends, today many interesting and many surprises, I'd say, are waiting for you. That is why, please, stay tuned and
listen carefully. Listen carefully. Okay, so what else? Actually, it's one more thing. From today, we have subscription plans for our community members who would like to stay with us not only on these global summits once or twice a year, but all during the whole year. What type of content you're going to do there at that subscription?
Well, that is really interesting format, and I hope that our community, our audience will enjoy it, as we are going to have like short, unique videos, so-called episodes on a weekly basis. So you'll be able to upgrade your skills weekly. Besides, you are capable of watching our past and upcoming events. So all this content will be published there.
So we will share links. I'm not sure right now, or maybe later, but during the event, we'll share the link. You go there, start the free trial. Of course, if you have paid track, you'll have access to these software architecture summit videos for nothing, because you already have paid track. You will have access for 6 months. And what will be there inside of this platform? All recordings of our previous events, like all summits. Which summits? Is Java, React, Node.js, cross-platform, which is Flutter and React Native development. So all these summits recordings will be up there. And weekly online meetups prepared by Anna also will be broadcasted up there. So we'll share these links. And, we'll just
keep this secret for our upcoming episode, and you will know soon.
Okay,
it will really rock.
So the first episode is ready now.
Almost everything.
You know what is it? People, we're so happy to have you here. No more chatting, no more words. Let's do our first moderators, and give us a few moments to connect our moderators, please.
Yeah. Yay.
And meanwhile, I'll switch audio settings. Yeah, thanks, Anna. And thanks, Chair.
Hi, Ed. How do you?
I want to introduce you, Maria Vovchuk. Maria, hello. Can you hear us?
Yes, I can hear you well. I hope that you can also hear me. Is it everything okay? Can you hear me, guys?
Excuse me. Is everything okay with Maria's sound?
Sure. Let me just check, but I think that so far.
Just let us know in comments.
Is everything okay with the sound?
Yeah, sure. Everything works well. Yeah, okay. Maria, thank you very much for this participation, for this work for us.
Thank you for inviting.
Maria is our great friend from very first event. We've been, no, not first, actually, from second. First was really long ago, but from the second event, from Node.js Global Summit. Do you remember the time?
Yes, I remember it. And I remember all the excitement. And at the same time, I was Well, every time when I'm moderating some specific event, some specific IT or blockchain conference for the first time ever, I'll tell you like there are like more nervousness in that case. But anxiety maybe a bit. But at the same time, I tell you like right now I don't have the anxiety, but at the same time I have only like excitement, and I'm really happy again to join our team, and I'm really happy as well to present our amazing speakers who we have today. A lot of amazing, interesting presentations are waiting for you. So definitely a lot for you to discover. So thank you once
Cool.
again, David, for inviting. Ed, for inviting.
Thank you too. I never told how many people would gather to this event, and you can't even imagine that. It's almost 11,000 people registered on this
Awesome.
event. Yeah, like
Awesome.
65,000 visitors on our website. Like that's not the largest one. Actual largest was React. It was 15,000, but this is 11,000 of people who are software architect now, or dream to be software
My
architect
favorite.
person. Yeah.
I
Yeah.
thought
Okay.
actually.
Ria, probably I'll leave this stage if you don't mind. The floor is yours.
Thank you so much and have a nice day. And I wish everyone to get a lot of excitement from today. Thank you so much for joining today's our World Software Architecture Summit, which is a 2-day delve into cloud efficiency metrics, including performance, sustainability, vulnerability, observability, costs, time, maintainability, which are the key actually to successful architecture designing. So stay with us because a lot of interesting presentation are waiting. And also, before I would not forget, and I think that you already heard like partially this information, but I want to clarify once again. Everyone who has started watching our Today Worldwide Architecture Summit, Software Architecture Summit, I'm sorry, you have the opportunity right now because you're already like the part of our very big community. You have actually right now the chance to get one of free tickets for one of your future events, which I'm sure that you really love, and I'm sure you'll be really excited. So I'm happy to announce that today you have the possibility to get a chance to win a ticket for the upcoming Geekle event at your choice, which I think is just amazing. So very important for this, you need to be active. Please be active and write your questions to our speakers in the comments. Use hashtag question for ticket. Definitely. And I'll definitely right now also drop it in a comment section. So please have a look. And at the end of the summit, we will randomly choose 5 lucky winners to provide you with a ticket. So be active and let the luck be on your side. So let me just drop this line in your comment section. Please have a look. And I'm sure that you'll be also pretty excited. I am also today really excited to have our guest today, Alexander Kuttig. Alexander, really happy to have you here. Just an amazing, interesting, actually, you're starting, by the way, our today's conference, our today's summit, within the block of non-functional requirement, so-called such is called the block. But also really exciting, what is the topic of your speech, which is like, yeah, if I'm not mistaken, today you'll be talking about how to use Amazon Web Services and Google Cloud in a cost-efficient way. So I'll tell you, like, Alexander, let me just first of all welcome you here. How are you today?
Well, first of all, thanks for the kind introduction, and thanks for having me. I hope everyone can hear me fine. I'm really fine today. I think it's a great conference. I think it's a great idea to have this kind of architecture summit, and I'm really happy to be here today. And so yeah, thanks for having me.
Thank you so much. And by the way, a few words. We actually met with Alexander at one of our previous events, which was on React Native and Flutter.
Right.
and Mobile Development Summit in the future. But also, I want to say, and I probably didn't mention it previously, but actually, if we have a look at also like partially at your bio, you can also see that it's pretty impressive because you already you founded your first software company in 2012, and you're focused specifically on cloud architectures and cross-platform apps. So you have already like I think that even like despite apart from founding your own company, you already had like huge experience, and moreover, you are a certified Amazon Web Solution Architect professional since 2019, and he's also developing and maintaining cloud backends with millions of sessions every month. Honestly, I think nobody else but you could actually provide this kind of presentations. I'm really lucky, and we're really happy that you are here today with us. Share what is your mood today. What is like a few words about your presentations, and what our viewers should expect.
Yeah, well, thanks again for the very kind introduction. So for me, I thought a lot about how to build scalable products in a very cost efficient way, because with my company we work a lot in the startup environment, and there you always have this task to have very low costs in the beginning, but on the other hand, be able to scale very fast and also scale very cost efficient. And I always, when I'm browsing the internet, I always read such articles like, oh, well, these things like AWS, Google Cloud, Firebase are very, very cheap at the beginning, but they used to be very expensive when you scale. And every time I read such things, I'm like, well, no, that's not the whole story, because if you do it in the right way, they can also be very cost efficient when you scale. And the idea of this talk is to show what we are doing. I have a real world example of an application we have right now at our company, which is kind of in the scaling phase. And well, we are at least now we are very cost efficient, and I would like to show to you today.
Thank you so much, Alexander. The floor is yours. And I just want to reminder to our audience that today you have the greatest opportunity to win one of the free tickets at your choice for one of the future Geekle events. So please prepare your questions, or definitely you can prepare them now. Listen to Alexander very carefully, but you will be able to ask him this question directly during our Q&A. So Alexander, the floor is yours. See you a bit later.
Well, then thanks again, and welcome from my side. If you have any questions, we have the Q&A, so I'm looking forward to answer your questions. But let me start. As I said, I want to show you all the things I want to show you on a real world example. And this is our sport and fitness app. It's called TeamFit. We have it here at the moment. And it's basically kind of in the scaling phase right now. So it was a product we had for some time. And during the, let's call it lockdown phase, it's gotten pretty popular here in Germany, and the numbers are growing very rapidly. So I prepared this presentation, I think, a week ago, and the numbers are already outdated. So we have around 100K monthly active users, and the other numbers were growing in the same range. I think we have 2.5 million app opens a month at the moment. And we are running on Google Cloud, so the availability is pretty good, I would say. I don't think we had any outages until now, but I stated the availability with 99.9999% here, because that's definitely the case. The interesting thing is all these numbers we only have all-in backend costs, and that's all we have at costs for things like traffic, databases, storage, authentication systems, security, and things like that. And we have all in backend costs, which are below 100 euro a month. And I think that's a pretty good good value for us. I think we had 40 euro last month, and we will be at around 100 euro this month. And well, since we are in the scaling phase right now, it's a good example for the talk I want to give today. I want to simplify our application a little bit for this talk, because on a simplified example, you can better explain things like, I mean, all things. Basically, it's a pretty simple app. So we have users and we have exercise videos, and the users can download and view exercise videos. They are combined to workouts, and then the users can do the workouts. In a real world scenario, it's a bit more complex, but this simplified example should do for our case here. But before we start, let me just introduce myself very briefly. I've gotten this amazing introduction from the Geekle team here, but as they stated, I founded my own software company back in 2012. I would call myself a solution architect since 2014, because since then I'm really doing solution architecture on a bigger scale, I would say. I'm working with Google Cloud and AWS since 2016. I'm a certified AWS solution architect, and I try to write regularly on my Medium blog. So if you want, you can follow me there. I'm working at Horizon Alpha. It's my own company, which I founded back in 2012. We're based in Munich. We recently hired some guys, so I think we're 28 people right now. We focus mainly on app and web development based on React Native, things like that, but always with cloud-based backends, and that's where the cloud experience comes from. So we always have to build cloud backends which can scale very fast. And basically, that is what I want to show you today. What's the process? How do we do such cloud-based backends? What questions do we ask us? And maybe some of you guys can take something of this away from this talk to, well, build your own cloud-based backends or cloud-based applications. So basically, this is our process. What we are doing when we plan a scalable application. So first of all, we have to analyze the requirements. And when I'm talking about analyzing requirements, I always mean what in my application will scale. I will talk more about this in detail later. Then we have to look at the available services. So when designing a cloud-based backend or a cloud architecture, it's all about services. Which provider gives me which services do fit my requirements? And this is a very important question, because choosing the wrong service or not the optimal service can produce a lot of costs. Then it's about creating the real application architecture. So how is my data flow? What parts does my application really need? And how should my application scale? Last thing, not really the last thing. So I think at least the last 3 steps here, you can't do them one after another, but you have to look at all of the 3 steps at one time. Because they pretty much rely on each other. So choosing if you have a database design for a NoSQL for a NoSQL database, you have to choose a service which gives you a NoSQL database, right? So they kind of refer to each other. But designing your database is really, really crucial to be able to be cost efficient. So that's basically the 4 things we do when we plan a scalable application. And what I want to do in the next, I think, 15 to 20 minutes is to look at these 4 steps with you and to give you kind of questions you could ask yourself in these steps to get kind of a cost-efficient application. So when we do analyze our requirements, we have basically 3 different things we have to do here. So what we do is we imagine the best case scenario. Best case scenario means, okay, we want to be able to serve 2 million users at the same time, or we want to have 20 million users or monthly active users, and we have to be able to serve them, and we have to be able to serve them in a cost-efficient way. What we then do is we identify the metrics which will scale in this scenario. I will show you on our example one slide later what I mean with that. And then we look at what would that scenario mean for all parts of our application. That's step 3, creating application architecture. So what would that best case scenario mean, and what would these scaling metrics mean for the parts of our application? So let's have a look at our simplified examples. So we have this users, and the users, what we basically did here was we had best case, worst case, and we call it normal case, where we looked at different scenarios and wanted to calculate which metrics will scale and what would that mean for us. So as you can see here, we have on the left upper side the exercise video storage, which we have to store somewhere in the cloud. So I will tell you later what we exactly do there, but we use Google Cloud Storage here. And as you can see, even in the best case scenario, we would grow from, I think, 100 exercise videos to 350 exercise videos, because we don't need that much exercise videos. I think 350 exercise videos, even in the best case, is pretty cool to have in that kind of training application or exercise workout application. So this is not a problem for us, because storing 350 videos is, I think, in all cloud providers, it doesn't cost anything, because they have this free tiers. So this metric is not a problem for us. What is a problem for us are the users, because the users are the metric which grow kind of exponentially, and that basically is what we're seeing right now. So we're lucky the application got pretty viral here in Germany. So we are growing kind of exponentially. We're at, I think, between T4 and T5 at the moment, and we're on track in the best case. So yeah, we have to serve a lot of users. And when we now look at the metric of exercise videos traffic, this metric also scales in a exponential way, because the more users downloading more videos means we have a lot of traffic. So when we look again at our simplified example, we see here the video storage is no problem. The users will grow a lot, and we have to store kind of user information, user data, also user statistics and things like that. So here we have to think about much more in detail how we do this than on this side. And this is the traffic. So we also have to think about where can we store the videos, and from where can we load the videos to in a cost efficient way. So you see, we kind of categorize which parts of our application we should look in more detail to be cost efficient than others. So basically, that's the first step for us. So now that we know which parts of our application are, we have to look in more detail, or which are kind of crucial for our costs, we have to choose the right services. And first of all, we have to think about what services are available for my application. Which part of services fit for my requirements. Then we have to look at which services produce which costs in the scaling scenarios. And last thing we always ask ourselves is, how much do we want to do by ourselves? So you have very different services in the level of how much is managed by the cloud providers. So for us, in the most cases, we want to do at less as possible, or have to be as much as possible done by the cloud provider. But you have to keep in mind that basically for all things you let the cloud provider do, the cloud provider will make you pay. So regarding the second question, which services produce which costs in scaling scenarios, it's very interesting to think about what basically are the cost factors when you go to a cloud environment. And basically, I think it's storage, it's traffic, and it's compute power. So it would be a good idea to build kind of an application which optimizes regarding this three factors. So to have as less compute power as possible, to have as less traffic as possible, and to have as less storage as possible, because these are the things which produce costs for the cloud provider. So the cloud provider will make you pay for that. As I stated on the bottom of the slide here, basically you can say the more the service is managed, the more expensive it is. So when you look at different services, as I said, you have different levels of what is done by the cloud provider and what is done by you. And the more which is done by the cloud provider, the more expensive the service is. So when we look at our example, we had a lot of different services which we could have used. So basically, on the right-hand side, you see the symbols of AWS. On the left-hand side, you see the Google Cloud symbols. There are also the services available on MS Azure. Basically, they all offer you kind of the I don't want to say the same services, but you can do everything on all of these platforms. So it's basically more kind of different details, and you have to look in details at the services which fit your requirements the most. So in our case, we wanted to have a fully managed environment. So there are some services which we could filter out because we would have to look after a lot of things by our own. So when you think about AWS EC2 instances, you have to think on your own how to scale, when do I want to add another machine. I have to care about load balancing and things like that. We didn't want to do that. So we wanted a fully managed environment because, as I stated before, thinking about what do you want to do on your own is very crucial for cost efficiency also, because costs not only occur on the cloud provider side, but also on your own side. So when you have to hire an administrator, which administrates your environment, that also produces costs for you, right? So in our case, it was much cheaper to say, okay, please, Amazon or Google, please do the administration for us, and do it very efficient, so much more efficient than we ever could do it. So maybe we can save some more money there, because you do it as efficient as you can. So back to our example, we had to look at which of these services we wanted to use, and we decided to go on the Google stack. Basically, we use the Firestore database, we use the Firebase authentication system, we decided to use the Google Cloud Functions, and we decided to use the cloud storage on the Google side. It's basically a full Google setup, and it's basically it's called Firebase suite, where you have all these things included in one kind of backend, and it's very comfortable for us. But basically, you could do and could combine things of different cloud providers, right? So we've done this in other projects. So basically, we have the same setup, but we don't use the Google Cloud storage, but we use Amazon S3 for storage, because I think it's 1 cent less in gigabyte traffic or things like that. But for our case, we said, okay, let's in the first place go with the full Google setup. So now that we decided which services we wanted to use, we thought about creating our application architecture. And again, it's not one step after another, but it's kind of thinking and rethinking all these 3 steps again and again. Because when creating your application architecture, you have to ask yourself, what should your data flow be like? So how should your data come from, basically in most cases outside of your database, to the user? What you also should think about, especially when doing native apps, but also when doing web applications, is when do you need to load which data? Again, try to use as less traffic as possible, because traffic costs you money. Third question is, what do you really need in your setup? And this is a very important question. I will show you later what I mean with this. Fourth question, I think that could be an own talk here. How do you ensure security? I will not tell you about this in detail, because I think it's a very large topic, and I only have 30 minutes today. But you should keep in mind that you have to ensure security on your cloud backend or your cloud application. So I again want to use my real world example to show you what I mean with this 3 questions. Basically, this is our setup. So we have our application, see it on the left, and we have this Firebase authentication system. And the cool thing in the Firebase and Google setup here is that basically the cloud storage and the Firestore are kind of connected to this Firebase auth system. So in these cases, we don't have to have kind of a backend which with API or kind of server-side code. We could read and write directly to the cloud storage and the Firestore with the Firebase SDK, and have security via the Firebase auth system. And we decided to do so for the reads, because for our read operations, which basically are much more than our write operations, we thought about, do we really need some kind of processing of the data or of the assets we get from the cloud storage and pass it through some kind of backend, or could we just go directly from the application to the storage and the Firestore database? And we thought, well, okay, when we can ensure security for the reads, it's pretty fine for us to do so. And that basically saves us a lot of money because we don't have to pay for the compute power for every read operation. So when thinking about how much operations we do directly on Firestore and the cloud storage, we would have millions of requests which we would have to pay for when having this kind of cloud functions backend also for the read operations. We decided to have that backend for our write operations, because when you have native applications, you kind of have the problem that when you have some bugs in there, it's kind of a long time thing to fix these bugs, because all your users have to update to the new version. And we said, okay, it's not a problem for the read operations, but when we have some kind of a write operation in the application and we write to the wrong place, or we write bad things directly in our database, that's nothing we want to have out there for, I think, 6 months. We want to be able to fix this bug as soon as possible. So we said, okay, for the write operations, we want to have this cloud functions backend. And also in our case, it's very cool to have this backend for the write operations, because I will show you on the database design step later. We have to write to different locations in our database at the same time, and that's easier to ensure when you have kind of a backend. Second thing about the application design is we have to think when we want to load data, and what comes with this. We have to ensure that we have a good caching mechanism, because again, we have to ensure that we use less traffic as possible. And what we did here was, first of all, in the first version of our application, we had no caching at all. So we just streamed the videos every time the user wanted to look at one. And then we calculated for this scaling scenario, and we said, well, okay, we can't do that, because we would have terabytes and terabytes of traffic. And second thought was, we store or download all videos right at the beginning of the application. That would decrease the traffic a lot, but we even had a better idea. We just download the videos when the user wants to watch and store them on demand. So store them when the user has watched the video. Basically, it's kind of, I would say intuitive to do it like that, but I wanted to show you how big the difference is if we use a good caching mechanism and a good idea when to load the data. Because even in the second with the second idea here, we would have double the costs from what we are doing now. So again, think about when to load your data. So last thing here, database design. It's very interesting when having applications with a lot of users or with a lot of operations to have a good database design. And you should ask yourself, what information do you have to write a lot? What information do you have to read a lot? How, do you have to write more? Do you have to read more? In our case, we have to read a lot more, than writing information. And the third question is, how is the information connected? So in our case, we basically have to store information which isn't really that connected. So we don't have to do some kind of complex queries on it. We just have to write it and read it. And that's basically our case. So I have some tips here. First of all is when you have applications with a lot of users, when you have applications that have scaling metrics regarding the users, don't be afraid to use NoSQL database solutions. I know it's pretty hard to deal with in the beginning, but for us, it's really saving a lot of money. When using this NoSQL database solutions, don't be afraid to duplicate data. I know it's something you shouldn't do on a MySQL or a SQL database, but it's totally fine to do it in this NoSQL scenarios. Sure, you have to ensure with your business logic that your data is kind of consistent. Last tip, don't be afraid to use different database solutions. So in our case, we use, for example, a NoSQL database for our users, but we have to do some reports. Yeah, Maria, I'm nearly done. I think I have 2 more slides.
Yeah, sure. I'm just like,
okay.
Maybe it's a sign to wrap up, but yeah, definitely, like, please proceed.
Okay,
I'm listening.
Cool. Okay, cool. Well, again, in our case, we use kind of a NoSQL database solution for the end users, and we also use kind of a MySQL database where we copy some data and run some analytics queries on it, or you can do it in some data warehouse. So how does it work with duplicate data? So basically, in our example, we have users, and what I didn't mention is the users can team up, so they can found teams and work out together in teams. So when a user does a workout, it is stored at his user node or user document, but it's also stored in the Teams document, because what we want to achieve is that we can read just the document. So when we want to read, and we read a lot more than we write into our database, we just want to read the team with this team ID and say, okay, give me the list of done workouts, and we can do it because we write on different nodes. And again, that saves us a lot of money because we don't have to do any complex calculations on the database. So last slide, it's an important tip at the end. You have to stay up to date with the services the cloud providers offer, because if you don't know which are the services that fit best to your requirements. So that's my absolute tip. There are a lot of good podcasts, newsletters, and things like that, which wrap up the development on the different cloud providers. So stay up to date with the services the cloud providers offer. Thanks for listening.
Thank you so much, Alexander. And once again, give it up to the CEO, founder, and developer at Horizon Alpha. Thank you so much, Alexander. By the way, you still have the opportunity to ask Alexander questions directly, and I can see that you already are really active according to our Q&A session already in PineTool platform, in StreamYard, but also please remember that if, for example, because when the session is gone, the questions might be gone. So please prepare them as well for our Q&A specific session. But also, you're very correct when you're also using the hashtag question for ticket, but it's really good. And also, I want to tell you that additional announcement, please, at the Q&A session, when you have like specific question, for example, to Alexander, please notify that this question is to Alexander, apart from hashtag. So thank you so much, Alexander, once again. We'll see you a bit later. So please join us definitely. And thank you so much for the great presentation.
Well, thanks for having me, and see you later.
See you very soon. Meanwhile, guys, folks, we are moving forward because like we still have within this block of presentations 2 additional great speakers, and I'm sure that you'll be really excited to right now to find out about 1 million requests in 10 minutes. I may say that the topic sounds intriguing, and in this case, it will be presented by Ivan Rigoni. Hi, Ivan, how do you do today?
Hello, everyone. Hello, Maria. Yeah, I'm good. Thank you.
I can see that you're very excited today, obviously.
Absolutely, I am.
Here, Ivan is actually solutions architect at DAZN, and actually, if we just have a glimpse at his bio, we also can see that he's very Italian from the Alps. This is I really like actually working in IT since the year 2000, and he worked on his knowledge from the dawn of internet to e-commerce, IoT, and new sports streaming, landing Ivan in London in 2008, where he lives ever since. And when he doesn't work, he has long runs with his Labrador. Is it Golden Retriever? And
Yes.
he's awesome, and he's helping his daughter with the coding projects. So also helping to raise like new generations of coders.
Hopefully.
Yeah, thank you so much, Ivan. The floor is yours, and please remember that you have the possibility to prepare your questions for Ivan. Prepare it for Q&A session. Whenever you're ready with your presentation, we're ready to share the screen. And also, as I told you, and also very important, if, for example, at some point in your Q&A during Q&A session, we won't have the time to ask all of your questions, which you asked with hash question for a ticket. But remember that every question counts. We'll try to ask all of them, but please also remember that you should directly ask, in this case, address this question to the specific speaker. So Ivan, the floor is yours. See you a bit later.
Thank you, Maria. As already mentioned, I'm Ivan Rigoni, Solutions Architect at DAZN, and I'm going to talk to you about 1 million requests in 10 minutes, a topic that sounds exciting, isn't it? So if you're interested, then follow me. DAZN is a sports streaming service that lets fans watch their favorite sport over the internet, their way, live or later, and at a fixed price. And we operate in over 200 countries. The title of today's presentation comes from an interview question that I used to ask to candidates for the position of principal engineer or solutions architect. That is only the start of the question. Let me introduce you to the full question. So the full question context is the following. So you have a monolith piece of software that runs both your backend and the front end of your application, of your system. This monolith is interfaced to third-party platforms to take payments and to create subscription by means of transactional calls. So you have synchronous calls to these third parties to perform something like taking a payment and creating a subscription, as mentioned. You have a non-functional requirement stating that users are signing up at the rate of 1,600 a second with peaks of 3,000. But more important is a business requirement that says that DAZN's core business are live sport events. So we have to ensure that our users can access our systems seamlessly and can watch the live event now, not being bothered by sign-up procedure. The implications of all of that are, first, for the first point is that with a monolith, you can only scale horizontally to add capacity, so adding instances of your service. The fact that the calls are transactional, so point number 2, means that the slowest system in the chain is the one that determines the overall speed of your system. That is, if your monolith can support 3,000, 4,000 transactions per second, but the payment platform only 1,000 and the subscription platform only 20 transactions per second, the overall speed of your system would be 20 transactions per second maximum. This, of course, clashes with your non-functional requirements, stating that you have to support 1,600 sign-ups per second with peaks of 3,000. You see that there's something not working here. And the last one states that whatever the known video failure of your system, the priority is to ensure that the users can enjoy the live content they are signing up for now, straight away. Visually, I can illustrate that with the sequence diagram you see on the right-hand side of this slide, where a user is approaching DAZN and signing up for. So in the first point, they submit their details, name, surname, password, whatever. And the sign-up endpoints responds requesting now the payment details. Once the user has filled in the form, this is posted to the subscribe endpoint, and the subscribe endpoint makes a call to the third-party platform, the payment platform, to take the payment from the card. Once this is done successfully, we have all the elements to create a subscription. So we make another call to the subscription platform, and we create the subscription. All done, great. So we can issue a token to the user, and the token can authorize the user to access our platform and play back the live content. Now, this approach has pros and cons. So the pros are the scaling, as I mentioned earlier, very easy, add instances and you scale up. System interactions are straightforward, everything is linear, sequential, you have no race conditions, so no complications in the interactions. However, let's say, from the efficiency perspective, you can't scale up only what is under stress in your system. So you have to scale up everything, possibly ending up in a waste of resources and high cost. From a security perspective, you load the entire code base in memory. It's a single monolith, right? So that means that all the code can access all the resources, database handles, encryption keys. So whatever you need, basically, to access third-party systems, and is shared by the entire code base. That means that if anybody can compromise your monolith, everything is compromised. So from the velocity perspective, the fact that you have a monolith with millions of lines of code, every time you make a change, you have to regression test the entire system. So let's say to make the release more efficient, you tend to group more changes into the single release, making them risky and causing also painful rollbacks if anything goes wrong, because if something in your release package is incorrect, you have to roll back everything, not only the change that caused the failure. From a maintenance perspective, you have a single code base, so you are most of the time restricted to a single technology and single language, thus hampering innovation, and it's a constraint that many engineers don't want. And again, from a performance perspective, if one endpoint is under stress, so is your entire monolith. What am I expecting from, let's say, a candidate response? One option could be the following that I'm illustrating now, is actually the more common. So the first thing you can do to your system is replacing synchronous call with asynchronous ones and queues at the integration points. This is to decouple the speed of the caller from the speed of the external system. That doesn't come for free, I'm afraid, because you have to introduce eventual consistency anywhere possible. So that is the result of the CAP theorem. This is not a presentation, I'm afraid, about the CAP theorem. I'm supplying a link in the slide if you want to have a look at what it means. But basically here we are compromising on availability. Therefore, we need to compromise also on consistency and aim for eventual consistency rather than continuous consistency. Third thing we can do is breaking the monolith. Of course, microservices, first thing that comes to mind. Fourth thing, given we introduced microservices, or at least we've broken down the monolith in multiple modules, the system becomes more complex, failures become more frequent, there is network traffic between the services that can cause additional failures, so you have to design for failure. So let's have a look. Point number one, how we can implement it. 1 and 2, actually, applying eventual consistency. So we can interpose between our monolith and the payment platform a payment facade that decouples the monolith communication with the external system, and replace the take payment call with a pre-authorization call. I will tell you in a bit the difference. We can also interpose between the backend monolith and the subscription platform a subscription queue. So for every subscription we just push a message to the queue. So how does it work? Let's switch to the right-hand side of the diagram, which is the sequence diagram. Once the user submits the card details, now we don't take the payment. We create a pre-authorization call that validates the payment details and ensures that the user has funds in their card, but we do it via the payment facade. So the payment endpoint calls the payment facade. The facade has all the details to call the third-party platform, retrieves success or failure. Let's assume it's a success. Once this is done, we can push a notification to the subscription queue saying, yay, the user has signed up, they have submitted the details and they're valid, so we are 80-90% confident that everything is correct, so we can also create the subscription. So now we can issue the token to the user so that they can actually play back the content. In the meanwhile, behind the scenes, whilst the user is enjoying the live sport event, we pick up a message from a notification from the subscription queue. We attempt to take the payment from the user via the payment platform. If this is successful, then we create the subscription, taking all the time we need to do it. If this goes wrong, then we revoke the user's token and we say, sorry, you can't access the platform any longer. Something went wrong, your payment details were wrong, fraudulent, whatever happened. What are the benefits of this arrangement? So first one, the monolith becomes independent from the third-party platform performance, so we can go faster. Performance, we can optimistically accept a sign-up. That's what I illustrated, the change in arrangement. So first, we do a pre-authorization, just validate the payment details. We don't bother with the long transaction to take the payment and create the subscription. Maintainability, facades, they are nice because they allow to replace the third-party platform easily, shielding the monolith from the changes. And then they also established a single entry and exit point for all our network traffic so that we can better monitor what is happening, improving observability, really important. Security-wise, only now the facades have the encryption key to access the third-party platform, certificates, whatever it is. So this kind of information is not shared across the monolith. If the monolith is compromised, our facade can be safe. And now our monolith can go much faster, of course, because it doesn't have to wait for the subscription platform to create the subscription. Users are happier, of course. Now we want to break down the monolith. However, before doing that, we want to remember the Conway law, which states, reading literally, organizations which designs systems are constrained to produce designs which are copies of the communication structures of this organization. This means that the interfaces in your system will be copies of the interfaces within your organization, across your teams. This can be a bad thing if your organization is not structured correctly. So the best thing to do is invert in the Conway law and use it to your advantage. So what you can do is literally design your organization the way you want your system to be designed. What did we do at DAZN? So we created a developer experience unit, organizational unit, which is in charge of supplying tools like command line tools, like CI/CD pipelines and deployment dashboard, relieving the engineers from this burden of maintenance of the tools. We designed the boundaries of our system, how it was supposed to be realized architecturally. So domain-driven design applied to our software, so divided our software into browsing experience, playback, payment, subscription, living room experience, and so on. Once we've done that, we apply the inverse Conway law. So we create a team for each one of these organizational boundaries. And finally, we've been agile in applying agile. We left to the engineering teams to decide how they wanted to operate. Do they want to use Kanban? Do you want to use Scrum? Both, whatever. Our agile coaches are there to help. So now we have our organization ready to, let's say, start the work on microservices. This is what happens basically in a nutshell. So you take your backend monolith and divide it into several modules of microservices, as you like. And the front end also can be split into multiple responsibility areas, the micro front ends, the same way you would deploy microservices. So benefits of this approach of splitting down in microservices. So resiliency and availability. You have massively reduced blast radius if one service fails. You don't have everything taken down by a single service if you design, of course, things correctly. That's the caveat. And then you can also apply different service level objectives for different types of service. Performance-wise, you have granularity of scaling, so you can scale up to multiple, to dozens of instances of your sign-up endpoint, which is supposed to accept multiple sign-ups, but maybe your retrieve password or forget password endpoint doesn't have that much traffic, so it doesn't need to be scaled up that much. Maybe 2 or 3 instances are enough. So that gives you more efficient use of resources and money as well. Velocity-wise, you can release multiple times a day for each single service or micro front end, and that paves the way to perform more testing, more user testing, changing a little bit, I don't know, the browsing experience and see how users react, expose some other users to a different way of playback. So this is multivariate testing. The fact that you can deploy multiple times a day enable these kind of things, which has a lot of benefit. And from a maintainability perspective, each team can decide what language and technologies to use among approved ones. Of course, I mentioned developer experience unit is in charge of providing the tooling. So each language carries tooling with itself, and we cannot provide tooling for everything. But of course, we can supply a wider range of tools, given that each service can be implemented with different technologies. Security-wise, you have maximum granularity of security policy on a service by service basis, on a micro front end by micro front end basis. And you can embed, having smaller code to handle, you can embed security in your software development life cycle. It's not that easy, though. There is a big decision to take. Do we aim for feature parity first? So create our new platform in microservices and micro front end, re-implementing the same interfaces, or do we apply greenfield development? So redesign the system from scratch, forgetting entirely about what we had before. So let's see what the 2 approaches mean. So if you go for greenfield, you create an entire new system in parallel to the old one, to the legacy development environment. And you evolve both until the new one is ready and you perform the switchover. This might take a while. With the feature parity first, what you do is taking a small portion of your legacy environment, such example again, the sign-up endpoint, and you replace it with new software, only that endpoint, and you start driving traffic to the new endpoint. switching off the old one, and you repeat the exercise for each of the endpoints until the legacy environment doesn't receive any traffic at all, and you can switch it off. This is called the Strangler pattern. It has some benefits, though, because you expose your software, your new software, early to production. At DAZN, we had an additional constraint posed by smart TV set-top boxes, and similar mobiles. Alexander before mentioned also this issue that you have longer release cycles for, let's say, these kind of platforms, so you cannot change that frequently the front end of your application. So we had actually to aim for feature parity first. So first, replace the backend, exposing the same interfaces as the old legacy environment, and then also evolve also the front end, because it takes longer to release and expose to the users. The Strangler pattern I mentioned works this way. So you place proxy router between your legacy environment and the front end of your application. This allows you to route a portion of your traffic to the new software. Seeing how it reacts, if it works well, you add more and more traffic to the new software until it reaches 100%. In the meanwhile, you drain traffic from the legacy environment until it reaches 0%. You strangle the legacy environment. That's why it's called legacy. It's called the Strangler pattern. And then you eliminate the old environment. We also applied other patterns in order to evolve. One thing we chosen is a push-based approach rather than pull. So when you have millions of users accessing a REST endpoint, either it crashes if it doesn't support those numbers of users, or you are anyway exposed to unpredictable request patterns that is pretty inefficient if these, let's say, clients are polling repeatedly for information to have it quicker. So the best way to do is to serve them the information when these become available, so you are in full control of pushing the information to your customers. And this is what our PubBee internal product does. It broadcasts messages to millions of clients via WebSockets. It is more efficient, smaller architecture, and can support millions of concurrent users. Another pattern we preferred to use was message-driven design. So the core of this pattern is pretty much having a loose coupling between producers of information and consumer of information. Producers don't know about consumers, they just push a message, and consumers can be multiple, and they know what to do with the information and how to proceed with that processing. This particular architecture you see on the screen is our external system event service that is in charge of receiving notification about your changes to your subscription and then processing it. As you know, when you handle a subscription through the mobile platform, Google Play, rather than Apple App Store, rather than Roku, you're not in control of the subscription. It happens, let's say, the user makes changes on those platforms. So what we can do is receive a notification from these platforms that the user want to change their subscription, upgrade, cancel, pause, whatever they want to do. We receive different messages for these from different platforms in different formats. Some serve you a real-time notification, other expose REST endpoint. What we do is unifying these messages and normalize in a single format, augment the message with additional information about the user, about the subscription, and then we route the message via, in this case, AWS Event Bridge to different endpoint, applying some rules. So if the message contains, let's say, a request for cancellation, then we route it to the cancellation endpoint. Otherwise, we route it elsewhere. So This is the approach we followed. All of I described and much more allowed us to acquire as many subscribers in our first 18 months of life as Netflix did in 5 years, which is a no mean feat. We learned a lot of lessons along the way, and I'll try to be quick, not to bore you, but there are a couple that are really important to know. First one, monoliths are fine in the right context. So if you start like DAZN did in 2016 as a startup with a handful of employees, you are faced with a big decision. Do we buy the software we need to prove that there is a market for OTT, live and catch-up sport events? Or do we build the software to create such a platform and support millions of users? There's a big difference. If you buy and go out on the market, you choose your the most suitable products, you stitch them together, and you create, let's say, an interaction of monoliths, if you like. And then you have, however, a quicker time to market because you can test your hypothesis. In this case, is that there is a demand for OTT live and catch-up sport events at a fixed monthly price. That was our business hypothesis. And we take early feedback from our users and build competitive advantage with the time saved. In the meantime, we recruit engineers for the scale-up phase and structure the company for it, and then we refactor and scale up. If you go for build instead, first you hire the engineers, which is a lengthy process. You design your overall system that will support tens of millions of users, but you might risk big. You might risk to build a system for tens of millions of users that might never materialize on your platform. Second lesson, architecture are not created, they emerge. So you have basically to agree and don't impose on architecture. If you create an architecture, an architecture which is created is promised by a date. It is created by the architect with no interaction with the expert of the areas, the engineers. Result in tension because the engineers, they want to have a say, of course, in how things are built, but they don't know the context because they haven't been told. So they don't know about, they don't know much about why some decisions have been taken. And the result, of course, is stress of the architect that has to do all the architectural work and talk to many people in order to get it done. And the product owner is in wait for the architecture to be completed before starting the development process. This is a waterfall process in many ways. Emerged architectures instead are the result of multiple discussions early in the process with the engineers, with all the stakeholders. Engineers participate to the decision process, contributing and raising questions, preparing different options from the one that the architect has thought about. So they foster diversity of opinion, enable better decision-making, and allow for delegation of low-level design tasks, because now we have engineers that are aware of the bigger picture, are aware of decision to be taken, so they can take on board some architectural work, low-level design, so that the solutions architect can focus on a sound, high-level solution and talking to the stakeholders, which is time-consuming, I'm telling you. And this is more, let's say, suitable to an agile architecture, an architecture that moves in time. 3, I'll skip over it, but be aware that you never have to start without an agreed MVP. So you have to test the hypothesis, your business hypothesis you go for. That's the most important thing to do when you approach a project. 4, requirements, really important. An architect never has to figure out requirements. Always ask the right questions to surface the requirements. And be patient. Finally, most importantly, document the key decisions with architecture decision records. There are documents that you store in a version system like Git or Confluence because they can change over time. You have a status, a context where the decision is taken, forces driving the decision, the options, the decision taken, and the rationale. Who devised this method is Michael Nygaard in 2011 in a blog post that I linked in this slide. And he's famous for his released book that I really recommend to read if you haven't yet. And this is DAZN, how it appears now. I have another couple of recommendations. Microfrontends, a book by Luca Mazzalira, if you want to know more about this topic. And the Lean Startup, really important because it talks about startups, MVP, testing the hypothesis, all stuff that an architect should, approach. Many thanks for listening to me.
Thank you so much, Ivan, for your presentation. I'm sure that there will be a lot of questions about the topic you just mentioned as well at the end. And you will have the possibility actually to ask questions, Ivan as well, at the end of our session. But also please remember at the end of this block, because very, very soon we're moving to Q&A. But please also remember every time, please address the name. So I would now definitely that you're addressing this specific person, our specific speaker. And also don't forget about hashtag question for the ticket. Be active, and of course you'll be rewarded for that. Ivan, thank you so much. We'll see you very soon, and don't disappear, of course. And a lot of interesting presentations are waiting for you in the future, in this block and in the future block. But also let me just introduce you right now, and please welcome Rohit Bhardwaj, who is today as Senior Architect at Salesforce, and he'll tell you more about resilient cloud architecture design patterns. I'll tell you a few words, because if you have a look at the bio of Rohit, it's just pretty amazing. So honestly, I'm really nicely impressed. Sometimes I'm even shocked with some of the bios, but for the time being, with almost all of the bios of our speakers, because Rohit, right now, as I mentioned, is already a senior architect at Salesforce. He has extensive experience in architecting multi-tenant cloud-native solutions for enterprise customers. Rohit has proven ability in designing solutions and executing and delivering transformational programs that reduce costs and increase efficiencies. And actually, I think we can take a lot of time to read about Rohit, but also a very important thing, which I wanted to, if we have a look at his experience. But one very important thing, Rohit, that he has done MBA from Barson College in Corporate Entrepreneurship, Masters in Computer Science from Boston University and Harvard University. Rohit is a regular speaker at No Fluff, Just Stuff, UberConf, ReachWeb, GIDC, and other international conferences. Rohit, really impressive. Thank you so much for joining us. How are you today?
Awesome. Are you guys able to hear me?
Yeah, of course. And honestly, I'm already, as I told you, I'm already excited about the bios which I read today about our speakers and yesterday as well. But also, I'm really excited to listen to your presentations, because I'm sure there are a lot of interesting experience you have to share and a lot of knowledge to share. So also, our dear audience, be active and prepare questions for Rohit, because not only will you know all of he will share more of his knowledge during our Q&A, but also you'll be able to win a ticket. So Rohit, the floor is yours. Thank you so much, and see you very soon.
All right, guys. So excited to talk to you guys. So first of all, welcome everyone. So today's talk is on resilient cloud architecture. So when we say resiliency, the important part is like anything you're building, you build the resiliency on top of it. So I'll discuss 9 specific things on it. So that said, I'm being a hands-on architect at Salesforce. And if you want to follow me, you can either follow me on the LinkedIn or on my website, productivecloudinnovation.com. So those are the 2 main places I suggest, you look at. So these are the 9 different areas we're going to embark our journey on today. So, and I'll take one at a time about it. The first one here is the fail point. So when we say fail point, everyone tries to build a software and then say, hey, there would not be any failure. So I consider the failures are the best friends we have for an architect. So when I'm building my software, the architecture that needs to build failure into account. So let's talk about the first thing, the use cases. Now we all know that, hey, what is the real need for my software? Why somebody will buy it? That is the real question. So Uber had the same thing. Uber looked at it, and what they did was they created an application, the modular application they built on top of it. Ultimately, they had users, trips, payments, products, and other things like that. Based on these, you find out how your customer is thinking at any given time. When we need Uber, what are we thinking about? Which situation are we in? What are we hearing? What are the pain points of our user? So these are very critical things to know. Does driver has any pain points? Does the passenger has any pain points? So we find out those two things. And once we find out, then we basically draw the use case. Now, as you can see, there's a driver use case when they're accepting a passenger, and there is a driver use case, driver is picking up the passenger. There is very much possibility that any of these use cases can break. So what I consider them as a golden nugget. Golden nugget means that this is where the system can break. Now this is a great opportunity for us to apply resilience architecture. So how about we increase our efficiency by texting the person, or texting the person, hey, how about you come to a location? You save the money, and also the driver saves the money. So those things also are really critical while building a software. Now that said, one of the key part which I always think about is Albert Einstein. If I had an hour to solve a problem, I did spend 55 minutes thinking about the problem and 5 minutes thinking about solutions. So what we normally do is, like, whenever we get a problem, we just start to come up with a solution for the problem. So this is what I suggest you to do, is to think like 55 minutes, most amount of time, understanding from problem from different angles. And hopefully today's talk would help you do that. So defining the KPIs is number one. What is your KPI looks like? From the product management perspective, when would the service be down? Is it 5 minutes? Is it 1 hour per month is okay? So we need to know that. We need to, depending upon that, we build our architecture on top of it. Similarly, what is the operational cost per trip? This is for the Uber. We would have similar kind of things for any other company, like number of orders created per day could be another one which can be there. And response time. So response time means, from the Uber perspective, 500 milliseconds is the response time. Nobody would wait for more than 500 milliseconds to solve, to look at a problem. Now that said, that is the fail points. We should always look at it. If you just get this, build the use cases, do the empathy map, you have actually solved the real problem. You have to understand it. That's the key part I was trying to hone in on, the failure points. Once we have the failure points in mind, now I can build a resiliency model to really support that. So let's talk about resiliency. What is resiliency? Is we have a skeleton of our product which is always running and making sure that the people are able to connect to our application and use it. So one book I suggest here is The Art of Scalability. So when we talk about scalability, Martin Abbott and Michael Fisher, they talked about different angles, processes, architecture, and organization. And ultimately, they came up with how many ways we can increase our scalability. So number one, what we can do is, you have a monolithic application, the x-axis, you can build a system with many systems connecting through the load balancing. You do the horizontal duplication. That is one way of doing that. You can shard the data. That means you can have z-axis for sharding the data. So when we say sharding the data, that means that you can do location-based sharding. That means if you are a global company, you can say, hey, if a request is coming from United States, it will flow through these service. If a request is coming from European region, it will flow through that service. So you can do that to scale up. You can also do scale up using function, by function or a service. This is where we start building the microservices, and we try to have split the service and the database based upon how we want to use it. So that's what the key notion is. Now let's talk about microservices. Like, it's a favorite subject. Everybody loves microservices. Now, do you know microservices are awesome? And when we build a microservice, we feel so proud of it. Yes. So what happens in this case? An end user is trying to send through an API gateway a request. When the request is being sent, it's going to a microservice. When it goes to this microservice, it also goes to different other microservices. What could be wrong? What could be the issues in this? What things you can see there are when we build some architecture for microservice? What are the things which can go wrong? I'm sending to the microservice. Microservice needs to call this microservice, this, and this. So what do you think could be a problem here? If you think about this, yeah, think about it. When a request is being sent, now this microservice is calling another microservice. What could happen wrong? Maybe there is a network failure. Maybe this microservice is not even available. Maybe this microservice is not available. So the orchestrating microservice is failing from the beginning. So what can we do to protect ourselves from these things? Those are the things. It's not the microservice, but what are the principles I can apply on these microservices to solve the problem? That's the key part which is there. What's the bottleneck here? Which is there. Now, what could happen? Like, we orchestrated this one, but how about a simple thing? A request has been sent. I send a request back as a 200. Now, which 200, which is saying, okay, this is your request has been received. We will work on that request. Now I get this data saved in the database. How are we authenticate the data from one microservice to another microservice? That's another very good question. The security is another point. Single point of failure is another problem. There are a lot of problems in this, guys. Like, if you see that, like, a single point of failure, that's one thing. But the other thing is when a microservice call another microservice, that means the availability goes down. The overall availability of the microservice goes down. So you can't say this is the 99.99% available. So those are the considerations. So one of the pattern I suggest is that you request and you send the 200 request back to them. Now save the data. First of all, save the whole data in a data store. Now you start processing it and have a status being sent to the end user as a push request while you're processing the microservice. If you need to orchestrate something like this. Make sense? So authentication, I'll talk about authentication also in a second. So if you think about it, the supplier, so now this is, you can call us Amazon. So Amazon does the same thing. When a customer is calling Amazon or any of the online services, what if the microservices of the process order goes down? Whenever the inventory is there, Amazon never send the request, push the request to the inventory. It's an anti-pattern to begin with. In the last talk also we were discussing this. You cannot push this request to the inventory. Inventory cannot take more than 100,000 requests at the same time. So what they're going to do is they're going to pull the request from here and then use in the inventory. So you have to know what you're trying to use in this case. So what if which process order goes down? So you have to understand when something goes down, what do you need to do? We'll talk about that in a second. So before I do that, I wanted to first tell you, hey, I told that, hey, something can go wrong at any time. A client is sending a request to a server. One microservice is sending a request to another microservice. What all places it can go wrong? It can go wrong in all these places. The post request can fail, delivery request can fail, validate request can fail. and and other requests which can fail here. Validate, reply can fail. So these are 8 failures which can take place in this case. Yeah. So which we need to look at. Now it could be possible that request messaging is going on across the network. You have to write the code which does the post failure, retry, fatal, and success. So that means we are writing this code. It's not anybody else. We need to write this code. So that is the resiliency. I would call it as an important part of our design principle. Next is a cell-based architecture. So whenever we see a boat, what they do in the boat, like, if there is a water which is filling in this boat, they have shut valves. They can shut the valve so the water will not leak to any other compartments. So that's what the bulkhead architecture is. And Amazon uses this one a lot, where they're trying to do the workload isolation. Whenever there is a DOS attack going on, or a failure containment, or some way of test this data, it's very good to do that. Let's take a scenario. So one of the important scenario you can do is that, hey, if you have A and B customer, you only send it through one cell. That's helpful, because now what I'm saying is that because we are routing it through one cell, what's this doing? The load balancer is routing through one cell. That means all the other customers will work fine. So that could be like one way of solving this problem. But what we can do is we can do shuffle. We can do shuffle sharding. So now if this fails, only these 2 customers are affected. Now let's take a look at another example where I did the shuffle sharding. Now A is appearing in 2 different cells. What if one cell goes down? Perfectly fine. A will be able to process without any problem. C will be able to process from here. And here the B can also process and D can also process. You get the idea behind it. So this has been used a lot through shuffle sharding. So the more the overlap, let's say if I have a 3 overlap, there is a 0.06% customers would be impacted. And it's basically negligible after you have 4 overlaps. So typically they always go with 3. You should have at least 3 servers, 2 to 3 servers, to really from the balancing perspective. Make sense? So that was the cell-based architecture. Now let's take a look at auto scaling. Auto scaling is an important feature which helps you save money, and basically it takes care of undersupply and oversupply. Whenever the customers are more, it's always a cyclical. It will go up and it will go down. The question is, how do I auto scale? Now, whenever we are doing auto scaling, we can use auto scale group. But the problem which we always face in the auto scaling group is that, whenever we are using load balancer, how do I store my session? Because where do I store the session? That could be one thing. There could be multiple places we can store the session. We can store the session in a cache. If it's the Redis cache, you can do that. Or you can put it in the database, or you DynamoDB. So all 3 ways you can store the session. Now, if one server goes down, you are resilient enough to be able to process that record using another server. So that's one of the key part which is there. Another thing, if you see here, is the CloudFront using the Content Delivery Network, CDN. Now what happens, whenever a request is being sent, the CloudFront can have a cache. That cache can have all the static content. Now we are not going for static content to our servers. We are directly getting from the CloudFront itself. That's another way to build in a caching mechanism for resiliency purpose. So those are the 2 ways we can really do this effort. So another part is like, when you have more than 1 million users, or 10 million users are there, 20 million users are there. I have one customer who has 35 million users right now. So if you have that much scale, what do you need to do? You cannot just keep on adding more servers. That's not going to really solve the problem. And then also there is a problem with auto scaling group, because When you do auto scale, what happens when you do auto scale? There is a startup cost. Yes, you have to wait for that startup cost to happen. Then only you can do auto scaling. So those things is more, you have to plan for your load. That's where you're going to use the auto scaling. Another way you can do that is through Lambda function. Through serverless architecture, you are able to connect and use this for most of that aspect to solve your problem. So you have to see what you're solving and be able to do that. You can also use SQS, the queuing mechanism, to solve your problem. Why? Because let's think about the queuing mechanism. What happens when one web service is sending a request to another web service? We'll talk about that in a second. All right. So now AWS has provided something, from auto scaling perspective, a way of predicting the future. That's called forecasting. So you can use forecasting to solve this problem also. You can have a forecast where you can say, okay, depending upon the previous load, this is what it looks like for the forecast period, and be able to build based on top of it. So we talked about the auto scaling. Now let's look at reactive architecture. When we say reactive manifesto, we all know response time should be less than 500 milliseconds, so 250 millisecond response time. Yeah. And it needs to be elastic. We talked about that. Everything is sent through a message. I'm sending a message to a bus, and then let the other customers take that message and use it. And it needs to be resilient. Then we are building the architecture. So let's talk about my, Uber, which is a unicorn Uber, which I'm sending. I want to go from one place to another place. This management service is there. So first principle which we applied here, if you see here, first thing, any request comes, you store it. That's a good thing. That's the number one thing which is important. Now, I don't want to send all my requests to the notification service, account service. I only want to send for anyone who has spent more than $20, more than $10, because I want to just work on my loyalty program for them. And accounting also, I want to work for that only. What things do I need to do? Should I call this microservice for all these? Is that the best practice? What can I do in this case? That's one question which is also asked in this case. Yeah. So in this situation, what are the options do we have? Any thoughts? What options do I have? I need to have some orchestrator here. So I need to have an orchestrator which orchestrates to send to all these services. Yes. So that's something we can do. Okay, I can send a REST API calls to all of them, but that's not the best way to do that. I should put a distribution service. Now distribution service is sending it to all of them. Now, if you see this looks good, but the problem is that what happens at any given time if the loyalty service is down? What am I going to do? If the loyalty service is down, how am I going to support that loyalty service? So we need to think about that also in this situation. So that's another problem which can occur. So, okay, so in that case, what can we do? What we can do is not only that, we also need to anyone who has spent more than $20 and gone for more than certain distance, I want to send it to accounting system and loyalty system. Yeah. Now, in that case, what you can do is you can create a topic. You can send it to a topic, pub sub model. You can do a pub sub model where you're publishing and then subscribing it. Yeah. So once you're doing the pub sub model here, in this case, now I'm able to publish my events and all these people can subscribe it. Excellent. That solves my problem. Yes. So event processing, yes, better with the event processing. Alberto saying gateway, API gateway you're using here, and then you're using event processing to do that. But the problem is still there, because what could happen is that I have my loyalty service, it crashed. Loyalty service crashed. It got all the data, but it crashed after some time. What can you do? How to sync the data in the microservice architecture? Excellent question, Ansari. So, so how can I sync the data? That's another problem which always occur in this one. So let's talk about few solutions here. So one of the thing is that that each of these service can take the request at a different rate. So what can we do? In this situation, we can filter the records. Now, once we filter the record, so I can use SNS message, notification message. I can send an SNS message from here, from AWS. I can send the SNS message to all these records in this case. Yeah, have a heartbeat check. Yeah, push with the dead letter queues. Yeah, so somebody saying RabbitMQ, you can use RabbitMQ. Queuing mechanism, pub sub model also you can use. Awesome, guys. This is exactly what we need to think about. So what we can do is we can put here a queue. Now, what is the queue really doing for us? It's serving two purposes. It's asking and acting as a buffering load balancer. Okay, if I put here a load balancer, so you know what you need to do? If in a traditional model, if I send a request to this microserver, what do you need to do? You need to put a load balancer here, yes, and then you need to send it to multiple microservices, yes. Now, in order to not do that and be able to still support using only two servers for notification service, what do you need to do? You need to use the queue. That's one way of doing that. So that's called buffering load balancer, which you can use for getting these data into different services. Now, someone has said Kafka as a consumer group. You can also do that. You can also use Kafka. In that case, the Kafka is now sending the request out, and now, or Kinesis, Amazon Kinesis also you can use here. Where now it's sending out, and the customer is, and all these are reading at a different rate. So that's another way of solving the same problem. So there are many ways to solve the same problem. Absolutely, yes. But the important part is that anything you persist, you do CQRS, command query responsibility segregation. This is the important principle which we need to keep in mind when we are doing it. So that means when we have a command, anything read-write operation the UI is doing, you use one step of storage, and you send it to the event sourcing. Now publish it and subscribe it and be able to use it for the domain models. So any materialized views using that. Yeah. Would this not increase the response time? Yes, exactly. Ayush, this is exactly true. This is going to increase the response time, because now the response time will reduce in this case. Why? Because it's eventually consistent. This is using materialized views. In a way, I can show it in the UI in a second, like, in 100 milliseconds. You cannot do it using a storage way. So that's the reason you're using CQRS. Make sense? So what we do is normally, this is one way of doing it. Event bus is there. You have a producer and consumer using a Kafka. You think about this, I'm using a Kafka here. The important part to remember is that you have to use a replay ID. You have to store all the transactions in a replay ID. That means you have a replay ID 1, 2, 3, 4, 5, 6, 7, 8. Out of this, one customer has read only till 2, has read only till 3, and this customer has read only till 5. So you have to know what your window is, and each customer can read the data at different rates. So this is a really good way of using the data and be able to do that. Now you can have different consumers. Different consumers can be there, consumer A can be there, consumer B. They both are consuming at a different rate, as you can see here. So whenever a disaster takes place, what can happen? You can have a RPO or RTO, which is the recovery point objective and recovery time objective. Now within these two things, customers can replay the event back to them. That's the key part which is there. So we talked about the reactive architecture. Now let's talk about the timeouts. And I know that we have another 10 minutes. Do we have 10 more minutes?
Well, to be honest, Rohit, we need to wrap up. But if you can do this at least in 5 minutes, then
okay. How about 5 minutes? Okay, let's do that. So the important part is whenever a front end is calling anything, insert. Number one, always do upserts. Okay. That's the first thing. because you have a number of connection pools here. So that's what one of the thing is. Another thing is to use exponential backoff. Always use exponential backoff when you're calling. If some service is down, always use exponential backoff to give a breathing room to be able to do that. And another important thing is always check the timeouts. Python has infinite timeout. So you have to put a timeout, otherwise it would not work. MySQL has a, you have to put a timeout, otherwise it's an infinite timeout. So you have to, without that, it would not work for you. Circuit breaker you can use for timeout also for that same purpose. And then, eventual consistency model, which I suggest everyone to follow, is if you want to book a ticket from Boston to Chicago, you want to get the cache. You want to get the caches. That means airlines, all the 3 airlines are there. All 3 airlines need to cache the data into memory. So that's the reason what I was saying, CQRS, where you raw event source the data through using Spark streaming to put it into Cassandra. And now it's available for you in 100 milliseconds of response time. So that's the key part which you need to remember. The next one is caching. Now, caching is very important. Amazon did a study, like they lost 1% of the sale by 100 millisecond response time. Magic number is 250 milliseconds. That's the key thing which you have to remember. The important thing is, we talked about CloudFront here. The important thing here is the cache. You need to make sure you build a cache, side cache or inline cache. Once you build these 2 caches, now it's all available for you to use for most recently used values. That's the key part. So when the DOS attack take place, then you have a way of the caching, so you can avoid going to the database and be able to get the cache for yourself. So these are the 2 caches which you need to use. The last one which I suggest you to do is, the order is always there in the chaos. That means you have to do an experiment, contain the blast radius. That means the blast radius means, like, whenever there is when I say blast radius, that means bulkhead. We talked about bulkhead. You test it small, make sure it fails and fix that issue, and then scale on top of it. And fallacies of distributed systems. So yeah, you look at my website, there are talks on this, like, network is reliable, it's never reliable, and so you will be able to get more information from my website or my YouTube channel. You should be able to listen to it. There are 5-6 talks on this itself. Right. So at the end, I would suggest use the chaos engineering, where you get the KPIs for your usage. So, well, it was a short talk, but I hope you enjoyed, looking at all 9 aspects of the data. And all of them are really important to make a resilient architecture when you're building it. All right. And hope to connect with me on the LinkedIn if you have any questions. All right. Thank you.
Thank you so much, Rohit. I may tell definitely, please check the context of our speakers if you want to ask them questions in the future. It will be definitely very useful for you. But also, please remember that today we have just awesome awesome opportunity to win the question, for your future ticket for our future events for the ticket. So right now, a few words, just I'll tell you what is going on, because we have additionally very important message for you to deliver, what I think will be really interesting for you, especially for those who are joining our platform for the first time ever. So if, for example, for the Geekle community, we have a pretty exciting announcement for you to make, because Geekle is moving to a new format. What does it mean? Starting from today, everyone can join Geekle educational platform to get access to the recordings of all of our amazing events, both which are past and upcoming. And also, we are starting a new series of weekly episodes focused on different aspects of developers' growth, which I think is pretty amazing. And here also some details on what benefits you'll get from joining our community. So first of all, you'll get the access to weekly online meetups with unique content from top speakers. Secondly, videos from past and upcoming summits by Geekle. Also, worldwide networking with a community of more than 60K of developers. And all attendees today of Worldwide Software Architecture Summit will receive, attention, 21-day of free access to the platform. So you can actually join us by the link. I'll definitely share it right now in our chat, in our comment section as well. So please follow, please subscribe. I think this is like an amazing opportunity. But also let me just recap, because very soon I'll try, by the way, also to make it like make it read all of your questions. And for this, I'll try to do my best, because we have here StreamYard, and we are also we have also additionally chat in our Pine platform. Pine platform. So please welcome. We'll proceed very soon. Hopefully very soon also Ivan will join our Q&A session. But I'll start like from the questions which I've got during the presentation of Alexander. So Alexander, I'll start with questions to you, which I actually got in our Q&A. But also please remember, you have the possibility to ask questions, and they are saved there in our question comment section at StreamYard. Okay, so let me just recap. Alexander, the question is from Aguiar. Which programming languages do you tend to use with cloud functions for cost efficiency and being developer friendly, for example?
Well, basically, that's a very easy question for us, because we are doing React Native development on the client, and we want to have this single software stack thing. So we do use Node.js, which basically is kind of cool for usage in things like Cloud Function, because the startup time is very, very fast regarding to, or compared to things like Java or C#. So we're using most of the times we're using Node.js here.
Thank you so much. The next question is from Michael. What do you think about the multi-cloud solution to select services from different cloud providers that can work together and allow to select cheaper services depends on the provider prices and offer?
Well, I think it depends on the scenario. As I mentioned in my talk, we've done that in different cases, and it worked very well for us. But again, I think it depends a lot on the scenario, because for us, it always creates some kind of overhead, because you have to think about things like authentication, security, over the two platforms or multiple platforms. So again, depends on the scenario, but it can work very well.
Thank you so much. I can see as well the questions, of course, for Rohit. I also could see some questions for Ivan. I really hope that he will join us maybe later. In that case, also, I'll try to do my best. If, for example, I have very quick announcement. I think that if, for example, if I haven't, because we still have limited time, if I won't read it out loud, your questions right now, they will still be evaluated for the future to win a question for a ticket. So please we'll try to make sure that we will read all of your questions, and if I won't read them out loud, still they will be counted. So Rohit, the question is about zero trust between services. An internal API gateway could be used for authentication of the internal communication. Could the external API gateway be used instead?
So you can use any authentication. That's not a problem. Like, industry standards are all in place right now in terms of authentication. I would suggest use OAuth for most of the services, because you don't want the person who is logging into the system, you don't want to give them access to more than they need to have access to. So what we have also started doing is is that per session basis only you are giving an access. So an administrator who wants to perform a particular session, when they're within that session, only then they get the access. when they're performing that service, only then they get the access. So that's what I suggest you do that. So I mean, yes, you can use API gateway along with other solutions like Microsoft solutions you can use, or Auth0 you can use. That's a pretty industry standard nowadays.
Thank you so much. Another question is from probably this would be from Ivan. Let me recap for Alex as well. What was the most important argument when choosing Google in that case instead of Amazon Web Services? I think it was during your presentation. It was closer to the end.
Yeah, right. So basically for us, it was, in this case, development speed. We wanted to have an MVP as fast as possible. And this Firebase suite setup gave us a lot of development speed. And when we compared the services, it wasn't that much more expensive than when we would have used AWS. So yeah, it was development speed in this scenario. Yeah.
Thank you so much. By the way, you have the possibility right now, as I mentioned, ask questions in our chat on Pintle platform, but also you have the possibility to ask questions directly on YouTube. So please let me just recap. I'm sorry. I'm really sorry for those who were asking questions, Ivan, but he's not. I'm sorry, he's not available right now. But we'll definitely, as well as I said, we'll definitely count them. Let me just recap. What are the? They already want to say thank you for your answers, but it's not all. Let me just check. Additional question is. I think that you already been answering some of the questions to our audience. Alex, yes. Oh, I can.
Well, I tried.
Yeah.
I tried. I just saw in the chat, but I tried to answer 3 of them in the chat. I saw there were a lot of questions also on YouTube, but I didn't get to answer them all. So from my side, if someone wants to have an answer for a question which we can't make here, just write me on LinkedIn or anywhere else, and I would be happy to answer.
Definitely. Thank you so much. And again, coming back, Ivana has already joined us as well. Just quick questions again to Alex, because I can see it here and new comments are coming. Please on YouTube, ask questions, address your questions to Rohit, Ivan, or Alexander, but also don't forget about hashtag question for a ticket. So Alexander, may I know how do we manage the service that goes wrong? Do we need a backup service that can handle those things?
Well, basically, that again depends on the scenario, right? So you have to think about what happens when the service goes wrong, right? But in the case you use things like cloud functions, most of the things are handled by the cloud platform provider. But again, if you have an error in your function, you have to think about what are you doing with this error. You have to kind of handle it, and that basically means you have to try it another time, or you have to give the user kind of an error message. So sure, in any case, you have to handle those errors.
Thank you so much. Question for Ivan. In your years of experience, what will you say is the best use case for a strictly microservice architecture?
Well, I would say that the first precondition is having a large organization. I wouldn't start doing microservices in an enterprise or in a startup with 10 or 20 employees. It's overkill, presumably, unless you intend to scale up quickly. I would literally start from, even if not a monolith, a small set of modules, and then as you scale up, you split the responsibility of your software into microservices, each one owned by a specific team. And the ownership part of it is the most important thing to take into account, because when you have that, then you can evolve separately. As I mentioned earlier, like you should structure your organization through the boundaries of your software. So when you define the boundaries of your software, of your service, then you assign to the specific team the ownership of that software.
Thank you so much. And by the way, additional question, maybe addressed to our audience, please. In case if you're like feeling that your questions won't be like lost, you may, for example, double it like in YouTube or in our chat on Pintel platform. Thank you so much, Ivan. Still, there were like a request for you to elaborate more on micro front ends a bit more. So the frameworks that are simple to implement them in. To implement them in. Additional, the question for Ticket.
Right.
So,
So
if maybe I might read it maybe once again, because maybe is the sound clear?
yes, please. Can you repeat?
So can you elaborate on micro front ends a bit more? The frameworks that are simple to implement them in, etc.
Well, this is a very broad question. There's no simple framework to implement in. There is your use case and what you want to use the micro front end for. So there are also several ways you can implement micro front ends, whether you want to render the micro front ends on your server, whether you want to use edge side include, so compose your interface at the edge of your cloud deployment, or whether you want to compose the front ends on the client. For these three different purposes, you have different, entirely different frameworks. Just have a look, and I can give you some pointers. Have a look at what SAP, Zalando, Spotify, and many others are doing in this respect.
Mm-hmm. By the way, I just wanted also to make everybody of you know that I really like, apart from reading questions, they are already, the audience is really satisfied to, are really satisfied with your presentations, and they're really grateful. And that's why I think it's really great to feel and to hear such kind of feedback. I'm definitely sure. Rohit, the question is for you. While using a PubSub with a front end, how do you make sure that the preceded data is visible immediately after the message has been consumed and processed?
Yeah, the important question, the important question is not immediately. The important question is when you're using PubSub, when the request is being sent, who is using it? The question is like, the eventual consistency model. And the argument is always there, like, if your use case is the immediate, like not even like a millisecond of response time, in that case you have to go to the same data store. You don't have any other way of doing that. But if your use case is that after some time you are processing it and putting it in a materialized views, so I always look for materialized views to save us cost and bandwidth to really cache the data and ready for us to use. So that you cannot do immediately in the PubSub. You have to either use the same storage where you're sending it to, and then and use it, or you can or you have to devise eventual consistency model with CQRS.
Thank you so much, Rohit. The next question is also for you, but I think it might be actually addressed to all of our speakers. A bit provocative, but at the same time, I would say a bit philosophic. So, Amazon Web Services or Google Cloud Platform? I think it depends on what, for what exactly.
Yeah, it's a very important question. Very important question. Like in one of our projects, what we did was like we built platform agnostic. So and when we built the platform agnostic, we were able to move from AWS to Google Cloud within a matter of 2 days. We were able to do that. But then, so that was like one project where I did that. But in order to do that, there are a lot of things which you have to keep in mind, which you have to process yourself. Like if you just pick AWS as a platform or Google as a platform, now if you start using their functions or doing certain things, you definitely at some point you're going to marry them. Like, it's like in order to have cost efficiencies, you would have to pick between the two. I would say, between the three. I would say right now, because Microsoft is also there. So, but in order to gain the efficiencies, we had to, for other projects, we had to move towards AWS, and because that was giving us more efficiency. So you're not looking just for platform agnostic, because if you do that, which is possible, but then that comes with a lot of work that you have to do behind the scene.
Thank you so much. By the way, question maybe Ivan or Alexander would like to answer that as well.
Pitch in on this.
Yeah, leave to Alexander first.
Okay, thanks. Well, basically, I think I'm on Rohit with that, because you can get a lot out of the different services which AWS and Google or Microsoft gives you, and they all have kind of different services which fit more in specific use cases. So I think you have to look at what do you want to achieve, and then look at the services which give you most efficiency for that specific task. For example, if you look at databases, all cloud providers give you great solutions, but they are all a little different and match different use cases more or less. So I would say have a look at your specific use case, have a look at the services, and then decide which way you want to go, because I would always prefer to use the services over platform agnostic, because you save a lot of time. But if you have the requirement to be platform agnostic, as Rohit said, you have to do a lot of work on your own. But it's definitely possible, right?
Yeah. Thank you so much. By the way, I have right now questions sometimes addressed to both of the speakers. But right now, question is directly to Ivan. So which of the architectural design patterns is your favorite, and can be applied it as a rule of thumb almost always?
It's a very, very tricky question. I would say...
I will just comment here, Ivan, that they are actually our one to win the ticket. That's why I think that right now they are very elaborate on asking questions. So yeah, this is a challenge sometimes.
I have a favorite, to be honest, and it's a push-based design. So literally pushing the information you want to the client, rather than having the client pulling the information. That is my personal favorite, which you should couple always with message-driven design. So creating a producer of your information, loosely coupled with the consumers. You don't know who the consumer is. The consumer takes the message and push it to the client. That is my favorite, and I've been using it over and over, in at least at DAZN, which is a quite large architecture, quite large also organization. It helps us going faster and having a smaller architecture in terms of cloud components and a number of components, because in the end you are in full control on how the information flows in the system.
Thank you so much. Now question is both to Ivan and Alexander from Tamar. For millions of requests per minute, for example, is enough to have scalable microservices and also to use fully manageable cloud services? So is it enough?
I would say we are using plentiful of cloud managed services at DAZN, and tying to the previous question actually about cloud agnosticity or preferring Google versus at DAZN we faced out these questions, to be honest, because we've been asked at some point by when we had a chief technical officer. Now we don't have it any longer, but that role. But we've been asked to aim, or at least have a look at the possibility of being cloud agnostic. Now, we realized very quickly that it was hard to achieve,
there was major effort to be able to be cloud agnostic, and I think Rohit can also confirm, given he's been through the journey. So unless you have really a compelling use case for being cloud agnostic, you better actually redo things from scratch if you have to move to another cloud platform, to be honest. That's why we now use a lot heavily the managed service that AWS provides, but we're not using only AWS. We use Azure, we use also Google Cloud, but the majority of our services are on AWS, I have to be honest.
Thank you. Alexander?
Well, I think I have nothing to add here. Yeah.
There will be additional questions again for you too, but right now, let me just recap the question for Rohit. So the question is, what is your approach for API gateway? Where we need, for example, 3 microservices to return a success to the API gateway in order to consider that request is a success using event-based?
Excellent point. So first of all, the success part is different. Like what I suggest always is that API gateway is basically used for the throttling purpose. Whenever a request is being sent to the API gateway, Amazon API gateway or Azure, doesn't matter what you use. The problem which always happens is that when you're trying to process multiple microservices, using that, there is orchestration going on. So instead of the orchestration, if you use a pattern where, hey, we have, so Amazon does the same thing. Think about this scenario, and then we make it much easier for you on this one. It's a Thanksgiving Day. Millions of requests are coming into Amazon. And what Amazon does, Amazon accepts all the requests. They do not know at that time whether they will be able to satisfy their request using their warehouse. They never do that. They always they always send an email saying that thanks for requesting. So what you do is whenever a request has been sent, you say your request has been started to be processed. Now you have a phased way. Now you can have orchestration API, which now can go to all different APIs and be able to send the request out. So that's one pattern which I always use instead of holding up the request, because if you hold the request in your processing, you can lose the data. You can crash at any time.
Thank you so much. And probably the last question for today, because we still need to have a break before our next block of presentations. Really quick recap for both for Ivan and Alexander. What key architectural tips generally would you give to start a new solo engineer project designed to scale?
Well, now you can go first, right?
Thank you. Thanks for returning the favor. I given already one recommendation during my presentation. One is the Release It book from Michael Nygaard. It doesn't speak about microservices or anything, but it gives you a lot of information on how things can fail, how you can structure your software, breaking it down in ways that prevents, let's say, failure of your entire system, and that leads naturally to building microservices. So architecturally, it's the first lesson you have to learn. Things can fail. Structure your software in a way that it can fail and it can also recover, and learn the basic patterns, bulkhead, whatever pattern that you hear many times is the one you have to learn. Absolutely. Don't go for fancy thing. Learn the basics first.
Thank you so much, Alexander.
Well, basically, I think there are some good it's not frameworks, but you have this, it's called, I think, AWS Amplify on AWS, and you have the Firebase suite on Google. I think if you're not that experienced in building scalable architectures, that are good starting points, because they kind of force you in good architectural constructs, I would say. And if you have a project which you are working on your own, they are also good tools to get some speed in your project. So I would definitely recommend to have a look at these two things, AWS Amplify and Google Firebase, because they can be a good starting point for your application. Firebase is a little more, I would say, locked in, but AWS Amplify basically spins you up the things you need, and you can work with it later and build some kind of bigger architecture around it.
Thank you so much, Alexander. I really appreciate your presentations today. I really appreciate your attention, your time, that your hard work and your sharing of your experience. I'm really sorry. We would love to listen to you more. The only thing we need to, because we're already even running out of time of our break time. So in that case, once again, I think that the audience would also would applaud you right now if you could hear them, if you were being on the stage. Thank you so much again for joining. Meanwhile, I'll just recap very quickly, because I heard from your feedback that you really you like questions as well from Ugur and Tamar. So to not lose them, please type them in as well in YouTube section with of course definitely with our hashtag question for a ticket. Thank you so much again. Right now, Alexander, Rohit, and Invan, and I think we'll see you at our future conferences as well. Thank you so much.
Have a great day. Thank you.
Thank you.
Thank you. And we are moving forward. Before, folks, I will actually go on a very quick break. I'll tell you a very important information, because I think for you it will be interesting challenge. So a Geekle team announces a challenge. So what does it mean? In this case, the challenge is about taking a picture or video in front of the screen with Geekle conference. Post in your social media network, different, because we are on Facebook, Instagram, Twitter, LinkedIn, using hashtags GeekleUS, Geekle / events / and please tag definitely Geekle. So 3 posts which get the most likes will be broadcasted online. And I think for our community is additional really nice incentive. Meanwhile, we're going on a very short break, guys. It was supposed to be, folks, probably for it will be on no more than 5 minutes. So grab your coffee, grab your tea, and we'll be back with a new block of presentations. Thank you so much, and see you very soon. Hi, guys. I'm really excited that you're actually joining us today and you're still watching one of the most, I think, exciting so far summits, which is Worldwide Software Architecture Summit. We are moving forward because we have pretty exciting news for you to share. And again, remember that you today have the possibility to earn additionally what? You have a possibility to earn additionally a ticket. So please, very soon, I'll be really excited to announce our next speaker. But before I'll start, please remember that prepare all of your questions, type them in, those questions, make them public. Preferably, you can also do them, of course, on on our Pine Tool platform, but also definitely uh, text them right once again in YouTube, because in that case we won't lose them, because we want to make sure that every question will be counted. And even, for example, if I want voice it, because we have still pretty limited time for Q&A session, you still will have the possibility to win win the ticket for the best question. Meanwhile, I'm really excited to have today Paloma Aguilar. Aguilar. If I'm not mistaken, please forgive me. I think Paloma will actually correct me if I'm wrong in this case. Aguiar from Spain. She is a cloud architect at Oracle, and she'll tell you more about building a smart manufacturer architecture with Internet of Things, which I think is pretty exciting. So, a lady who has graduated from computer science and completed MBA in information technology at the University of Sao Paulo. And I think Paloma has lots of interesting events, very interesting things for you to share as well. But also, for the time being, make sure that you're prepare your questions. So very soon she'll be live, and you'll be able to listen carefully, and you'll also get the prize. See you.
Hello, everyone. Thanks for coming for my session. It's a pleasure for me being a speaker for this event. So today I was talking about how we can build smart manufacturing using IoT. So before starting, so let's introduce myself. My name is Paloma, and I'm originally from Brazil, São Paulo. I graduate in computer science, and I also complete an MBA in information technology in University of São Paulo. I worked for Ericsson almost 10 years as a system integration engineer and also as a support engineer. And during this time, I was able to travel a lot and work with different customers around the world. I work currently for Oracle, so I'm working for Oracle almost 7 years, but now I'm based in Malaga in Spain. So I'm working in Spain almost 1 year. And since that I started Oracle, I was always working with architecture and pre-sales. And my big knowledge, my expertise is mainly when we are talking about handling data. So I have a few certifications as well. And the last one that I got, it's the professional OCI certification for Oracle. So let's start. And I like this slide because since that I work with technology, I realize that all the time we have like different words that means different things. And sometimes this is so hard because we are start with a solution and looks like sometime later something is new and we need to be prepared for this. So when we are talking about building a better architecture, it's just to make at the end our solution be more adapted for the real world. So before starting and talking about this, so let's be clear. So the basics of IoT device. So what means an IoT device? What is in fact? So an IoT device, as probably all of you know, that it's a device that can send some information, that can communicate with an internet or can communicate with some system that can share some kind of data. So sometimes you say, so a human also can be an IoT device. Yeah, if he sends some information for that, so it's possible if he can communicate with an end solution that will handle this data. But when we are talking about a specific device, we know that an IoT device, like we can have SIM card, I can have like I use a smartwatch. It can also process IoT information. So an IoT device, it combines like hardware and software. So there are different possibilities using IoT device. We have different ones. So for instance, here I am mentioning some IoT device for smart manufacturing that are partners from Oracle, but there are different ones. Since I work for Oracle, I just shared a few ones that I have been in touch. So this device, they can render the information and they can have different APIs and they can talk different protocols to communicate with your end architecture. So imagine if, for instance, in chemical manufacturing, that I have some embedded sensors that it can regulate and control the flow of pressure water. So you can have different sensors to do different things. or even to take pictures. For instance, here in Malaga during the COVID, it was interesting solutions because we have the beeps and they were taking pictures and they could control by using a map, like how many people are there, and they could mention if the people are respecting or not, and the restrictions for the COVID. So I could see that they have done this, and it's quite interesting. But when we're talking about manufacturing, how we can make our production line, how we can improve this kind of information. So, and how this looks like, how this data is handled. So, for instance, usually these informations are just small records. So imagine that I have a small SIM card, like with IoT intelligence implemented on it, where I can send some information about the temperature or about how a specific robot is doing an action. So this information usually are small information. So you have just a single record, but it's a lot of information. So it's like one line that is a small line, but with a lot of information. And think that if I am handling data, if I am handling information, how I can design my architecture for handling this information. So one of the important things when we are thinking about IoT, it's understand the data, it's understand how we handle this information. So if I'm using a record that has a small record, but a lot of records, millions of records, means for me that I have a lot of writes, that I have in my end architecture a lot of I/O to make this write in the data in the storage that I'm going to use. So the writing, so I need to have at the end storage or a data solution that I can run this kind of information. So it's common that we see in this kind of architecture using NoSQL database. So because I have a lot of write, I don't have too much update, and the kinds of query that I have, I don't need to do too much relational operations. So it's very common that we use for this kind of information, like a NoSQL storage for handling this information. So when we talking about this as well, we know that we have different challenges for the business. So I have a rush of volume of data from the IoTs. It's like information all the time. And I have different, I'm talking not just about one sensor, I can have hundreds of sensors, thousands of sensors. And also each sensor that I use can have a particularity or can do a thing and talk in a different protocol. That can be binary, that can be JSON, that can be HTTP, that can be Kafka. So how I do this, how I can integrate this information, right? And also the retention. So I have a lot of information, but I'm not being able to handle all this information. So I need to purge the data in a specific way that won't bring for me cost, like store information that I'm not going to use. And how to do this in real time. So this is a big challenge as well. I was working in Brazil with a specific customer that they do tasks for logistics, and they need to have some inputs in real time. So for them, if a trend, it was a big trend company in Brazil that can do different kind of logistics between different states from Brazil, São Paulo, Rio de Janeiro, Minas Gerais. And they needed to fix if something was not working properly, because if the train got stuck, they could lost not just money but also the image. So it was really hard. So after and they had all this information in papers. So at first we worked digitalizing this information and being able to build visualizations and using a smartphone for the drive operator be able to find the solution and fix it in a faster way. So, and all of this needs to be reliability with integration and keep the system always on. So when we thinking about this metrics for manufacturing, we see about how many companies that have experienced this kind of unplanned downtime. So, and how this amount can miss in the cost at the end. So how this can impact. So in fact, the Internet of Things in manufacturing is beneficial, both not just for the producers, but also for the and the customer, for the target customer. So we can also scale up for different equipment. So this is really important. And when we are talking a traditional enterprise model, we know that we have the factories, we have our sites, we have the suppliers, and we have a different kind of business application. Like I can have applications for CIM, for ERP, and also I can engage my users to use chatbots, using mobile, using web. But when we are talking about IoT and bringing smart manufacturing, we can bring different talks. So we can give this real-time visibility using different things with a bit more of intelligence with it. Like I can use IoT, I can use intelligence artificial with different capabilities. I can use blockchain for saving, for knowing exactly what has been done in a different situation. So with all of this, I can get efficiency, identifying and solving issues before they can cause delays. I can act in a predictive way. So when we are talking about IoT, it's very common when we're talking about architecture, try always to design a solution using a reference model. So I'm sharing here two different reference models from Cisco. At first, so we have like different steps that it's not steps, but it's how I can know that I'm designing my architecture in a very good way. So I can have my physical device, I can define which kind of sensor that I'm going to work. So imagine I wanted to have this physical device, but I want to have that the sensor acting more in a passive or active way. So with all of this, I can connect this information for my environment. I can have some equipments like edge equipments that I can communicate with a cloud solution, because in IoT, it's really important thinking about serverless solution that I don't need to have a capacity exactly for a specific size. So this is when we say that it's cloud, it's a good way to use IoT solutions. So, but I also want to have some information in my infrastructure before going to the cloud. So all of this, it is important. Like I wanted to have this information in near real time But if I go to cloud at first, maybe I will have a delay. So I can have information in a step one and send this information in a not synchronous mode for the other for the cloud. And how I define my data storage, so it's important. I mentioned if I know that I have more writing, it is important for me to thinking about how much my storage can deliver in IOPS. So, and how I will aggregate this information, how I use this like a visualization for my company, how I build the dashboards so I can help also my business area to be more data driven. So I want to collaborate internally. I have this information, but how much this impact for my my business, how I can help the operators to work in a more safer way and also in a more accurate way. So I'm also sharing the Gartner reference model for this purpose, for IoT. So I can have an idea about, like it's mentioned here, I have the sensors, or maybe I wanted to work with digital twin. So it's quite interesting. I have my physical equipment, but also I have this equipment in a digital way. So I can have much more occurrence, and I can use this in a more smart way. So I can really know how this equipment is working. So also about the communication layer. So it is important to know how to integrate the solution and how I will process this information, the data, if I run by events, if an information will arrive, how I handle this information internally, how I will stream this information in real time, in batch information, and how to use machine learning algorithms to process this information. So, and of course, having all of this with security, because we are rendering a lot of information. So having the security implemented, it's very important. This is another point that I think that it's quite interesting when we are talking about cloud solutions, where we are pretty sure that we are going to implement encryption and we don't have the risk of someone going there and using this information. And looking for more specific information, what is behind? So I have this reference architecture, but what is behind? Of course, we have different cloud providers like Oracle Azure that we have all of these already done. But if I wanted to implement by myself, what I need to take care. So I needed to know the IoT device. I needed to understand this information. I have to implement the gateway, so I can rent the messages data formats that we are using. So it's very common using Kafka, that it's an open source user for handling streaming data, and it's really interesting. Almost all cloud providers also use Kafka at the end. So, and this information, this streaming information, can be sent for different infrastructure. So I can send this information for a Spark, I can send this information for a Hadoop big data. And after all this information that will be consumed by different applications that can bring the visualizations that I can use for my BPM and my SOA platform, also to handle this information. So I have the data, but now I want to get insight for this. So also all this IoT device also have some APIs, and that I can also enrich my solution using this. So for instance, my smartwatch, I could use some API from Garmin, that it's the brand that I'm using, to integrate with some solutions. So this is really interesting. And now have an overview about the role thing that it's involved here. So what is the operation? So I have the different protocols, like I mentioned, for different sensors that can generate the information, that can generate the role information. And operator, so they could see this information and see about how this information is handled. So it is interesting. We also can have this concept for augmented reality. So it is interesting. I can see how this could operate in a specific scenario, in a specific environment. And all of this I can create, I can improve my quality, I can improve the maintenance, I can avoid a lot of cost for maintenance that was not planned. And all of this is deployed in an infrastructure that I have a security. I can use the big data connectors to handle this information in a safe way. So it is important to understand how this is connected. So this is our connecting manufacturing, that I can have collaboration, I can use chatbots, I can have dashboards for handling this kind of solution. So once when we are explaining about how these IoT applications can be delivered. So imagining that I have an application that it's working with asset monitoring. So I want to be sure about the assets, and I can also detect where it's placed, so I can have better imports. Another that it's really important is the production monitoring. So I can use production monitoring, so I can do prognostic equipment. So I can detect anomalies for this equipment, and I can avoid have any trouble at the end. I can also use this for the fleet monitoring. So I wanted to see in a specific place how this is logistical being managed. One of the very nice things that it's important to mention as well, that usually for the manufacturing industry use a lot of maps and graphics as well. So I can have different fabrics being monitored remotely from different places. So this is also important. So I can act not just for any specific place, but I can handle this in a bigger way. So it's quite interesting as well. So for the connected work, so I wanted to guarantee the safe for my operators. I wanted to guarantee that I'm working in a safe environment, so I can integrate this and use this information to build dashboards, to build information to activate this way. So for manufacturing industry, it's quite important to use this kind of dashboards, to use this kind of information to integrate your environment. And talking about the service monitoring, so I wanted to see how my fabric that it's in a specific place is working compared with each other, with another one. So I can learn from that as well, and I can also accurate my results. I can do recommendations, I can detect, and I can act in a predictive way. And so this is really important for the business KPIs at the end. So of course, and as I mentioned before, we have solutions that it's already completely covering this, but it's also possible to build this, at least starting. So let's try to build something for my company that now it's really important. So I wanted to start with some sensors, and I wanted to see the monitoring for this equipment. So just is a step. And when and for me, the concept ideas for this architecture, so the highlights, if I could share my experience about how to build an architecture for a smart manufacturing and what could be the highlights. So for me, it's about create a data-driven solution. So this is important. I have a lot of data, but I need to handle this data. So I need to have the possibility to handle this information. So talking about the serverless idea, so I can handle the information without taking care about if I'll be able to handle this or not. But of course, using, like I mentioned, the purging data that I'm not going to use, but drive my company to be more data-driven, making decisions not by feeling, but making decisions based on data. So this is really, really important. Building this kind of dashboard with a good visualization. And I'm not exploring on this topic because we have just 30 minutes, but there are a lot of information about accurate dashboards for smart manufacturing. So how I really can integrate and use this. So this is really interesting. Use the capabilities for machine learning. So there are different algorithms that I can use, that I can implement in my environment to make sure that I am going to make prediction in an accurate way. So it's very common. We are talking about Python, we're talking about R. So use also the possibilities that machine learning brings for your company. So you can prevent problems and you can use this by a bad way. So we know that there are a lot of legacy environments and you can modernize, but thinking about how you can integrate this with different solutions that can also still integrate with this kind of legacy environment. So it is important also reducing the risks and integrate all the solution with the provider that can integrate not just with a cloud provider, but also with multi-cloud provider, but can integrate this and minimize the risks. And with this, we can also accelerate the best time to market that. I think that it's ideal for nowadays. So here I finish my session. It's a pleasure for me sharing this knowledge. I really hope that was useful, and feel free to reach me, and maybe we can also have different discussions on different topics as well. So thanks a lot for coming, and please be safe.
Hi guys, hi everyone. Thank you, Paloma, for your presentation. Definitely very soon Paloma will be back for our Q&A session, and you will have a chance to ask her like as much as we can due to our time limits, because you know we actually had like our previous Q&A session lasted more than 5 minutes. So we're really sorry that we're just a bit delayed. So without further ado, let me introduce you our next speaker with his amazing speech, Philipp Pickel. How do you do?
Hi, I'm good. Really glad to be here.
Thank you so much for joining. Philipp is a principal DevOps engineer at Horizon Alpha, and he'll tell you more today about how planning a cloud migration for a complex software as a service solution. He founded his company as well in 2012, focused on cloud architecture and cross-platform apps. Do you also remember our previous platforms, cross-platforms summit? Migrated applications from on-premise to different cloud providers. A lot of knowledge.
Unfortunately, I couldn't hear you, Maria. I'm not really sure why. Can you hear me? So, yeah, thanks for the introduction. So I would just start, even though I heard Maria's last words. So I'm really happy to be here and talk to you about planning a cloud migration for a complex SaaS solution. So as already said in the introduction, hi, I'm Philipp. I did a master's degree in information systems. I founded a software company back in 2012. I'm an AWS SysOps administrator. Yeah, and my job, I plan and implement cloud architectures and do cloud migrations. So far, I've worked with all three major cloud providers, AWS, Microsoft Azure, and Google Cloud. So as also said, I work at Horizon Alpha, which is based in Munich, Germany. We are about 25 people and mainly focus on React web apps and React Native mobile apps. And those apps, of course, normally need backends, and that's where cloud is a real good choice because it's easily scalable, and also for startups using mobile apps or developing mobile apps, it's really nice to have such scalable infrastructure for the backend. Besides this consultancies, we also have own products named Team Sports and Team Fit. Maybe you have heard Alex in a prior talk. He talked a little bit about Team Fit as a real-world example. I will take Team Sports as a real-world example here in this talk. So let's dive into planning a cloud migration. So the first thing is, when you decide to migrate to the cloud, the first question you must ask yourself always is, why do you want to migrate to the cloud? Normally, the main driver are cost savings you want to accomplish by a cloud setup. So, but those cost savings come from very different things. So, for example, you can save costs by having the scalability and elasticity of a cloud environment. So if you can easily scale your application, then you don't have to provide resources for peak load all the time. but only when you really need it. And the same goes for elasticity in a much shorter time frame. Another thing is easy deployment. So if you don't have to do much steps to deploy your application, you also save time and thereby costs. Easy deployment can be achieved without a cloud setup, but most cloud providers have heavy integrations, and therefore it's really easy to get an easy deployment for your application in the cloud. And also, one of the biggest cost-saving options is the reduced maintenance. So if you want, you can go full serverless, so you don't have to do any maintenance on operating systems or even your cloud environment, your application environment. And that can also save you a lot of money, because if you're not a really huge company, you might not have dedicated administrators for your resources, but some of the developer or something like that have to do the maintenance work, and that's time they lose for developing your application. So easy maintenance can be easily achieved by using cloud environments and by migrating to the cloud. Also, high availability is one thing you can easily achieve with a cloud setup of your application. You always have to rank those objectives, so what you need the most, what you want to achieve with your cloud migrations, because those objectives can compete with each other. So normally, if you go full serverless and have the minimum of maintenance to do, then you normally have to pay a bit more for each CPU cycle, for each memory used in those serverless services from the cloud providers. But in comparison to when you would take virtual machines where you have to do this maintenance yourself. So that's the first thing for a cloud migration to do, that you get your objectives, rank them. And so what are the steps to the cloud? I named it after you've decided you want to do a cloud migration. So the first step always is analyze the current state of your application. So this means describe the current architecture of your application, and especially name the pain points of this current architecture. So normally those pain points are then the main objectives of your cloud migration. So for example, if you're really fed up with all the maintenance work, then your main goal of the cloud migration might be to have zero or near zero maintenance work to do in your new architecture. Another thing you should keep in mind for the current state analysis is what's the current deployment or development process like, so that there is nothing completely different after the cloud migration, so the developers don't have to learn a whole new process, and the process should of course be easy after the cloud migration and easily to understand. So after you've analyzed the current state of your application or the architecture of your current application, then you should already forget it again for a short moment at least, and just think about what is the main essence of your application. What do you want to provide for your users? Just think about that, and think about the perfect cloud architecture for this application then. I put perfect into quotes because there could always be quite a discussion which is really the perfect architecture for the given requirements. So first then do it just as you would do it for a greenfield project. Think about your architecture, and have in mind your objectives you want to reach with those with this architecture. So, and then again, you go back to the current state analysis, because normally an already developed application has some limitations and has some difference than you would do it for a greenfield project. And so you have to think about where do you need to change and adapt your perfect architecture to suit your already developed application. So this adaptation is a real hard step, because you always have to think, do you want to throw away some of the code already written for your application, or do you want to keep it and take another limitation for your architecture? So normally in the already written application and code, there's already a lot of learnings in it, and you don't want to throw them away. So you have to adapt your perfect architecture to I named it an adapted architecture. So, and after you finished with adapting your architecture, then you would plan it in a more granular way. So normally, or at least I would suggest and advise you not to try to make a cloud migration in one huge step, but break it down into minor steps, do it in an iterative way. So have one small part move to the cloud and then the next. And so you plan those smaller steps one by one. And of course, the next step is always planned the most exact, and the step afterwards a bit less exact, and so on. And for the last step, you might have only a vague plan. So you have to describe what's your target architecture for each of those steps after they finished. And when you have defined your steps, or your smaller iterative steps to cloud, then you can really start. And yeah, that's what we will also do. We start with the real world example. So as I said, we here develop a product called Team Sports. The development on this product started back in 2011. So it's quite old for a product provided as SaaS solution. What is it? It's a content management system dedicated for sport club websites. So at least here in Germany, there are a lot of sport clubs, and all of them need websites. And normally, those sport clubs don't have people who are really good at doing websites, and that's where our product is placed. So they can easily set up a nice-looking website. And what's even more important, on this content management system, they can share the responsibilities. So there are different access levels. For example, for trainers, for the one running the whole club, etc. So the content management system is really dedicated to those websites, and bring features like writing articles about your last match, for example, for your upcoming matches, writing about players, etc. So today we have about 160 tenants which are using Team Sports, and we also do have self-service for website generation. This all is written in PHP and is using a quite heavyweight framework called Cake PHP. And so those figures you see at the moment aren't all right at the moment, because normally our monthly usage would be about over 1 million unique users and over 50 million page impressions per month over all this 160 tenants. But yeah, due to Corona, those amateur sports have come more or less to a halt, and that's why we don't have this usage. But you can see it's it's not a small application. It's it's a bigger application, and is a usage, and so you have to keep that in mind when planning the migration. So to get to be in a more technical view on team sports, and also do the current state analysis. So one of the main pain points is it's at the moment a single tenant application. This means each tenant has his own instance with his own database and his own code deployed. And this is done, so a couple of instances then put on one server and running there. So we currently managing those servers, which is another big pain point, that we have a lot of effort for maintaining those servers. One of the nicer things we have already implemented is continuous delivery. So otherwise we wouldn't have a chance to deploy any update to all those instances. You couldn't do that by hand. And as I already said, we use Cake PHP there as a framework. And what it does is it has an MVC pattern. It does the routing, for example, for us and things like that. So it's very heavyweight, and it always displays whole pages. So you don't have any asynchronous calls like you have in modern single page applications. The whole site is loaded, which is also a little bit of a drawback of the current architecture. And I also noted down, currently we don't have any redundancy there, because high availability isn't that much important for those sport club websites, because they are more cost sensitive than sensitive to outages. So after that analysis, we can go on to the objectives we want to reach with the cloud migration. As I said, currently we have a high effort for maintenance, and that's our number one priority, to reduce this effort. I also said because of the deployment, we have continuous integration, and we also want to have this after the cloud migration, and even have a so-called one-click deployment. So you just either have to check in the code on master or make one click, and then the whole application is deployed in a newer version. So on the left of this page, you can see the usage of the application during a week and during the year. And you can see that, it's mostly used on the weekends. That's, not really surprising, because normally sports is done on the weekend, and then the site is the sites most used. And also, over the year, we have less usage in the summer, because the sport leagues are not active, and the same goes for some of the winter time. So there are cost reducing potential by having more elasticity, and also have more scalability, and to reduce the costs and only provide as much resources as needed at the moment. So I said you have to rank your objectives. So I ranked high availability the lowest. As I explained, this isn't that important for our customers here. And after we have defined our objectives of the cloud migration now, so let's jump right into the perfect architecture I would use for the requirements of this application. So I use here the AWS services, but there are comparable or really similar services in the other cloud providers. So Microsoft Azure also provides, for example, a serverless service called Azure Functions. Google Cloud does the same. I did it with AWS services, but you could also do it with one of the other cloud providers, or even mix the cloud providers. So the first thing I would do for perfect architecture is using a multi-tenant architecture. And instead of loading always the whole page, I would go for a modern single-page application. As I said, we often do develop React web apps here, so I would go for React. And as a backend, then run serverless, I would use, for example, Node.js, because for all those serverless applications or services, you always have to think about the cold start time. So the time when a function hasn't been called for a long time, how long it takes to start it. And this is really short for script languages like Node.js or TypeScript, which is could be used in a Node.js setting. Languages like Java or C# would take much longer time, and there aren't really heavy computations here for this application, so I would go for something like Node.js. What I would also use as an entry point for the user then would be Amazon API Gateway. It brings intelligent routing with it, so then you could decide either go for the Lambda function and query something from database, or go to S3 to load some static content. What you also could integrate it with is Amazon Cognito. So Amazon Cognito is an authentication and authorization provider, and then you could at that level already decide if someone is authenticated to do a certain action, and then only forward it the request if he is authenticated. What this API gateway also provides is a caching mechanism. So you don't have to do all the calls to your database done, but can cache it for some time. And yeah, that's always a tricky question, to have the right caching time. So as a database, I would go also serverless with Aurora Serverless. So you have this elasticity and scalability also in your database. For the deployment, I would go for code build. So you can have this one-click deployment, and code build nicely integrates with AWS code commit. So I would also use that. So this would be my perfect architecture if I would just have the idea of team sports at the moment and want to build it. So, and to going back to our objectives, so with the serverless approach of Lambda and also Aurora, we have this main goal of zero or almost no effort for maintenance. And code build provides the one-click deployment, and also the high elasticity comes with those resources. So, as I said, you can have this perfect architecture, but normally you have to adapt it because there are limitations from the already existing applications. So one thing I would leave out when doing this migration is the cloud, the authentication provider, so AWS Cognito, because there is already some authentication authorization provided in the current application. This is done via database request. It's not the prettiest way to do authentication nowadays, but it works well. And so I would take this code and don't lose any of the learnings in this code. And to even use this code, I wouldn't go for Node.js on the functions of Lambda, but use the PHP, the existing business logic there. This would also be changed to the perfect architecture, or more or less an adaptation. And another adaptation would be integrate GitHub with AWS code build instead of the code commit. And the more tricky thing would be the switching to multi-tenancy. This is not really cloud-specific multi-tenancy, but it does. Then you can really use the strengths of this cloud setup when you have multi-tenancy. And also by this setup, we have the objectives reached of zero maintenance and high elasticity and scalability. as well as the one-click deployment. And what we also get, so to say, for free is the high availability, because Lambda, S3, and also the API gateway have almost zero outages. So as I said, after defining this adapted architecture, you have to plan smaller steps, because you don't want to do this switch to the cloud in one big step, but have smaller steps defined. So what would be the first step? And here it gets quite interesting, because as you can see, I switched Lambda for Elastic Beanstalk. Why did I do that? So what can Elastic Beanstalk do? It can provide you an application environment. In this case, it would be a PHP environment. And but you also, just like in serverless, you don't have to think about maintaining it. So you don't have to do operation system patches, and you wouldn't have to do patches of your application environment. What is the great advantage here of Elastic Beanstalk in the first, before using or going to a serverless model? The advantage is we could more or less have the whole application written now with the Cake PHP framework ported there, because the routing and things like that could also be done by the framework, and we don't have to throw away that much code or change code. So this would be a really good first step, because it makes it quite easy to move to the cloud without overthrowing your whole application. And what we already have there is that we have this minimal maintenance effort, and also the elasticity. So we already neared our goals and have not that much effort. But as you said, the adapted architecture looks a bit different, and also the thing with the single page application would also be really nice to have, and that's what is started in the second step. So there's the starting to switch to a single page application. So a single page application with its asynchronous calls really nicely integrates with the serverless model of Lambda. So you can have this asynchronous call go to one Lambda function and fetch the data. So in the second step, we would have Elastic Beanstalk and Lambda side by side. So Elastic Beanstalk would host what is still left of the old application with the Cake PHP framework, and Lambda then would have the somehow transitioned business logic in separate functions. So in the step 2, the routes that lead to Elastic Beanstalk would always all the time get fewer and fewer, while there will always be routed more things to AWS Lambda. So what you can do is start your single page application only for one region of your application. So for example, in a content management system, you have a backend, and the user can administer some parts. And that's, for example, one point where you could start with your single page application, that you have it there for some of the administrative stuff, while the whole front end still runs the full-blown Cake PHP application. And that's what it meant, that do small iterative steps to get nearer your then adapted or perfect architecture. What we also have, this is a bit more of a complex setup then, but what we do get is already the elasticity of Lambda, while we still don't have to transfer everything to a single page application and to the serverless application model, but can do it in small steps and already have Lambda and its elasticity. So then When all has been transferred from the Cake PHP application to Lambda and the serverless application model, then we would have our adapted architecture we defined in the beginning. So, but by this, we completed our objectives. So we reduced the maintenance effort. We have an easy deployment by code build. We have the elasticity and scalability of Lambda and Amazon Aurora, and also have high availability by default, more or less. So to wrap this up, what are the key takeaways for a cloud migration you should take from this presentation? So in the first place, be always aware of your main goals and main objectives. Rate them. What is most important for you? So in this example, it was zero maintenance was the most important goal. Sometimes it also plays well with other goals, but sometimes you also do have to make trade-offs. Give yourself the time at the beginning to think of a perfect architecture. Think freely there. Don't think about the limitations your current application has. Don't take too long for that, but do it just to have a feeling what would be possible. And then you can choose which trade-offs you want to make to get from your perfect architecture of a greenfield project to the most suitable architecture of your existing application when you want to move it to the cloud. And as a last but very important point, in my opinion, is do a cloud migration always in small steps. Try to get something to the cloud of your existing application as soon as possible, because this will give you a hint where could be problems and what you could achieve. Yeah, and that's my biggest suggestion, and that's also the end of my talk. So thank you very much for your attention, and I hope to see you all in the Q&A session. Thank you.
Thank you so much, Philip, and I hope that you can hear me right now. You know, sometimes... Oh, awesome. Because sometimes when we are broadcasting live, there might be some technical issues slight, but hopefully we managed to take care of them right away. Thank you so much, Philip. Really soon, definitely we'll hear you more, and you will have the possibility to ask him questions more. And right now we're moving forward because our next speaker is about to start just in a minute, who is John Savill, and who is an author and Savill Tech. And he will tell you more about building resilient services in Azure. He's been working with Microsoft technologies for over 25 years when he first stumbled across Windows NT by accident when Control-Alt and Delete did not give me the expected response, but rather popped up a strange security dialog. So honestly, if you actually have a look at John's bio really quickly, I'm sure that you definitely read his bio, short bio at least, on the website, on our website, for example, or you Google it, but definitely interesting topic, interesting thing to watch. So please stay tuned, stay with us. He'll be back very shortly, and please remember, prepare your questions. I can see that in our comment section in YouTube, you already you're asking questions. Philip, you are asking, if I'm not mistaken, there was some question for were there some questions for Paloma as well. But just in case, you still have time, because we're going to ask them questions during Q&A. And don't forget that during this time, you can actually win a ticket. Don't forget only about the hashtag question for ticket. We'll be back very soon, so please welcome John Savill.
Hey everyone, welcome to this session on building resilient services in Azure. My name is John Savill. I've been working with Microsoft technologies for over 25 years. I recently published my 9th book. This was all about architecting Azure services. I have a large number of courses on Pluralsight, I have a very, very active YouTube channel where I have playlists around Azure Masterclass with like 20 hours of content. I do a weekly update. I have lots and lots of deep dives. So a lot of just free content, no advertising available there. Outside of computers, I enjoy fitness training. I do a lot of Ironman events, hopefully going to Hawaii this year. Now, for this course, I really want to talk about, well, do I even need to worry? It's the cloud. Hey, I deploy things to the cloud. I'm good to go. So is that true? Spoiler alert, no. Then I want to try and think about, well, what are we trying to be resilient against? What are the types of failures we may actually encounter? I think about different blast radiuses. I can think about what a disk could fail, a node could fail, a rack could fail, a data center could fail, a communications line could be cut. There could be a natural disaster. They each have different levels of impact. So what do I think about and how can I build resilient services against them? And then some special considerations to when I use multiple regions. So first, do I even need to worry about this? Again, you think about, I'm going to the cloud is indestructible, I'm good. And sometimes you'll hear, and I've seen people with t-shirts, and it will say there's no such thing as the cloud, it's just someone else's computer. And there's a small element of truth to that. Now, obviously, the cloud is more than just capacity, which would be someone else's computer. There's services, there's management, there's a whole rich tapestry of things around it. But fundamentally, there's still physical constructs that house the resources, servers in racks in buildings with lines of power, lines of communication. So do I need to worry? Well, it depends, but realistically, yes. Azure has this whole shared responsibility model. I can think about what am I responsible for as the customer? What is Microsoft responsible for as the hosting with Azure? We hear about different types of service, infrastructure as a service, platform as a service, software as a service. Now, if it's software as a service, if it's Office 365, if it's Dynamics 365, it's not really my responsibility. There's really nothing I can do to impact the availability of my service. That's down for the provider. But if it's infrastructure as a service, i.e. a VM in the cloud, if it's platform as a service, for pretty much all of those, I still have to consider availability. Often with those services, I'm still deploying to maybe a certain region. I'm picking certain replication or resiliency options. Now, things like Azure Active Directory, once again, that's a managed service. I don't have much control over that availability. There are SLAs around that. That's really Microsoft's job. But even within Azure AD, there are things I can do to make things more resilient. Managed identities, for example, for my applications are more resilient against hiccups in Azure AD. Having longer lived tokens, but using things like continuous access evaluation can again make me resilient if there was some kind of Azure AD hiccup. But what am I actually trying to be resilient against? Now, we always think about, well, there's the application, there's an operating system. Whether this is infrastructure as a service, i.e. a VM, whether it's a PaaS, there's still an underlying OS there. There's still your application and they can fail. So I want resiliency against the failure of my app against the operating system. Physical boxes, they're still servers. Now there's great resiliency built into the servers, redundant power, networking, but nodes still have failures. Racks have power supply units. They have network switches. Things can fail. I can think about an entire data center can fail. And once again, we have to think about, well, the data center, it has power and they have generators, they have resiliency, but ultimately things can fail. Network communications could fail. And failure doesn't necessarily mean a physical problem. there's a whole set of infrastructure and software that runs Azure. So if they deploy a software update, well, what if that knocks out a portion of Azure because there was a problem with that? We can have region level outages. Now, obviously, they're very rare, but it could happen. There could be some kind of natural disaster that knocks out an entire region. And when we think about what do we want to be resilient against, all of these things to this point have been a failure of some kind. But realize there's also planned maintenance. Within my app, I want to roll out a new version. Well, I don't want to take it down. Maybe I have a maintenance window. Maybe I don't. So maybe I need kind of maybe blue, green, or I'm doing rings of deployment or canary. There's different methods, but I need multiple instances to be able to roll those out and a means to balance the traffic coming in. Azure itself, they have a whole set of workaround. Don't have to reboot the box to even patch the kernel. Things like preserving host update to update the box without actually having to shut down the VMs, just pause them in memory for a few seconds. But there is that planned maintenance. And we always have to consider there's a compute side, i.e. doing work, and then there's storage, our state. And I have to think about both elements for resiliency. Now, maybe I have something that's pure cattle, it has no state. Maybe it's ephemeral storage on the host itself. But when I think about resiliency, often I have to consider the state is actually more important. The compute I can recreate pretty quickly. I need to be able to get the state back, be it in a database or on a disk or something else. And I have to understand what is my resiliency requirement. How much data can I lose? How much time do I have to get up and running again? What things does it depend on? So I have to know my service to really be. Hey, everyone. Data centers. And I have to think about both elements for resiliency. Now, maybe I have something that's pure cattle, it has no state. Maybe it's ephemeral storage on the host itself. But when I think about resiliency, often I have to consider the state is actually more important. The compute I can recreate pretty quickly. I need to be able to get the state back, be it in a database or on a disk or something else. And I have to understand what is my resiliency requirement. How much data can I lose? How much time do I have to get up and running again? What things does it depend on? So I have to know my service to really be able to work out what I need to do and what I need to be resilient against. Now, when I really think about what is Azure, well, Azure's capacity. Capacity in terms of compute, in terms of storage, in terms of network, in terms of specialized things like GPUs, but it's capacity. And then of course, that capacity has to be exposed. Now, on premises, we have capacity. Well, Azure, whereas on premises we have capacities, probably VMs, maybe containers, Azure has a whole set of services to expose this capacity. VMs, containers, platforms, databases, machine learning, a whole set of different things. But they're provided by physical constructs. Now, the first one is a region. This is really the first physical component we use. When we create a resource, we almost always have to say, well, what region am I deploying to? Now, there's a huge number of regions distributed globally. If we go and take a look, for example, here is Microsoft's kind of global map of regions, and we can see there's a huge number in the United States, in Europe, China, India, Asia, Australia, South Africa, Brazil is building out. So you can kind of go and pick, for the most part, any of these regions. And you'll notice there's typically always at least 2 regions in any geopolitical boundary, so that I can deploy my app, my data to a region, and have resiliency replication to another region that's hundreds of miles away, but in that same geopolitical boundary. I could go to East US to West US, North Central to South Central, Europe, etc. So we have all these different kind of regions. Now, I can really think about a region being comprised of one or more facilities, data centers, and it's really bounded by this 2 millisecond round trip latency. So that means it could be many miles apart, but it's within that 2 millisecond latency envelope. Now, what you'll also see is Azure regions are actually paired. Now, you don't have to use these pairings, but it is recommended. So if I jump over for a second, this is my YouTube channel, by the way. But if I go and open up the paired regions document, what it actually talks about is what are the pairings. You can kind of see, hey, look, there's kind of East US to West US, East US 2 to Central US. It keeps it within the same geopolitical boundary. Now, the reason we might want to use these, and it is recommended, is that some services, like storage, globally redundant storage, it has 3 copies in the primary location, asynchronously replicates to the paired region, where there's another 3 copies. Azure Key Vault, it has resiliency that it can fail over to the paired region. Backup builds on GRS, so the backup is replicated to the paired region if I turn on that geo redundancy. But additionally, beyond just maybe replication, Azure rolls out updates. When it rolls out an update, it will never roll out the same update to paired regions simultaneously. Because if that update had an issue, you don't want to take out the primary and the secondary. So in terms of service rollout, by using paired regions, I'm guaranteed to not get the same Microsoft update rolled out at the same time. So that's really probably the biggest reason to use those kind of paired regions. Now, some services also have built-in replication based on those region pairs, like, as I mentioned, GRS. Others you can pick. A lot of the database services, for example, the platform as a service, be it Azure SQL Database or the Azure Managed Database for Postgres or MySQL or MariaDB or Cosmos DB, I can pick where I want these async read replicas, or in Cosmos DB, it could even be writable. So sometimes we have our own flexibility. Even Azure Storage has object level replication where I don't have to use GRS. I could pick, hey, I want to replicate this container to this other container in this region I pick. Now, regions are selected based on considerations such as susceptibility to a natural disaster. I'm not going to build on top of a tectonic plate, for example, a meeting point. I'm not going to build in a floodplain, but it can still happen. There could still be a region level event. And so we have to consider, well, I deploy to a region, something could happen to the region. That's kind of my first blast radius, that I could knock out the region. Then we get to availability zones. Now, a region, as I mentioned, is made up of multiple physical facilities. In some regions, they are exposed as availability zones. Now, each availability zone, there is no guarantee of distance between them. They might be miles apart, they might be a couple of 100 yards apart. The point is, they are different facilities and they have independent power, cooling, and communications. So my goal here by using availability zones is to restrict kind of that impact that can happen. I'm restricting any particular fault that impacts one facility, be it power, cooling, communications, maybe a fire, should not impact another availability zone. So it gives me resiliency at the building level. Now, I'll see 3 availability zones. It is a per subscription logical mapping. I'll see AZ 1, 2, and 3. If I was to jump over, if I go to my subscription, if I say, for example, the simplest thing I could do is, hey, well, I'll create a new virtual machine. Now I have to pick a region that supports availability zones. If we think back to all the different regions, they don't all support AZs. For example, if I was to pick, let's see if I pick one, if I was to pick West US, availability zones here are not supported. But if I was to go to West US 2, I can pick availability zones and I'll see 1, 2, and 3. So I'll always see 3 availability zones. This is a per subscription mapping. And so I can think about, well, that availability zone could break. There could be an incident. There could be something that happens. And there is no consistency between different subscriptions. To kind of emphasize this fact, here I could think about, well, I've got this region. Now that region is made up, let's say 4 buildings, could be 16, it varies. Then I have a subscription. Now my subscription 1, AZ 1, 2, and 3, point to buildings 1, 2, and 3. Just happens to go that way. My second subscription, well, its AZs point to completely different ones. Its AZ1 is the other one's AZ2. Its AZ2 is the other one's AZ3. AZ3 is a different building completely. There is no correlation between subscriptions. The point of availability zones is it helps me control isolation from instances. If I deploy 3 VMs to 3 different availability zones, I know those 3 VMs are in 3 different physical facilities. I'm minimizing the blast radius of something happening to any individual facility. There are some important terms that we really have to think about when we get to availability zones. The first one is zone redundant. So sometimes you'll deploy a service and it has an option of zone redundant. That means the service is automatically deploying across multiple availability zones for you. Nothing I need to do. It is redundant, resilient against any particular availability zone problem. So I don't have to worry about it. Then we have zonal. If it's zonal, it means it's deploying to a specific availability zone that I select. For example, NAT Gateway has a zonal option. I can pick, I want it to be in this availability zone. So it's not redundant against any particular zone failing. It's in one zone. So if I do zonal, I would probably deploy zonal instances to multiple availability zones. So I'd have a NAT gateway in AZ1, a NAT gateway in AZ2, a NAT gateway in AZ3, for example. But it's letting me control where it is, so I can make sure that I put the dependencies in the same AZ. I don't want these cross AZ dependencies. I want each AZ to be kind of self-contained and dependent, so any particular AZ failure doesn't impact resources in the other availability zones. And then you'll see regional. Regional means it's just deploying it somewhere. I'm not picking an AZ. There's no AZ exposed to me. It's obviously using physical facilities, so it may be something that's used by AZs. It may be that it happens to align with my AZ1. I don't know. I can't see it. By blind luck, it may distribute them over multiple AZs. It may not. When I deploy something as regional, I'm basically saying, I don't care about kind of AZ level resiliency. I just need this thing deployed. Now, you do want to be careful when you start using things like availability zone, services that are zonal or zone redundant. Make sure you're consistent. I don't want to deploy some things as zone redundant, but then it depends on something that I have no control over. I won't want to have zone redundant services that use something that is regional, because the chances are that regional thing, if something happened to one building, it might take out that whole service. So you want to be very consistent when we use these things. And then there's availability sets. If I think about a particular building, it has multiple racks in that building. So what availability sets do is they say, look, we're going to spread this over kind of up to 3 fault domains. A fault domain is an individual rack. So I create an availability set, and then it just round robins distributes the resources over those 3 racks, those 3 fault domains. There's also update domains that I can pick between 5 and 20 when I'm doing staged rollouts of my app. When Azure is doing rollouts of its updates, it would only impact whatever percentage based on the number of update domains I have. Now, a key point here, though, is availability sets are being de-emphasized. They were there before availability zones. They give me resilience from a rack level or node failure. But obviously, availability zones are better because it gives me resilience from an entire data center outage. And additionally, there are a number of services now that are built on virtual machine scale sets where you'll see this FD equals 1, fault domain equals 1. That doesn't mean use one fault domain. What it's basically saying is distribute over as many fault domains as you can. So if I deployed, for example, a virtual machine scale set in a availability zone, and I set FD to 1, it's going to use as many racks as it can. It might be 5, 10. It's not limited to 3. So you are going to see now moving beyond the kind of 3 fault domains you have with availability sets and just saying, hey, look, distribute as much as you possibly can. Those are the key constructs that we're going to have: regions, availability zones, availability sets. So what does this mean? So you need to understand your service requirements, understand its dependencies, understand what is the recovery point objective, i.e. how much data can you lose in an unplanned scenario. In a planned scenario, you shouldn't lose anything because we should kind of shut it down, finish the replication, and then start it up again. What is our recovery time objective? How much time do we have to get up and running? Because those really are going to impact. Because if my recovery time objective is not super aggressive, maybe it's 8 hours, I can just redeploy the resources, maybe restore a backup. I'm fairly flexible there. If it's a very aggressive recovery time objective, I probably have to have resources up and running, replicating data, ready to start up. The recovery point objective is, well, how much data can I lose? Again, if it's very aggressive, hey, I can lose 10 seconds, I'm going to need to do replication. If we can lose 12 hours, maybe it can regenerate the data, I can probably restore backups. So the combination of the recovery time and the recovery point will drive, is it replication? Is it backups? Is the infrastructure ready? Do I have time to just redeploy it? And it's really just the state I care about. And you obviously have to think about the cost. The further we go in terms of replication and ready to go means the resources are up and running. It's going to cost me more money. When I think about resiliency within a region, ideally what we want to think about is we like multiple instances. I want to think about at least 2, spread over availability zones, or availability sets if availability zones are not in the region. Now, this could be virtual machines, it could be virtual machine scale sets, it could be worker nodes for Azure Kubernetes services, it could just be worker nodes for app service plans. It varies. But Azure is consumption-based. We like scale out, i.e. horizontal scaling instead of scaling up and down. I can add and remove instances very, very easily. That optimizes my cost. And obviously, the more instances I have, the more resilient I am. Now, if it's PaaS, there's often going to be options for maybe zone redundant, i.e. spreading over multiple availability zones. It might be, hey, it's zonal, so then I would deploy multiple instances, one instance to each of the availability zones. But make sure all components have equal resiliency or better than you need. I don't want to have it as, hey, I'm deploying to multiple zones, and then just catch up here. And then I have something else that's just in one availability zone. Because then if that availability zone goes down, my whole service goes down. I want to make sure I have equal levels of resiliency. So that might mean, hey, I'm zone redundant on my virtual machine scale sets. Then I'm using an Azure standard load balancer, which can be deployed zone redundant. I'm using a standard public IP. The skew of the IP has to match the skew of the load balancer. If I'm using NAT gateways, well, then I need to start aligning based on subnets because that's zonal. So I need to have NAT gateways in each availability zone and make sure my networking is set up the right way. But there's a lot of considerations around that. Now, this does include items like storage. Remember, storage has different resiliency options. By default, it's LRS, locally redundant, 3 copies within a particular facility. I can do ZRS. It will spread the 3 copies over availability zones. Then there's things like GRS and GZRS, where it then asynchronously replicates to the paired region, where there's another 3 copies. But within the region, I have to decide what is my resiliency. If it has availability zones, ideally, we want to use those. Remember, if I'm using backups, and they can be GRS enabled to replicate to that paired region. So that's within the region. Definitely, I need at least 2 instances of my service spread over availability zones or availability sets, making sure I'm using good components. If I have single instance resources, it's tricky. Make sure you use, for example, premium managed disks. That still gets you a pretty good SLA. As you start going down standard SSDs and standard hard disk drives, the SLA decreases. For really the good SLAs, you need at least 2 instances in availability set or availability zone. If you're going to use multiple regions, and really you should be, true resiliency is going to come from deploying to multiple regions because, again, something can happen. There's no such thing as some indestructible set of infrastructure. Even multiple buildings, if there was some natural disaster, maybe it took out the power grid. Yes, there's generators, but there's still limits. You can still fry components, an electrical storm, and it will go down. So when I think about multiple regions, again, it comes down to that recovery point, recovery time objectives. My DR to another region could be, hey, I have a DevOps pipeline, CI/CD. It might be I have ARM templates or Terraform. I can just rebuild the infrastructure pretty quickly. Again, it comes down to the state. Where's the state? Is it in a database? Is it on a disk? So is that replicating? Is that backup and restore? It depends on the recovery point, the recovery time objectives. I might run active passive, so things are running and then I can switch over. Something in the cloud that is common is active. I'm actually running in multiple regions. This not only gives me resiliency from failure, but now I have instances of my service close to the users consuming that service. So it's a better all-up experience for them. Now, the challenge here is, yes, recovery point, recovery time will drive those decisions. But the ability to use multiple regions in an active manner is really driven by the application architecture and that data layer. Because if I want to have active hundreds of miles apart, well, if there's a database, normally with a relational database, only one instance is the primary writable. So that second instance is hundreds of miles away. If it wants to write, has to go and write hundreds of miles away and get the response back. So there's going to be a latency. Now, if it's very read heavy, I can have a read only replica, async replica close to it. So there are things I can do, but I have to consider that. Maybe I can move to Cosmos DB and have multi-write. But my app architecture really will drive the practicality of active-active. But replication can be accomplished. It could be through the application. My app running in VMs might have replication. My database, which could be part of Azure, the Azure SQL database, managed database for Postgres, MySQL, MariaDB, Cosmos, all have replication options to regions I can pick. If it's a VM, I can do a VM level replication, saying like Azure Site Recovery to another region or a different availability zone. A final closing thought, if you do go multi-region and it's public facing, I have to be able to balance the traffic. So if it's HTTP, HTTPS based, I can use Azure Front Door. That also will improve the overall connectivity by having edge locations close to the users to terminate the TCP, the SSL connection, then go over the Azure backbone to get big chunks of data, cache it and feed. If it's not, then I can use Azure Traffic Manager, which is DNS based, that will really work for anything. It's just name resolution. There's also now the Azure Global Load Balancer that enables me to have this Anycast layer 4 that then redirects to external load balancers. So again, I have to have a method for people to be able to come in and then point them to services in particular regions. So that's what I wanted to cover. I know I'm at time. Thank you for watching. Obviously, we've got the Q&A block. I'm happy to kind of jump over and answer any questions I can. But if you check out my YouTube channel, I've got a lot of videos there that goes into much more detail about all of these things. I kind of quickly alluded to it, but if you go to my NTFAQ guy, I've got playlists here. You can see like I've got an Azure Masterclass, which is like 20 hours of content. And then I check the comments, so ask questions there. I will happily answer those. But thanks for watching. Have a great day.
Hi, once again. Thank you so much, John. And we are moving forward, by the way, folks, to our Q&A session. Before we'll start, and actually Paloma, Philipp, and John will answer your questions live, I'll make an additional very important announcements, which I think for you will be definitely really interesting to know too, because guys, very soon and approximately already after I will make this announcement, it will go live. The proposal about QA Global Summit, which is going to take place on March the 2nd and the 3rd. And we would love to see you there among our viewers. But also remember that it's, first of all, it's most important for those who are considering QA as a career move or have already started as a QA engineer. So this event will definitely help you to be on top of practicing QA. But also you'll get additionally 2 days and 14 hours to learn about how to build QA from scratch, which mistakes to avoid, how AI can improve testing experience, and how to implement QA into development process, automate automated and manual testing, yin yang, and QA career path turns to take. But you know what's the most important actually announcement about this event? Is actually that right now the happy hour is starting. What does it mean? That throughout the next hour you have the greatest chance to get a ticket for QA Global Summit just for $30. And remember, this is only for this approx 60 minutes, so please be attentive. By the way, I'll share this also in our comments in our comments in YouTube, and also, so please remember about that. Let me just give me just a few like quick questions when I'll be back with that, and I'll tell you, and I'll share this information with you just very quickly. And meanwhile, very soon we'll move forward to our Q&A session. Have you already prepared questions for our guests? I hope that you did, because I think that for you it will be really valuable to, even for example, maybe for QA, additionally to win maybe generally ticket for free. So once again, give it up to Philipp, John, and Paloma.
Hi again.
See you all of you here. How are you doing?
Hey, everyone.
Once again,
Good.
I'll try actually right now to show as well questions for whom they have been already previously addressed, but also let me read out one of our Q&A session before. Question from Virgil, and he asked, in case of incremental migration to the cloud, how do you deal with network latency if the application is latency sensitive? The first question.
I guess it really depends on the application. If it's really sensitive to this, you might want to put both parts, which is sensitive to latency, in one step. But otherwise, there are also a lot of services that can reduce those latencies. For example, something like VPNs provided by the cloud providers, and using their backbone system. So yeah, you can do it also with latency sensitive applications if you want to.
Thank you so much, Philip. By the way, we have a comment from Ahmed about $30 question, which I said the happy hour we're having today. Please, Ahmed, remember that there is a possibility for you maybe to win maybe a free ticket if you, for example, ask interesting questions. So please be attentive. I don't want to miss any of the questions to any of our guests today, to our speakers. So if, for example, because we have a lot of as well comments from you in chat, if I'm missing something for our Pine Tool platform in the comment section, please type them in once again in YouTube comments so I can definitely see them. I got again questions for Philip, and later on I'll make sure who this question was also addressed to. So Philip, you spoke about the load times of Net and Java and Java VS nodes. Could you throw some light on Python load times?
Yeah, I've actually seen this question and did a quick search. So, and that's what I also experienced, is that Python is even faster than JavaScript or Node.js. So yeah, those script languages are quite fast at startup, while those compiled languages like Java or C# take a longer time for cold starts in serverless applications.
Thank you so much. By the way, I'll be asking you, and I want to again to remind you that you have the possibility to earn like a free ticket. Additional question, I think it's again for Philip, or maybe I'm mistaken. Would you be interested to know the cost differentials from hardware-based to cloud-based solutions without being tied into cloud provider solutions?
The question is what counts as tied into cloud provider solutions. So on all big cloud providers, you can run Docker containers with a little cloud or provider specific things. But I would guess, so Docker containers could run anywhere. And normally it's a bit cheaper to have your own hardware, at least in production. But what you need to calculate is also the maintenance effort you have for those. And that's why I would always go for things like serverless. If you don't have a really huge company that can manage all their own resources and have big resources on their own.
By the way, Paloma and John, you can actually also comment on this. I'm also waiting especially for the questions which are addressed towards you. I'm just checking them. So just in case, if you want to comment on this, you're also welcome. But also yes?
Yeah.
Can you hear me okay?
Yes, we can hear.
I mean, the only thing I would say about from a cost perspective as well, there's absolutely the hardware element, but exactly as you said, there's the facility, the hardware has to be housed in the data center. There's things like power, cooling. So when you start adding up the total cost of ownership of actually hardware on-prem, sometimes things like the electricity, the communications, the connectivity actually can start to cost more than just the cloud service. So if you're going to look at kind of total cost of ownership, you have to kind of think about all of those different elements to really get a good idea of what is the true comparison. It's not just the box, it's everything that makes that box work.
Yeah,
Thank you so much.
Can you hear me?
Yes, Paloma. Yeah, we can hear you. By the way, I just wanted to check because I should probably better announce you like Paloma Rodriguez or
Paloma Rodriguez de Aguiar.
Thank you so much because like I was just checking like I've seen just recently Rodriguez and I missed that.
I'm originally from Brazil.
I see.
Yeah, so just adding a comment, it's also possible when we are talking about cloud. So during my time, I worked for Oracle. For a long time, I was working more with on-premise solutions. So I did this transition, so making the movement for the cloud. What I can realize when we are comparing the price, it's also related about how the license are being provided at the end. So you have the role scenario, like I can have, it's the time to market. It's also a point, but the license also moves a lot, this kind of price that you can have at the end.
Thank you. Additional questions actually from James. In regards to scripting language and compiled languages, it depends what are you doing in it. As a lot of languages using DP or API are IO constrained, so the results can be similar to the basics.
So what I talked about were the cold start times. So the time after a function in Lambda or Azure or wherever hasn't been called for a long time and the underlying container needs to be started again. This is faster for the scripting languages because you don't have to install the whole framework like in C#, the .NET framework or things like that. And those interpreter for scripting languages are really tiny in comparison to those frameworks, and so the cold start times are much faster for the scripting languages. But if you have applications heavily using things which are faster in Java or C#, then it's really worth to use Java or C#.
Yeah.
Thank you. Yeah, Paloma, you wanted to?
Yeah. It's I'll just complement as well. So for instance. He did a question also about related for the database. So for database, we have like different APIs that can also help if you are not just using a relational database. Like for instance, I can have a very good result if I use an API that I can use for Java or JSON contents. And so this also can improve your performance at the end.
Thank you. And again, guys, these are like specifically, like for example, we have some specifically addressed to some of you, but in case if you want to comment and add, please, you're welcome. Additional question, and the request for your comments on the security issue for an on-prem versus public cloud.
I'll take a first stab at that. I think when you think about security, it's always a shared responsibility model. But depending on which cloud service you use, you may be responsible for more or less. So always think about with security on premises, we're used to the idea that the network was that security fence. Well, more and more we go into the cloud, the identity becomes more of that security perimeter. But if we think about an IaaS virtual machine, we're still responsible for many layers of that security, be it the network, the antivirus, the firewall configurations, the configuration, that's all our responsibility, and then whatever app services inside there. As you start moving up the PaaS layers, you're responsible for a bit less. I'm not focused on the OS security anymore. I just focus on, well, my application and maybe the communications into that. In the cloud, you'll often see a lot of services that will actually help with that security. They may have native firewalls, web application firewalls. They might have intelligent services that take your logs and then look for signs of intrusion. But more and more, a lot of those vendors, yes, they have a cloud solution, but they'll let you take that solution and use it for on-premises as well. They'll let you take the logs from those services and bring them in to use those maybe machine learning type algorithms to help detect a sign of an attack or an intrusion. But I mean, I guess for me, it really depends on what type of service you're using. It's always shared responsible, but the further you go towards PaaS and serverless, you're responsible for less, and it becomes more of the cloud provider. My 2 cents.
Thank you, John. Philipp, Paloma?
Yeah, I can totally agree with that. So you always need to have this shared responsibility model in mind. Yeah, and then you can choose in the cloud how much responsibility you want to have. That's a big advantage, I guess. So if you're not that familiar with one part of the security, then you don't have to do it if you don't want to.
Yeah, the same for me. So in cloud, it's like there is no cloud without encryption. So it's quite important. So you need to know also how you can deal. There are a few references or guidelines. Like, for instance, I can have my role database encrypted, but where I will have this keys. So there are a lot of things that you can explore a bit more, but I completely agree.
Thank you. Additional questions for Paloma. Considering real-time data processing and display, what are the biggest issues that you come across most of the times?
Yeah, when you're talking about streaming data in near real time, so sometimes this is also a challenge. So during my presentation, I mentioned about using Kafka. So for instance, most of the solutions that do this kind of synchronization of information from Messenger or for sensors, it's important that you can process this information with less latency that you have. So if you have data with a huge size, maybe you could process in an edge device at first, and after send this information for the cloud or for some serverless capacity that you have, because it's really demands a lot of information, and you need to have a good network with a low latency to be able to have this information processing in near real time. So Kafka, usually when I'm using for streaming data, it's a good point.
Thank you. Additional question for your applications, like team sports, etc. Have you implemented any schemes or mechanisms for auto-scaling, or just completely relied on the ones provided or by Amazon Web Services or Azure? Very important. I'll just want to add to our audience, please remember about the hashtag question for a ticket, because this is how we usually will be asking and like looking through for those who will win 5 tickets. 1 of 5.
So one of the nice things of serverless, so AWS Lambda, for example, is that you don't have to think about scaling. So you get that for free, and AWS does the scaling for you. On another cloud migration project which heavily relies on natural language processing for documents collected on the internet. There we have scaling based on the queue length or things like that. So you always have to see if you want to go for something completely managed by the cloud provider, or you have strong indicators if you need to scale up or scale down. Queues are a good example. So if the queue gets lengthy, then it's a good indicator that you should scale up, and you can do that automatically just by configuring it that way.
Thank you. If you want to add something, you're welcome. In that case, by the way, Philip, we have additional actually question to you, because don't you have to change the Cake PHP app in API to server React application?
Yeah, that what I meant in my presentation, that I would keep most of the PHP business logic, maybe break it up into several cloud functions. But of course, you can make an API out of that. And also for the Elastic Beanstalk I had in my presentation, you can use some of the business logic as API. And we already do this for some parts of the application. So this is also a viable way. So if you don't want to move to Lambda, you could also use Elastic Beanstalk and just change all of the Cake PHP framework, or better, the application written with Cake PHP into an API, and then make a single page application in front of that. Exactly.
Dear audience, if for example you still have approximately like no more than maybe 5 minutes, even less, to ask our dear speakers the questions, because remember, this is the time for you, like somebody of you have already previously commented, if you want like a free ticket, we are giving you this additional chance. And also Paloma, Philip, I won't be like John, like I would go more in detail, like because of the lack of the time, but very shortly, for those who are just starting, like for example following your footsteps, what are the best piece of advice you have ever like heard so far that you can share? And probably maybe after that we'll add like additional question 1 or 2, and we need to wrap up. What I'm trying to say, for example, if you are like a new, because we are talking about career pro track in this case, and in this case we are having a lot of additionally newbies in this case, not to offend anyone, but this is like how they call about developers or in any sphere. So what is the best piece of advice you've got, maybe from your teacher, maybe, or like have you been like taught like yourself, or that you can share for the time when we'll be wrapping up?
A really interesting question, not too easy to answer. I guess one of a good learning for me was always take small steps. Never try to think of all at once, but take small steps. Take small steps when developing your application. Take small steps when thinking about how it should evolve and how the architecture should look like. So that's what often described as emerging architecture, that you don't plan everything to the end at the beginning, but have a more raw plan in the beginning and then make it more precise step by step. Yeah, that would one be of my bigger learnings.
Thank you, John. Thank you, Philip. John, maybe.
So, I mean, I just think about it as a good way to learn something is to maybe set yourself a small project that you want to try and achieve. So you have some goal and just try and get hands-on with the technology. So start with something small, maybe something you're passionate about, that you'd like to create a little solution around, be it an application or an architecture in the cloud. Get hands-on, set yourself a goal. And the nice thing if you're using the cloud is you can make mistakes and just kind of try a different technology. You can be a bit more flexible. Don't be afraid to fail. And that's how we learn. So set yourself a goal, have something you want to achieve, and go for it. Get hands-on, and most people learn best by actually using something.
Thank you, Paloma. Here, I would actually wrap up. I still would want you to answer this question as the last one. The only additional question is here for you, and this is we'll have to. I'm sorry, but we'll have to finish. In your real-time data processing, how do you handle if a particular event is taking more time than expected? This is for you, and please also following the question. It's how we will finish our block of presentations right now.
Okay, so when we this kind of event, so usually in the event we have some time to live. It's like some parameter that we can use. So I can measure for my event if this event it's using too much time, or I can have some parameters to say I want to process this information because I don't want it to influence on my queue, or also I can have some kind of logs to handle this event later on. So there are different ways that you can handle this kind of information. So you can have parallelism, you can have serial model. So depends also about which kind of information you are processing. So if this information is mandatory for another event, so you need to stop and you need to handle it. If it's not, you can just have like some time to live and use this event to handle what's happening. So depends. So it's depends. And answer the questions that you did before. So for me, I like to think like about what is the problem that I need to solve. So I try to understand the final pain. So I know that this is a problem. So how I could fix this? Because if not, I could get a bit lost because it's so many technologies and I love technology. So I could try exploring something different. And for me, it's really important always look for an actuary reference. So we have Gartner, we have different mechanisms to look and say, oh, I have this reference, how I can explore and how I can fit my problem, my solution on that. So usually I like to act by this way.
Thank you so much, Paloma. I'm really sorry for you. Please, next time and during our next blogs, I'll ask our dear audience to be more active at the beginning, because right now already I can see that please ask your questions directly, probably in our chat, write it to Paloma, Philipp, or John, or find them on social LinkedIn. But we have to wrap up. I'm so excited. I'm so grateful that you joined us today and you dedicated your time, your patience, your shared your knowledge, and you've made great presentations. I really like, by the way, reading also great feedback from our audience. Thank you so much for joining today. Will happy to see you more, and I'm sure that we'll see you more at our future events and this event at other tracks as well. Thank you.
Thank you.
See you. Bye bye.
Bye.
Thank you. And our dear folks, I actually need to wrap up because in 5 minutes, the other block, which is about code development, and it will be actually preceded by my colleague Victoria Otroshenko. She will proceed with that. A lot of new presentations are waiting for you. Meanwhile, I just really quickly will tell you that still our happy hour, only throughout this time you have the I think amazing opportunity for those who especially are waiting for QA Global Summit to get your ticket for $30. So please remember, this is the lowest price so far. I've actually shared it in our comment section at in YouTube and at our platform, Pine Tool platform. So please be active. I'm so excited. I'm so grateful that you've been with us from the beginning, and please proceed watching us very soon. My colleague will proceed, and a lot of new presentations are waiting. And I'm happy, and I'm sure that you actually will have a great time. Thank you. Maria Wojcik was here today with you. I'll see you tomorrow, and definitely have a whale of time. Bye.
Oh, hi guys. Sorry, I didn't notice that we are actually live already. So, hello everyone. My name is Victoria and I'm going to be your moderator for the next couple of hours. So, actually, I'm participating in this amazing Geekle challenge. Aren't you? If you're not, you definitely should. So, I'm happy to announce that Geekle is running a challenge. Take a picture or video in front of the screen with Geekle Conference, post it in your social networks using hashtags like Geekleus, Geekle Events, and Geekle Family. And we will broadcast online the posts with the most likes. So don't miss your chance. And now we are ready to greet our next speaker, which is Carola Lilienthal. Hi.
Hi, Victoria.
How are you doing today?
Very good, thank you.
So,
yeah, a good day to do this, Geekle.
yeah, that's nice. So, Carola Lilienthal is managing director at WPS Workplace Solutions and loves to design good structured, long-living software systems. Since 2003, she and her teams are using DDD to achieve this goal. DDD and sustainability of software architectures as a topic of many talks she has given on various conferences. She condensed her experience from over 300 analyses of software system in her book, Sustainable Software Architecture. So, I'm sure your speech is going to be amazing. I'm really excited about it. And how are you? How is your mood today? How are you feeling about this event?
Yeah, I'm very fine, and I'm very curious about all the other speeches and how the public will react to my speech. So I'm very happy to be here. Thank you for having me.
Oh, we're really glad to have you with us, and thank you so much for joining. So you can actually share your screen now. We are ready to start with it. Okay.
I will do it. Wait a second. Here it comes.
Okay, yes, we can see it. So, Carola, the stage is yours.
Thank you very much. Hi, everybody. My name is Carola, and I'm from Hamburg, actually, which is a rather huge town in Germany with a lot of water and rainy weather at the moment. But anyway, I'm going to talk to you about my favorite topic, technical debt and software architecture. I saw that some of you said we love DDD in the chat, and Victoria announced me as a DDD expert, and I know a lot about DDD. You will see it in the background. I can give another talk on DDD another time. You will see it. It's in there because DDD is a wonderful technique to resolve technical debt as well. Well, what is technical debt actually? Well, this is a very, very nice metaphor to describe what happens in our software systems in their lifetime. And I normally try to help teams with 4 categories of technical debt: the lack of documentation. If you have nothing, this is a bit of a problem. I don't talk about a huge documentation, but just some architecture decisions should be noted, explained. Why did you do it this way? So technical documentation, not enough unit tests or tests anyway, big problem. Implementation debt and architectural debt. And this is the thing that interests me the most, a messy architecture. How does a system look like if you have that, and what can you do? And to explain to you what happens in the lifetime of a software system, I will use this little diagram you see on the next slide. We have low debt and high debt, the amount of technical debt, and the functionality that we can create over time, so the lifetime of a software system. And if you imagine you had the most wonderful team of developers, all very fond in architecture, you had a wonderful product owner, you had a good management that knows about the life of a software system and technical debt, you probably put a software system after some iterations and discussions with the users into the world with low technical debt. This would be wonderful. And what happens then? Then the life of the system in production begins, and you start to get questions about enhancements because your software is so wonderful. The user love it and the users need more. And you start to enhance it, to change it. People are finding bugs. You're doing maintenance. And this will start a process that looks like this. Whatever you do with a software system, if you change something, normally your first idea is not the best one. And this is why I put a yellow arrow there, which means that with a change, with an enhancement, or even a bug fix, you take in some technical debt. And you need, after a while, you need time to repair. You need time to improve the architecture because you've thought about your solutions, your enhancements, and you have to follow these good design ideas that appear in your head. So the normal and good way to develop software is to do maintenance and changes and then have some time for improvement. And you end up with this wave and you stay in a corridor of low and stable maintenance cost. This is the ideal world. Unfortunately, many of us don't have a chance to work like this. We don't get time to improve the architecture. And what happens then is, our architecture starts to erode. We start to do hacks. We start to enhance things that don't really fit, but we don't have time. And by this, we slowly get into a red phase. The arrows start to get red. But if you look at it a bit closer, you see that the arcs get smaller and smaller. And this means that with your time and your budget, you can do less and less enhancements and changes. The work is taking much and much longer each time you do something else. And finally, you end up in a corridor of high and non-predictable maintenance costs. Some of you might know that you have some legacy software that is really hard to maintain. You are frustrated, you don't get forward, you change something, the next day you have to redo it because everything broke down overnight. And if you're in that corridor, it's really hard for the team, for everybody. Management is frustrated because you don't get forward, product owners too, everybody is blaming you. What should we do? Well, we need to get away from there, and we can do this with refactorings. We can refactor the architecture and get back to the corridor of low and stable maintenance cost. This costs money, of course, and effort, and design ideas and architecture knowledge, but it is possible. The other thing that you can do with what some companies do, you can just do it one more time. You can start over from the beginning again and create a new software system. Cost a lot of money too. What I do with my teams is we try to help people to understand where they are. Are they in the low and stable maintenance cost corridor, or are they up there in the red or in the yellow, or where are they? And we do this with tools. We go there, we take their software, we put it in some of these tools you see here, and we analyze the architecture with them. Something like 1, 2, 3, 4 days. We do it virtually. You see my colleagues down there. They are all, not all of them are there every time, but these are some of our architects. And in the end, we tell the people what we think about their architecture out of the discussion with them and out of our knowledge about the past, what we have seen. And well, these days, I think we have seen about 300 different software systems. I just show you a diagram with 16 of them. We organize them into a scale from 0 to 10. On the left side, you see 0 to 10. And if you are underneath 4, you are red. You're in the corridor of non-predictable high maintenance cost. If you are good, you are up there between 8 and 10, and in the middle, you're yellow, between 4 and 8. And on the x-axis, you just have one system per unit there. So there is nothing interesting there. But the size of these systems indicate how big they are. So you see something here with 15 million lines of code, a very, very big software system in a very good shape from a point of view of technical depth and modularity. you see some other smaller systems in bad shape, another very big one. And all these systems, they are from various programming languages. I'm going to show you another diagram now so you understand. So we have seen around 300 software systems in all kinds of languages, in C++, C#, Java, TypeScript, PHP, SAP, PLP, so various software systems and various sizes. On the right side, you see the explanation, small systems up to 100,000 lines of code, a bit bigger, like 500,000, 1 million lines of code, 5 million, 15 million lines of code. And all these systems we have measured with the same process. We have standardized our view on them, and I will give you the standardized ideas how to look at software systems to give you an idea what you can do to reduce the technical debt in your system. All the languages have some specialities, or the sizes do say something about how a software system should be, but there are some general principles. And these principles that we use, they came from my doctor thesis, where I worked on complexity of software architecture. And what I did was I went to cognitive science and tried to find out what is really helping our brain to deal with complex structures. Because software is a very complex structure. You know that. You have a lot of classes, modules, packages, namespaces, directories, all kinds of things that are related to each other. Software is a complex structure for our brain, and cognitive science has examined our brain. What do humans do when they are confronted with complex structures? And they found some mechanisms, some things that our brain is doing to deal with complex structures. What is our brain doing? Our brain is doing something which is called chunking. I'm going to show you in a second what this is. Our brain loves hierarchies, and our brain has the capacity to work with schemata. Schemata is a very, very interesting thing. I will show you in a second too. We will start with chunking. When our brain is confronted with complex things, my sentences are already complex, our brain starts to take smaller bits and pieces and put them into higher chunks, small chunks into bigger chunks, and again into even bigger chunks. This is what your brain is doing now as well, all the time while I'm talking. You're chunking the ideas that I try to get over to you, because your brain is only able to store 7 to 9 pieces of information. Then it has to chunk, to abstract in the end, to create bigger chunks, to have more things in the storage. This is a very interesting thing that we do, but it only works if the chunks we are trying to chunk, so the bits we're trying to form into a bigger one, if they are related, if they have something to do with each other. Bits and pieces that don't have anything to do with each other are very difficult to chunk. And in software development, we can see this a lot, that we try to put things into higher abstractions, into coherent pieces. And our word for this is that we try to create coherent modules, high cohesion and low coupling. This is what we do, and we call it modularity in our profession. So modularity is a very, very good concept, but it will only work if you create modules that represent a coherent thing. We have other words for that in our profession. High cohesion and loose coupling. I told you already. Responsibility-driven design. This is as well pointing into that direction. If we have several units that have together one responsibility, then we can chunk them. We can say, oh, they are doing this, chunk. They are one, and this is a good view of modularity. And you should program your software like that, not like those two people on the other side in this little comic. One of them says it's crucial to find a good name for your class. which reveals its purpose. Exactly. And then the other one, they look at the screen and then he says, like crap, I don't know where else to put in. And then the first one says, exactly. And this is as well pointing us into this direction. Naming is key. It's written underneath of this little comic. This is it. If you can't give your class, your package, your namespace, your project, your module, however you name it, if you can't give it a proper name that describes its responsibility, your modularity is not in a good shape. Think about it. And this is because your brain wants to do chunking. Okay, the second mechanism of our brain to deal with large structures is to form hierarchies, to try to find hierarchies. The cognitive scientists have done a lot of tests and experiments with human beings to find out what human brain likes. And our brain likes hierarchies, things that are higher in the hierarchy with parts in them and so on. We prefer that. They have done a lot of experiments, and I will show you some examples of that in real software. But before, I would love to share with you my knowledge about schemata, because this is really amazing. Schemata are ideas that we form in our head about the reality. If I tell you, my parents have been teachers, in your head, the teacher schema starts to work, and you start off to think of what is a teacher doing. You start to think of your own teachers maybe, and some of you might think, oh, this must have been a difficult childhood with two parents as teachers. Or you think, oh, this is why she's talking so quickly, or whatever. Whatever is related in your brain with the schema teacher. If I tell you my father was a hammer, there's nothing. No schema for this profession. Why? Because we don't have it these days. People who had the profession hammer were those people who were transporting the goods along the Alps, the hems of the Alps, when we didn't have lorries, trains, and all these trucks and all that modern forms of transportation. So now you know, now you have the schema. Schema helps us to recognize things, but they make us much quicker as well in understanding, in remembering things. And this is another possibility of our brain. I will show you what this means. The cognitive scientists took a chessboard and they put the figures on the chessboard and asked a chess expert to remember the setting of the figures. 20 seconds, remember what you can, and then they took off the figures and asked the chess expert to put back the figures in the setting that he remembered, he or she. And they did this with chess experts and with people who didn't know anything about chess. And the result was that the chess experts were able to put back twice as much figures on the chessboard than those people who didn't know anything about chess. But this only worked as long as the chessboard and the figures were showing a reasonable setting. If there was chaos on the chessboard, a setting that didn't say anything to the chess experts, everybody created the same bad result. So the chess experts were only better than the people who didn't know anything about chess if they could use their schemata of chess setting and remember by this much more. So this is a very important possibility of our brain. And in computer science, we do have something like this. We do have our own concept that is perfectly reflecting the idea of schemata. We have design and architecture pattern in our software system, in computer science as a principle. So I hope that you are using design pattern or any kind of pattern in your programming, and this is important, you are using them consistently. So if you have pattern, please use them always the same. So now we get into examples of real systems. We start with hierarchy, but you will see modularity and pattern are already in there. In the 90s, I was teaching at the university, and we told people, you have to do hierarchies. You have to do technical layering in your software. And this was already a good idea, because before everything was mixed up, we had SQL statements in the user interface and things like that. So it was good, but unfortunately, we were not able to see that software would grow and grow, and we actually don't only need a technical layering, but we as well need a structure on the domain level. We need domain modules, and we have to layer them too. I will show you an example now from a tool of a real system, how this could look like. This is a Java system, and I was called by the architect who knew me already some time, and he said, Carola, could you please come by and check the system with your tools and give my team some advice, because we're going to start soon a big enhancement. I think we will double the size of the system, and I want them to do that from a good architecture basis. Okay, I said, I come by. How big is it? Oh, 100,000 lines of code. Okay, I come for a day and work with them on the technical layering and talk with them about domain layering. I went there, and we worked the whole day. We had a lot of fun. And in the evening, they had something like 40 refactorings to do. And I told them, listen, the architect asked me to come back in a year when your enhancement is done. And then I want to find a good technical layering and a domain layering. And this is always good if you tell people that you will come back, because I will show you the good result they presented to me then. What you see here are two pictures that I took in the tool Photograph. I will explain to you what you see, so don't worry. On the left side, you see the technical layering. In the middle axis, there are these squares. These squares are modules that we have created in the architecture analysis tool. We have created these modules and put part of the package tree and the classes in there. So we divided the system. If you look at it, it had now 200,000 lines of code, so it had doubled its size. We put them in around like 20 or 25 modules. You see them here. Some are darker, there's more in there. Some are of a light green, there's less in there. So you can imagine the package tree is divided into these modules. And then you see those arcs. And the arcs on the left side, they go downwards. And the arcs on the right side of the axis go upwards. And these arcs are use relationships between the classes. So in the upmost module, there is a class or some classes that need something from the module down there. So you can follow the arc from upwards, downwards. And now the layers. Where are the layers? Well, if you look at it a bit closer, you can see that there are these lighter blue cuts in this graph. After like 10 modules, there is the first layer. So the upmost 10 modules form the user interface layer, and then there is the application layer, domain layer, and some infrastructure layer. Okay, we looked at it with the architect, and I praised them a lot because green is good, in a layered architecture. The relationships from up to down that go downwards are good. Those are good relationships, and there are not many on the other side of the axis. There is one which is very red, and it goes from the business logic to the user interface. You can follow the red arc upwards. And when we looked at it, the architect said, oh, this is great. This is the reporting component, the reporting module down there. I knew it had a problem, but I have never found it really. Now I can see it. Give me this picture, and I'm gonna ask my manager to give me some money to refactor it, because this is out of question. You can't use the user interface from the business logic. This is impossible. We have to do something. I said, well, you have the picture, no problem. The yellow ones were some smaller problem. Somebody had done some copy and paste and just used the wrong class, and not the interface class, but the implementation class. It was easy to repair. And I was happy that we found it at that moment, because copy and paste mistakes, they tend to get more and more. So it's very good to find mistakes and violations as early as possible. And then we took the same modules, the same squares, and ordered them from a domain layer perspective. So on the right side of the screen, you see down there several modules. They are on the left side too, but now they are differently organized. You see the same modules down there, the basic domain layer, and then some other layers on top. So this is the domain layering. And when I saw this, some small mistakes, some red arcs, some yellow arc, again, the reporting module that makes part of the mistake. So I saw it, and I was really, really happy about it. I told them that they did a great work to organize their domain in this sense. Of course, if you know domain-driven design, you want to go even further. You don't want to have modules that use each other, but you want to have them separate from each other. But this is a different story. I'm going to tell you another time, okay? The next example I have for you is a system with a very good technical layering, but it was really huge, 7 million lines of code. And the frustrating thing about it is, in the dark layer there in the middle is the whole mess. And you see this mess on the right side. You see 90 different packages. We didn't even try to organize them with some idea of layers. It's just a graphical organization that the tool did to put those who are not less needed downwards and the other one upwards. So this is what in domain-driven design we call a big ball of mud. This is a real problem. It's very, very difficult to maintain this system. And unfortunately, they didn't know about domain modules and cutting the thing into pieces. And we had to work a lot. So this system is in the corridor of non-predictable maintenance costs, and the one you saw before is in the corridor of low and stable maintenance costs. But on this level, it's hard to do something. So what we normally do, we look inside and we look at classes, and we often find cycles on the class level. So these classes here, this 119 classes on down there, they are all strongly connected with each other. They form a cycle. So there's no hierarchy. There's no up and down or anything. And when I looked at it the first time, I told the team, oh, please do something about it. It's only 119 classes in one cycle from 4 components. So this idea of components could give you a help to find out which one is rather the base classes which belong to the base module or the base component, and which other classes should sit on top. Please do something to get rid of this cycle. Unfortunately, they didn't get time. A year later, I looked inside of this system again. This is a C++ system, and the thing has evolved, unfortunately, into this. This is now a cycle of 327 classes from 8 different components, and they all need each other. No hierarchy, and by that as well, no modularity, because modularity says that you have some basic functions and other stuff is sitting on top. So a very frustrating situation where you don't know what to do. And I always tell people they are like black holes, and you can see it. It's black in the middle. Why is it so black? Because all these classes have connections to each other. There are so many arcs that you only see black. The tool wasn't even able to paint it differently. And now the last thing we will do is we will look at pattern. If you look inside of systems, you often find pattern like this. You find model view controller pattern for the user interface in various forms that we have these days. You find some services, and you find business objects and value objects, or in domain-driven design, the business objects are called entities or aggregates. So you typically find patterns. And the good thing about patterns is they help modularity and they help hierarchies. What are they doing? They help modularity? Yes, because they name the responsibility of a class. If I tell you you have to program a controller, you know very, very well what the responsibility of the controller will be. The controller will not create the view, the user interface. This is the job of the view. So the pattern names give you an idea of the responsibility. And if you look closer, you see that pattern create hierarchies as well. The controller uses the view and the model, but there is no other way around use. The view will never use the controller, or the service will never use the controller as well. So patterns are really great. And we look inside of those systems as well and look at the patterns to find out how the system is organized in pattern. This is the server part of a software system, and we have put the patterns on a clipboard that we have discussed them with the development team, and then we looked into the tool and we took all the services, put them into one layer, and so on. All the processes, all the importers, all the eventers, and you see a lot of green and not much red. And this is a very good result. Often systems are in a bad shape because the people don't work with their pattern, or they don't understand them. But this team did a really good job. And the good thing about doing this is you look at the system there where the people are programming. They are programming services. They are programming business objects. They are not programming layers. This is far too high in the architecture. So look at your pattern. Be aware of pattern that show the job of a class and that form hierarchies. This is very, very important. And by this, you can help your brain to work with an architecture. You will be much quicker if your software is modular in the sense of responsibility, low coupling. If you look at the sizes, you will see as well, and the naming I told you before. Hierarchies in your architecture help as well, that your brain gets around much quicker, and the consistent use of patterns. And I hope that you have a lot of pattern in your system, because that part of a system that doesn't conform to the patterns is always the problem. So I hope you go away from here with some information and you do something about your system. This was a very, very short intro into this topic. If you have more questions, follow me on Twitter, send me an email, look into my book. The book has a website as well with some more information, some other speeches of myself, and I will be happy to help. Thank you very much.
Thank you, Carola, for such a fascinating talk. I'm sure everyone enjoyed it.
Thank you very much.
Dear audience, don't forget to leave your questions in the comment because Carola will join us in our Q&A session, and she will be able to answer all of it. Yeah. Thank you so much, Carola.
Thank you too. Bye, and see you later.
Definitely. Bye. Okay, and now I would like to remind you that all our next videos and all the videos from our previous events will be available on our new subscription platform. I will share the link in the chat, so stay active and subscribe. Stay with Geekle. And we are ready to welcome our next speaker, who will be Nick Bhardwaj. Nick has been a solution architect and software engineer for almost 30 years, working in 3 continents and from startup to global enterprise. Focusing on aligning methodologies and process with tools and technology, Nick spends his time helping development teams adapt to and implement new technology and integrate with cloud and DevOps. Nick has founded and successfully exited 3 companies, and we are going to see his talk using GitHub to automate and deliver technology projects. And he will be here in a minute.
Well, hello and welcome to this session on using GitHub to automate and deploy technology projects. My name is Nick Beaujard. I've got a super session for you today where we're going to learn to use what is effectively a free online tool in the cloud to automate and deliver whatever technology projects you're thinking of. So a lot of people think about cloud projects or software development projects as being things which really work with GitHub, and they don't think that GitHub can be a tool you can use for all sorts of project management, no matter where you are. In this session today, you're going to learn how to use the tools available for free in GitHub to actually build, run, manage, and report on technology projects that you're running at the moment. So without further ado, let's begin. Here's some background. My name's Nick Beaujard. I've been a software architect for the last 25 years, been around the traps for many years, run a bunch of successful startups. There's been some awards. I've worked for Microsoft. There's been a bunch of history which has got me to the point now where I have a pretty finely honed way of running complicated technology projects. And there's a bunch of tools you can use. Today, however, I'm going to focus on using GitHub as your end-to-end management tool. Because it's free, it's really easy to use. It's very commonly used in the open source community, and the platform's just going from strength to strength. There's a whole bunch of things they're doing. Now, to understand and use some of the examples, if you want to, out of this session, there's a whole bunch of technology I use in this. You'll also need the snipping tool. Now, anything that captures screenshots will do. I don't mind whether it's the snipping tool or any other tool. I'm just quite used to using the snipping tool to make everything work for me. To edit Markdown, which is the language we're going to use to write documentation, I like to use Visual Studio Code. It's a great tool for doing that. It has a bunch of add-ons. It's highly supported. But then I write code for a living, so I'm a developer, so I understand how to use it. You may find other Markdown editors are better for you, but I'm certainly a fan of it, and you'll see me using it in the demos in this session. There's a tool which I wrote, which you're free to grab a copy of, which is the Project Documenter, and that uses issues and setup set in GitHub to be actually able to go and document and work with the projects you're working with. And finally, we use an open source tool called PamDoc, and PamDoc allows me to take a bunch of pieces of information written in Markdown and compile them into a Word document for giving to management and showing how the projects go. So without further ado, let's dive into the next section and let's have a look at technology projects. What are they? How do they work? So technology projects are really made of 3 things in my mind, and there's obviously a whole bunch of moving parts underneath them, but really a technology project has documentation as the core tenet. Writing things down is super important, both for you and your customer and all sorts of people. So I'd really, really encourage you to write down as many things as you can. Also, alongside documentation, you need to report. There are people who'll be paying the bill for this project, and they want to know how it's running and how it's working. So reporting's super important as well. And finally, the actual deliverable that you create. So those 3 things I think are the main pillars of a technology project. And I'm going to show you how to manage all of those using GitHub. So while a lot of these examples can be quite pie in the sky or quite ivory tower, what I want to do is I want to focus on a real world example that I'm working on at the moment. So we inherited a project that we're working on, which is some meeting software, which is designed to make meetings better for people using them. And it's some old software. It's an N-tier architecture, traditionally written in the legacy Microsoft.NET framework. it came to us with no documentation, no effective bug tracking, no project management, and no issue management. And so what I needed to do was find a way to get a project up and running really quickly on a budget using tools that everybody could access, so we could actually start this project running at some speed. And we had some limited resources to work on it. And so the platform we use to manage that project is what I'm going to describe to you in this session today. So let's have a look at how we get a project like this up and running, how we build it in GitHub, and then finally how we operate it. And let's put some demos in here as well. So the first thing to look at is how to set up your project and get it working. So there's a few steps in here, and I'll talk through them. First of all, in GitHub projects or areas are called repositories or repos in the kind of the GitHub sort of world. So a repo is something you use to store your documents, your issues, your projects, your tasks, your milestones, your releases. Everything lives inside this single thing called a repository or repo. So the first thing you need to do with any project is set one up. The next thing you need to do is create a bunch of labels. And we do this for managing tasks and issues. So GitHub isn't just a place where you can store code or documents or other things. It's actually somewhere where you can manage tasks, issues, projects, steps, milestones, etc. So there's a whole bunch of areas in GitHub that you can use to do project management, or focus a lot on that. But in order to classify things correctly, we're going to set up some labels. Now, GitHub comes with some out of the box, but there's some I like to create when we're doing a project properly. The next thing we're going to do is we're going to document the requirements of the project, but instead of documenting them somewhere that locks it away like a PDF or a Word document, we're actually going to document our requirements as issues in GitHub. And then we're going to use some tools to turn those into a specification document that we could give to a client. So I'm going to step you through now, using some demos, the various ways to set up your project. So let's go and set up a repository or a repo in GitHub. So let's grab a browser that you can see on screen at the moment, and I'm going to go up the top and choose repositories, which is the list of repositories. You can just sign up to GitHub and get a user interface. So I'm going to create a new repository, and let's call it Sol Arc for Solution Architects, and I'll give it a description. Which I'll just do underneath. Now, it is possible to set up repositories from templates, but that's not what I'm going to be doing today, because I want to show you how to set it all up. So we won't have any templates we set in. I'm going to make it public. So after this, you can go and see what we're doing. And I'm going to pop in a README file and a .gitignore file. And the gitignore file tells Git which files to ignore. And commonly, things like Visual Studio go and create a bunch of files we don't want. So that's what we're going to do there. And next, we're going to choose a license, and I'll just choose a fairly permissive license so you can go and play with this stuff to your heart's content. So once that's done, that's created my new area, which will be github.com/nikbo/solarc. And you can see that up there in the bar at the top left, that I've now got this repository set up. The first place it's going to take you to is this area called code. Remember, GitHub does come from a software development background, so it's going to start focusing on code, but there's a whole heap of other things we can do in this. So let's go through it. So the next demo I'm going to take you through is setting up the labels. So getting ready to start managing our tasks and issues across the platform. So let's go back into the GitHub page we were looking at just a second ago. I'm going to choose issues, and then I'm going to choose labels. And this allows me to set and edit and create some labels. So let's start with priority 1, priority 2, and priority 3. These will allow me to categorize my issues in terms of priorities, telling my team you should focus on priority 1's first, priority 2's second, and obviously priority 3's third. Helps me slice and dice the work that people are doing, which is a really important step. So once I've got my priorities in, I'm now going to work on my spec. And there's two types of requirements. There's a functional requirement, something the software does, and a non-functional requirement, which is something the software does not do, but needs to have as an attribute, for example, security, performance, those sorts of things. The next thing I'm going to add is one called triage. And this tells me whether I need to look at this issue and discuss it as a team, or whether I can just ignore it. So that's a label we're going to add, and I'll choose a fancy color for that. And you can choose whatever colors you want. So these labels are actually important because we use them later on in some of the tools that do the documentation for us. So they're not arbitrary. So Pro 1, Pro 2, Pro 3, functional rec, non-functional rec, and triage are all required labels for some of the things we're going to do later. And they help us manage our issues better. So they're really important to get right. The next thing we're going to do is we're going to start building our requirements. Now, obviously, in a 30-minute presentation, I don't have time to go through and start writing the entire requirement specification for a product, but we'll create a couple and see how it works. So to create these, I'm still inside of GitHub. And so what I'm going to do here is I'm going to go up to issues, and I'm going to create a new issue. And here, let's create a non-functional requirement to say that the product must be secure. And I can use the formatting tab at the top, or I can use Markdown to actually write this in a text format, which gets formatted nicely. So I'll just show you some bullet points, which is hyphen space hyphen. Will actually create bullet points, as you can see me typing on the screen right now. So I'm just going to type in those items, or just use something random, and then I can attach the labels. So this is probably needs to be triaged. It's priority 1, and it's a non-functional item, non-functional requirement. So I'll get all of those in and set, and now my issue's ready. Number 1 says the product needs to be secure. I've created a non-functional requirement. Fairly simple. The next thing I'm going to want to do is create a functional requirement. So let's go and click on issue, new issue again, and we'll give it a title. And in this scenario, I want users to be able to log in, but I want to capture somebody else's login screen and say, build me one of these. So the way I do that, and this is kind of weird for people who haven't worked in the web very much, is I'll show you. I'll go into an incognito window and I'll try and log into Microsoft Office 365, which should give me a login screen. Let's give that a go. There it is. I'm then going to use the snipping tool and go and capture that bit of my screen. There we go. And that should go back in the snipping tool, and I can hit copy. And I'm going to copy that, minimize everything I'm doing, and I can now just paste that image in. And what it does is it uploads that image to an area in GitHub. And when I hit save, I'll be able to see it. Anyway, this needs to be triaged. It's a functional requirement, and we'll give it a priority 1 as well. Cool. So I'll hit submit new issue. And now what I've got is I've got an issue there with my picture in it, exactly as I want it. And there are my 2 issues ready to go. But that's kind of cool. I've got some issues. So if I'm on the team, I can work through these things, and I can look at the different issues, and I can try and work out what I'm going to do. But that really doesn't help me create a specification. So what we're going to do now is work out how we produce a specification. So that's using a tool which I wrote to do this just for me, but I've made that open source, so you can actually have a play with it yourself as well. So to create specifications, I've obviously got these 2 issues in here. I'm going to go to nicbo/project documenter, and here's a tool I can download, which will run on Linux, Mac, Windows. It's a nice .NET 5 application, but it's a little command line app which will allow us to go and document our project. So if I go to my user at the top to settings and to developer settings, I can get something called a personal access token. And this allows the app to connect to GitHub as me and do something. I won't show you my token. I'll just go create it. And then I can drop out to a command line, back to my solution architecture space. I'll drop out to a command line. Here we go. Excellent. So there's my tool, my documenter tool. So I'm going to start using it. So documenter.exe -- repository, and the repository Solarc, -- owner, and that will be me, Nickbo, and you know that's Nickbo/Solarc, so that's how you get those 2 variables. Next, the doc type, and I'm going to build a specification. And finally, I want the token to be my personal access token, and that will create this MD file. Now, here's where we use Visual Studio Code. And the way we use that is to work with Markdown files. So I like to add some tools to Visual Studio Code to make it work. So I like to add Markdown all-in-one, really handy tool for working with Markdown, and Markdown PDF, both handy tools. What I can do is now go back to my document. I'll just click on it up there, and view. And then what I can do with viewing it is I can actually have a look at a preview on the right-hand side. So let's scroll down and find that. Open preview to the side, and you can see there's my specification written out in Markdown. Now, the beauty of the tools I had before, obviously including the images, is I can go and export this to a PDF, and I've now got this PDF file that's customer ready, which I can go use to deliver to my customer and say, right, here's my specification. But it also means my team is working off just things in that specification. So the concept of a living document is there because it all works off the same data at the same time. And that's super important when communicating with stakeholders, that everything ties together and works. So that's actually going through and setting it up. So what have we done? We've created a repo, we've created labels, we've defined our requirements, and we've created a specification to give to the customer. So quite often, if I'm bidding for work, before I do anything, I'll do this process, release the specification, and use that to go win the work. Okay, so the next thing we're going to talk about is how we actually operate and run one of these projects. So to run a project, there's a bunch of things we need to do. I like to have a very regular meeting, probably daily. We call this the triage meeting. So other people might call it scrums or stand-ups or whatever they call them. I call them triage meetings. And that has stuck with me since the turn of the millennium at Microsoft. But it's a kind of cool term because that's what we do in that meeting. There's then a process for managing bugs or defects. Again, like to call them bugs because that's how I've been brought up. You can call them whatever you want. But how we manage those is really important. And I've seen lots of people do that and get it wrong. And we're trying to drive quality into everything we do. And the bug management process is how we do that. The next thing is, how do I produce documentation fit for my customer? Or technical people, or the documentation that goes along with a product. How do I treat that as code? And we're going to focus on that because I'm not spending a lot of time in this session talking to you about how to write software. In fact, we're doing none of that at all. It's about how to run a project. And so producing deliverable documentation for your customer is super important. And the next thing we're going to talk about is producing the project documentation, the updates for management, which tell them how the project's going, how it's working, whether it's the right thing or whether it's not the right thing. So let's dive into each one of those and have a good look at them. So one of the most important things, I think, in a project is what we call the triage meeting. These go by lots of different names. They can be called scrums, huddles, stand-ups, get-togethers, project planning meetings, all sorts of different things. But a triage meeting is somewhere where you actually sit down, go through all of the items that are sitting in the list. And actually, let me explain the meeting because I like them to happen really quite quickly. They need to be really focused. You can't go to triage and discuss something that you haven't already raised as an issue. And when you raise things as an issue, triage has to make a decision. The first decision is to whether you assign it to somebody to fix it or not. That's really important to get right. It's key to make sure that there's enough information in the issue for somebody to pick it up and do the work that's required, that it describes what it wants properly, that it's actually got the right content. And if it doesn't, you need to decide what you do with it. You can't just be sending really poor issues across to the team because that will just annoy people and make it not work. So you can choose to assign it to a resolver. You can choose to resolve it with what we call no repo. i.e. we can't find the behavior that you're reporting in your issue. So we're just going to mark it as closed because we can't see this stuff happening. So we think it's fixed. The next one is to say we won't fix the thing you've asked for because it's actually designed that way. This is something which really winds people up, but it's really important to have that in your triage meeting to make sure you can do those things. The triage team actually works as a peer team. They work with each other to make these decisions. And it's important that we all work as peers in the triage environment. There's no management, there's no hierarchy. It's how it works well. The other thing we can do is called punt. So when we're building a product, we have a bunch of releases. Some people call these sprints, but things we want to do by a certain time. And if an issue isn't making the cut for whatever reason, you can actually move it to the next iteration or sprint or item. So it's important to think about, what am I going to do? Each item, am I going to assign it to someone? It's got to be complete. Am I going to resolve with no repo because we can't make it work? Am I going to resolve it saying we won't fix it? Or am I going to punt it to the next version? And triage makes that decision, and it's a very defensible position because we've all done it as a peer team. So triage is really important from that point of view, and a really important meeting. And triage, you work through issues and you document your decision in the issues. It's not some big other meeting. Everything lives within issues. Triage is kind of where it all happens. The next one is bug or defect management. It's important to get this right. One of the things we're thinking when we build product or build technology solutions is we really want to deliver as much quality as we can. And this process, I think, really does it. So there's a link at the top. I wrote a fairly chunky set of markdown pages, which allow you to, which is called the release method, which documents how this happens at a slightly more higher level. But you're welcome to go and have a look at that and even fork it and do a pull request if you want to change things. But the way it works is this: the person who finds the bug or thing they want to change, they're called the originator. Triage goes and processes that bug or issue and may hand it to a resolver. The resolver will fix it and hands it back to the originator saying, I fixed it. So he doesn't close it, he marks it as resolved, not closed. The originator is then the person who's able to close it or send it to the resolver or send it back to triage. That process is how you drive quality. It's that double check. I found something, somebody's fixed it. Did they fix it to my satisfaction? Yes or no? I drive that into the process and off we go from there. And that's a really important way of thinking about how this all works. The defect management, using triage as the universal arbiter of everything, doing the defect management process to make sure that things are fixed when they should be, is a really important way of making this all come together. So that's defect management. The next thing is your deliverable documentation. So it used to be we'd write documents and we saw them in Word or PowerPoint for some people, or even Excel or text files. But I'm a big fan now of using Markdown to write the documentation. And one of the reasons for that is GitHub's really good at doing version control of text files. And documentation in Markdown, because they're all text files, you can see who changed what when. You can go backwards and forwards in the history of them. It's stored in GitHub. GitHub renders your documentation on the website. It's really, really easy to see what's going on. Super easy way of doing product documentation, I think. And lots of tools will render that. You can use tools to render that as websites. You can render that as Word docs. And what we're going to show you in the next demo is how to take deliverable documentation and render it as a Word document. So let's dive in and have a look at the demo. Here we go. So I'm going to go back to GitHub. I'm in there and I'm going to go where it says code and clone, and I'm going to copy that link. I'm going to create a folder on my machine and I'm going to type in git clone, and that will go and get me a copy of that repository locally. Now, I could work all in the command line. I'm not going to. I'm going to work in Visual Studio Code because it's a bit easier. And what I can do in here is I want to make some changes. So I'm going to create a new branch. I'm going to take a snapshot of the repository now, and I'm going to branch it so I can work without affecting anybody else. So let's create a couple of folders. I'll create an image folder and a documentation folder. And in there, let's go and create a markdown file we'll call readme.md. There it is, not much in there yet. So I'll just put a title and some contents, and that's my document. And I can add to that and add more markdown files and do whatever I want. Let me go check that in. I'm going to add a comment to check it in so people know what I did. I'll hit the little tick. I'll say, yep, always. And now I'm going to synchronize that. That's checked it in locally. I'm going to synchronize that with the server. So off it goes. Now, that's in its own branch still, up with the server. And I may want to merge that into what everybody else is doing. And I do that using what's called a pull request. So I'm going to take a pull request, which takes all of my changes together, and I can merge that. But I can have reviewers who can go and have a look and see what's changed, which is a really good way of communicating with the whole team what's going on. And there's my Markdown file in Markdown, sitting there in a browser, which is great, but my project sponsors aren't going to want to sit and look at a browser in GitHub. So how do I give them what they expect, which is a document? Do it like this. I'm going to create another file in here, and I'm going to call it title.txt. And in there, I'm going to put some syntax, which says the title, the author, the rights, and the language. And I'm going to hit save. I'm also going to create a little command file called build me, and this is where I'm going to put the commands for a tool called pandoc, which is actually going to create my Word document for me. So I'm going to create output is solution architecture.doc. It's a docx. I use title.txt, and I'm just going to put in readme.md. But after that, I can put spaces and any markdown file I want. So I can add lots and lots of markdown files to create all my documentation. I've just run that, and you saw it ran in really quick time, in seconds. And I can go open this, I can open my Word document, and there's a well-formatted Word document that's been built and is ready to go from my Markdown. So really useful way to make that work is to use pandoc to turn your Markdown into customer-ready documentation. So we've talked about triage, we've talked about the bug process, we've now created customer-ready documentation. The next thing we're going to want to do is talk about project documentation. People are going to want to know how our project is going. And there's lots of tools to manage projects. There's external tools. There's things like Trello, Microsoft Projects, Microsoft To Do, all sorts of things. But we're going to use GitHub to manage our project today. Okay, so we have our repo. Let's go and create a project so we can use that for project management. So the way I make that work is I go up and click on projects, and I'm going to create one. And these are project boards. Kanban boards are ways of managing projects really quite well. So I'm going to give this board a name. I'll call it first release, and I'll give it a description. And I like to use the automated Kanban because that moves things around depending on how the issues are going. So GitHub goes and creates some cards. I tend to delete these, but you're welcome to look at them and see how they work. And I'm always going to add a column. And this column is going to be all about testing. So everything needs to go through the need testing process before it actually gets released into production. I want to be able to report on that as well. You can drag and reorder these however you want, which is really neat. And I'm going to drag my issues into my board. So I'm now managing those as one thing. And you can have some issues, all issues, non-issues. And I'm just going to create a new one from here, which involves very simply creating a card to say create the documentation. Once I've done that, I'll click add, and I'm going to convert that to an issue. And there we go. Happily does that for me. And I can go and give it some labels. I can give it a priority. I can say it needs to go to triage. I can do all sorts of things in here. So I'm going to do that, assigned it to myself, and I can start dragging these around to reflect where we are in the project. So I've got these kind of vertical swim lanes that allow me to see what's going on and how things are being tracked. So really, really useful way of managing those. Now, I can also use the documentation tool, same way we did before, just with a switch to create project documents. And that will create a project status report showing what happened in the last 30 days, where are open issues, what are our projects, and where are the things in the different swim lanes, as you see there. So a really easy way of creating a report and getting that to management quickly. And obviously, I can right click on this and choose to save it as a PDF as we did before. So there's a whole heap of options you've got to be able to do that. So that's building and running and operating your project. And obviously underneath that, you're writing code and creating documents and all sorts. But if you track it here with your entire team, it's very, very easy to report to management. So everything's kind of put together for you in a single place. So let's look at how this applies to our real world example. And there's a couple of ways it applies. You can see here on the left, I've taken a snapshot of what's going on with our issues that we're tracking today. And these change really regularly. And it gives the project sponsor the ability to see what's going on really easily. So here are the key things. Number one, our documentation is now all in Markdown. So we've gone away from some locked up PowerPoints and Word documents. Everything's in Markdown. We can see everything that changes, when it changes, and we can track it. So everything's in a really good place for anybody to work on. Makes it really easy to bring in somebody into the team or let somebody leave. Nothing's caught up in its own space. The end user documentation is now published directly from GitHub. We use something called GitHub Actions, which are automations I can build on top of GitHub, which actually builds the documentation from the source and publishes it. The code's being worked on through issues rather than random developers going to random places trying to fix random things. And everything's managed through a regular triage process, which keeps people accountable, but also means you know where to go to get something fixed. So the quality's gone up. The product has far stronger quality, and we're moving towards beta at the moment. So you want to see if I can put my money where my mouth is, go sign up for the beta, and I'll put you a link at the end, so you can actually sign up and be part of this beta program. Visibility is improved, and more interestingly enough, we're delivering more faster. Our delivery cadence has improved as well. So thank you for looking at this presentation and seeing what's going on with GitHub for project management. Let me just wrap it up and put a little bow on it before we finish off. So number one, GitHub's a really cool free tool to manage projects of all types and sizes. Right? And used properly, it can actually drive any type of project. It's not just for software development. You can use it for documentation, proprietary project, open source projects, all sorts of things it can be used for. So it's a really, really powerful platform from all of that, from that point of view. Interestingly enough, all of the tools we showed you today are free. So you don't have to buy anything to make this happen. You get more stuff in GitHub if you buy things, but you certainly don't have to. If you go to github.com/nickbo/solarc, that's that repository I created in here in the presentation today. I'll make sure that's continually updated with links and other resources that may help you. So go in there, and if you want to add a link, you can fork it and do a pull request and start contributing on that as well. And finally, if you want to have a look and see if I put my money where my mouth is with a real project, you can sign up for early access to our beta at m4software.com. All that's left for me to say is thanks so much for joining me for the presentation. I hope you have a great conference and a fantastic rest of the day. Take care, and we'll see you soon. Bye for now.
Well, I hope you all enjoyed this amazing talk. And for now, I would like to remind you that we have one more free track, the vendors track. It's happening live right now and available by the link that I will share in the chat. Share it with friends and colleagues who are interested in cloud architecture. The speakers on this track today are Heik Melkonian, Ashley Chamboko, Simone Pomata, Thomas Lemuel, Elliot Pierret, Yasine El Ghali. They will share in-depth knowledge of the industry as well as the latest tech innovations that could change workflow when implemented into your project. So don't miss this opportunity. I will share the link right now. So check it out. And now I would like to present you our next speaker. This will be Sanjay Kattimani. Sanjay is a solution architect from Dallas, Texas. He is a certified Snowflake professional and also a data superhero. Today, he will share some insights about building high-performance analytical solution using Snowflake. And now we're gonna see his presentation about architecting high-performance analytical solution using Snowflake. Also, interesting fact that the son of Sanjay was our youngest speaker on our previous Python event. So get ready for the new dose of amazing information.
Hello everyone, I'm excited to have you all on this session. I'm sure most of you heard about last year's biggest IPO in software history. It was Snowflake, and for good reasons. In this session, we are going to explore what makes it unique, a brief about its features, and we will also look at a couple of reference architectures to build high-performance analytical solutions using Snowflake. Let's get started. My name is Sanjay Kattimani, and I'm a solution architect by profession. I've been using Snowflake for over 3 years now. I'm a SnowPro certified and also a data superhero of Snowflake. Whenever we are choosing a modern analytical solution, we almost always come across these fundamental questions. Can our underlying architecture scale to meet the needs of our fast-growing business? Can our product ingest and analyze large amounts of structured as well as semi-structured data together? And most importantly, can we accomplish these goals while remaining operationally efficient and cost-effective? Welcome to Snowflake. Snowflake is a single integrated platform delivered as a service. It features storage, compute, and global services layer that are physically separated but logically integrated. Data workloads scale independently from one another, making it an ideal platform for data warehousing, data lakes, data engineering, data science, modern data sharing, and developing data applications. Let's quickly look at what makes Snowflake's architecture so unique. Snowflake's centralized data storage layer is designed to support sub-second query response times against multi-petabyte table sizes without explicitly partitioning the data. Snowflake also provides native support for semi-structured data types such as JSON. In addition, Snowflake fully supports ACID transactions with fast insert, updates, delete, merge operations. Your data is also highly secure with Snowflake's many built-in security features. Snowflake encrypts all data at rest and in transit. Snowflake's computing layer is fully decoupled from storage layer and runs virtually any number of workloads on their own dedicated computing clusters, even if these workloads access the same underlying data. Dedicating computing resources for each workload avoids the drawbacks of running all workloads on a single large cluster, such as having a queue to drop workloads or engage in the costly and time-consuming effort of increasing compute capacity. With Snowflake, computing resources are independently sized based on need of each workload. And Snowflake provides a usage-based pay-by-the-second business model with zero cost when a workload is automatically suspended. Snowflake's cloud services manage client sessions, metadata, transactions, query planning, security governance, and other services. It is also highly scalable tier. Snowflake supports thousands of customers' accounts and hundreds of millions of queries each and every day. With each of these layers being independently scalable, whole Snowflake ecosystem becomes highly scalable to meet all modern analytical systems demands. Now let's explore some of the features of Snowflake. Snowflake separates compute and storage so you can scale each of these independently and cost effectively. Snowflake automatically scales compute resources up and down for near infinite concurrency without impacting the performance or having to reshuffle data. These compute resources are needed to query, ingest, or for most of the other data operations. Align costs with your product margins with pay per second compute pricing and avoid paying for idle resources. Ingest and immediately start querying JSON, Parquet, Avro, ORC, and XML data without defining schemas in advance. Deploy on any cloud regions with global replication for high availability, data durability, and disaster recovery. With zero copy cloning feature, you can quickly create sandboxes and develop pilots with live data but without the cost of copying and moving the data. A great use case of this feature is to create a replica of production environment in a matter of seconds to troubleshoot the issue without incurring any additional cost or time to recreate an exact copy. Time travel lets you easily access historical data after it has been modified or deleted for a period of up to 90 days. With a wide variety of connectors and drivers, you can integrate easily with native clients and connectors, including ODBC, JDBC, Node, Python, .NET, Go, Spark, and Kafka. Use SQL for all your data, structured or semi-structured, including support for joins across the data types, databases, and external tables. You can extend Snowflake with in-engine JavaScript functions to perform custom calculations. Automate the steps to transform and optimize continuous data loads with Snowpipe and third-party data tools. Share live data easily and securely with your partners, but without copying or moving the data to ensure a single source of truth across your ecosystem. It also offers security features to protect your customers' data with role-based access controls and data encryption at rest and in transit. Partner Connect lets you easily create trial accounts with selected Snowflake business partners and integrate these accounts with Snowflake. Fivetran is one of the integration partners who provide connectors to Salesforce, Google Analytics, and many other such standard. ThoughtSpot is another one that integrates very easily with your Snowflake and creates AI-driven analytics on your data. Metilin is a great ETL tool on the cloud. DataOps by Datalytics is another great tool that provides end-to-end orchestration, environment management, CI/CD pipelines, automated testing, and ELT wrapped in one elegant UI. Snowflake's marketplace is an online transactional location or store that facilitates buying and selling of data. A data marketplace is more a public form of data sharing and sometimes commercial or monetized too. Live COVID-19 dataset is one of the most popular dataset on Snowflake's marketplace. I tried this data set a couple of months ago and I could query and figure out a number of details such as how many COVID patients are there in a given zip code, or which country has the most COVID recoveries in a given time period. You could also combine this with the number of hospital beds available in a given zip code and figure out how many hospitals are running out of beds. You could also chart out projections based on available data to predict the future scenarios. It was very interesting. That was just one of the example, but then you can also see there are a number of categories and you will find data set on each of these. There are a number of such interesting data sets available on Snowflake's data marketplace. Again, the consumer will be paying for the compute, whereas the storage is already paid for by the owner of this data set. With this good understanding about the features and architecture of Snowflake, let's take a look at a couple of reference architectures to create high-performance analytical solutions using Snowflake. Customer's 360-degree view architecture is one of the most widely used architecture to build sales and marketing applications that use historical and real-time data to accomplish 360-degree view of customer goals, such as finding new segments and sending personalized offers. In this architecture sample, we have cloud object storage that stages application data such as data on products, audiences, purchase attributions, and user activity for ingestion. A streaming service ensures reliable and continuous ingestion by buffering event data such as click streams. ETL services orchestrate the workflow to load data from cloud object storage into Snowflake. Snowflake secure data sharing enables data from third-party sources to be used without copying or moving the data. Snowflake supports all analytical workloads within the application. External tables support queries of data in cloud object storage without ingestion. Streams and tasks features automate the ingestion and data enrichment process. Native support for JSON and other semi-structured formats simplifies the data ingestion of event data. Secure data sharing enables monetization of fresh data without copying or moving the data. Machine learning models are trained to optimize offers based on historical data stored in Snowflake. The application can make real-time predictions via an API and uses Snowflake tables to store input data, and batch prediction results. Application health and security analytics reference architecture analyzes large volumes of log data to identify security threats and monitor application health. The application and its infrastructure log large volumes of event data that can be used to monitor application health and detect malicious behavior. Log collection and aggregation systems centralize log data from multiple sources and deliver it to streaming services or to cloud object storage. Streaming service buffers log data to ensure reliable and continuous ingestion. Depending on which log collector and aggregation system is used, data can be staged in cloud object storage without the need for streaming service. Snowflake stores and analyzes the log data, which can be saved for long period at commodity storage prices. Snowflake with auto ingest automates the ingestion from cloud object storage. Scheduled task invoke SQL-based queries to detect suspicious behavior or application health concerns. External rule-based alerting systems such as Snow Alert can detect suspicious activity or health concerns. Operations teams can monitor the application via dashboards or ad hoc queries. A messaging service such as Amazon's SNS or Twilio uses email, SMS, or push notifications to notify operations teams of events that require attention. Security information and event management systems such as Splunk can leverage data in Snowflake for advanced searching and alerting capabilities. This reference architecture is for Internet of Things to build applications that analyze large volumes of time series data from IoT devices and respond in real time. Smart devices, sensors, and other IoT devices generate continuous data. Due to frequent unreliable internet connectivity, IoT devices communicate using MQTT protocol and IoT message broker. The message broker uses publish and subscribe mechanism to interact with other services which subscribe to the specific topics within the broker and access the service data. A streaming service is used to ingest and buffer real-time device data, thus ensuring reliable ingestion and delivery to a staging table in Snowflake. In cases where the application requires it, cloud object storage is used to stage batch data prior to ingestion. For example, IoT device may be sending data every second, but it may get aggregated over longer period and may be stored in Snowflake. Snowflake offers native support for JSON and other semi-structured data formats for easy ingestion of IoT device data. Snowpipe automatically optimizes time series queries by ingesting data chronologically. Snowflake's streams and tasks features automate the workflows required to ingest and aggregate incoming data. An IoT rules engine hosts the business logic required by the application and operates on data available in Snowflake and in the message broker. The rules engine sends messages back to control the devices. Our next reference architecture, machine learning and data science, is to train machine learning models to build predictive applications such as recommendation engines. Application produces training data which Snowflake ingests via streaming services or via cloud storage. The streaming service buffers the training data to ensure reliable and continuous ingestion. When cloud object storage is used, the streaming service batches training data into larger chunks to lower API storage expenses. Snowflake ingests data into staging tables. When new data is detected, the streams and tasks features schedule required transformations. Multiple streams and tasks can be chained to implement complex data pipelines. External tables support queries of data in cloud object storage without ingestion. Data scientists can create zero-copy clones of the training data to support feature engineering and experimentation. Using the data stored in Snowflake, data scientists train models with machine learning platforms and available libraries. Once the model artifacts are trained, they are deployed on training platforms or on separate processes to support predictions. Moving on to the next architecture, that is serverless data stack. This architecture is for data-intensive applications that run on serverless infrastructures. The client-side apps running on mobile or web devices invokes the application logic on the serverless compute via API gateway service. The gateway service authenticates the API calls and throttles them if needed based on SLAs. Serverless compute runs the application logic and scales on demand without the need for provisioning or managing the servers. The application queries the Snowflake data for runtime decisions such as delivering product recommendations or powering the dashboard for analysis. An OLTP or NoSQL database provides the application with high capacity transaction processing. This NoSQL or OLTP database can also be a serverless service. An ETL serverless stack orchestrates the workflow and loads transaction data into Snowflake. Snowflake ingests data in batches or in streams and makes it available to the application for queries. Snowflake scales automatically to keep pace with the data pipeline and ensures data is always fresh. Workloads are isolated in virtual warehouses where they can run and scale concurrently without resource contention. That was about serverless data stack. And now moving on to the last reference architecture, which is on streaming data stack to build data intensive applications that rely on streaming data ingestion and analysis. The producer application generates continuous data that the streaming service ingests and buffers to account for data rate differences between the producer and consumers. Depending on the application's needs, Snowflake ingests data directly from the streaming service or via cloud object storage. Snowflake ingests data from the streaming service into staging table and stores streamed data for analysis. Multiple streams and tasks can be chained to implement complex data pipelines. Snowpipe with auto ingest automates the data ingestion from cloud object storage. Regardless of what type of applications you build or what architectural design patterns you select, you must meet the core data platform requirements for scalability and connectivity if you want to attract and keep customers to grow your business. With Snowflake, you can meet customer expectations with modern foundation of your data stack that delivers a highly performant service both now and in future. That's it about the reference architectures. To conclude it, this 30-minute session was intended to generate enough curiosity in you about Snowflake, and by no means to cover every architectural details. If you haven't started your Snowflake journey, I highly suggest you to try it out with 30-day trial account. I'm sure you will love it. Signup.snowflake.com lets you register on Snowflake site and use their trial account. Thank you all for joining my session today. I'm available on social media and you can easily find me with my first name and last name. That is Sanjay Kattimani. I'm available on YouTube, LinkedIn, and Twitter. I would love to connect with you. Questions and answer session is coming up shortly. Looking forward to talk to you all. Thank you.
Thank you, Sanjay. So I hope everyone enjoyed this session. And before we start our Q&A session with Carola and Sanjay, I would like to make a few announcements. So, first of all, we'd love to see you among us at the React.js Case Study Festival on March 16-17. Either you're considering React.js as a career move or upgrade of your JavaScript knowledge, or have already started as a front-end developer specialist on React.js, the event will help you to think out of the box and master the React.js practices. You'll get 2 days and 14 hours in 2 time zones to learn battle-proven React.js case studies of top companies as AWS, Facebook, Code Academy, Product Hunt, and others. Learn how to make your front-end accessible to everyone. Know more about hooks and best testing practices, and much more. Have time to register during a happy hour to get a ticket for only $30. I'll share the link right now in the chat, so don't hesitate and register with such a nice price. And now we are ready to start our Q&A session with Carola and Sanjay. I'm adding both of you to the stream. Hi.
Hi.
Hey Victoria, hey Carola.
Hi, Sanya.
Hello.
First of all, thank you so much for such an amazing talks. It was a pleasure having you with us. And now we can proceed with questions. I think we have quite a lot of those, starting from the very beginning. So let's go back to our comments. And our amazing audience, feel free to ask more questions right now. And if your questions was somehow missed or something, feel free to duplicate it right here in the comments. So let's start with our first question. And it's there. What are the best tools to inspect the system to make this kind of analysis? I think it was to Carola. So
Yes. I wrote some of the questions down, so I saw them before, and so I had a little bit more time to look at them, of course. And well, there are some tools that are for free, but those tools are generally not very easy to use for this kind of analysis I do, because me and my colleagues, we do it live with the team. And for that, you really need some tools that cost money. They are not for free. And I had them on one of the slides. I love tools from the company Hello Tomorrow. They are called Zonograph, Sotograph. There is a wonderful tool from America called Latix from the MIT. There's another one from England. I'm just searching for the name, but anyway, on Wikipedia there is an article on tools for static analysis, and if you don't find it there, just send me an email. There is a bunch of tools. I really like another one which is called QA Assistant, which is a very good tool as well, and this one is actually for free. Yeah, I hope you find something that helps you. From this answer anyway, write me an email or send me a tweet. This will work as well.
Thank you, Carola. And next question goes right now. So it's for Carola. At point or at what do you consider that we have crossed the low and stable maintenance costs?
Yeah, I think the question is about when do we leave this area? And it depends, of course, what kind of system you have. But I normally ask people how big is your system, and for me there is a rule of thumb how many people should be there for maintenance. So if you have something like 500,000 lines of code, one person. Of course, you need 2 half persons to be really in the sure area, but you need one person to do the maintenance, and the rest of the team should do enhancements and changes, and then you can just calculate how much you should need, and this is the area where you are still in the green and low and stable maintenance cost, and you can keep on enhancing the system. If you need more people, you're not in a good maintenance cost ratio, actually. This is
okay.
This is easy explanation. The other one is finding out with all the ideas and concepts that are in my book where you are, because I showed this other diagram where people could see systems that we analyzed, and we told the people, well, you are red, you're yellow, you're green, and this is of course a little bit of a more difficult process.
Okay, thank you. And our next question. So what are the data protection options in Snowflake? I think Sanjay, is this for you?
Sure. So apart from multiple network security options that are already available in Snowflake, for protection of the data, they provide column level security using their own proprietary data masking solutions. They also have encryption available on. They can provide encryption using the either the customer keys or every data that is getting in and out of Snowflake is also encrypted with its own default keys. And it provides security for the data at rest as well as for the data in motion.
Okay, thank you. And here we go with our next question. So, Carola, how can we avoid going into red zone for the maintenance costs?
Yeah, very good question. Well, what we can do is we really can work on our technical debt. We have to try to get our system into a good, straight architecture. And what I do with teams is I try to help them to create rules for their architecture. Maybe on the pattern level, maybe on the level of the architecture. And if you have these rules and you have means to control them, and then you get a lot of possibilities to avoid the red zone. One tool my teams are starting to use at the moment is an extension of JUnit. It's Arc Unit, and you can use it to control your architecture, to control architecture violations. It's like tests, but it's testing the architecture. You can describe the architecture and then ask the unit tests, the Arc unit tests, to check for those rules. I think you should have a look at that, because this helps a lot to stay in the green zone and not get into the red one. And it's as well a question of transporting the idea of the architecture to everyone in the team, because the people who program, they want to really finish a feature. They want to extend the system, to change something, to find a bug, but they are not thinking about the architecture at that moment. And it's very important to remind everybody again and again of the idea that this architecture had. Otherwise, it's getting forgotten. People don't feel it anymore, don't know it anymore. So it's very important to have regular meetings in the team. We are doing this all 2 weeks. We have an architecture review or something, so that we really know about the architecture and don't forget it, and work on it in the every day in the end.
Okay, thank you, Carola. And next, how can you use structured and semi-structured data in Snowflake?
Sure. So just like any other system, Snowflake offers structured data, but in addition, it also offers support for semi-structured data like JSON, Parquet, Avro, and a few other formats. So you can get that data into a data type called variant, and once it is in Snowflake, you can write views on top of it and join it along with rest of your structured data. So it is very effortless, a process to use structured as well as semi-structured data in Snowflake. So this is one of the very important aspect of building a data lake. It should have support for semi-structured data, because that's what is the kind of data we see around us. All these devices generating JSON and these kind of data.
Okay, thank you, Sanjay. And let's see our next question. Hi, Carola. It was wonderful explanation. What are the tools we have for Java in market for identifying the class dependency?
Yeah, it's again a question about the tooling. For Java, you can find on Wikipedia a whole page with all those tools. You can there's a very old tool called Xradar, which was used a lot in former times. There is Sotograph, Lattice, some other tools, JQ Assistant, many tools that you can use to find those dependencies. And I'm probably forgetting half of them. So any tool vendor here around here, don't get angry with me. I'm just a speaker and not the tool seller. So there are many tools out there. Look at the Wikipedia page. I can even send the link for it if you want, and you can find it as well. Okay, thank you.
Thank you. And this one, I think it's to Sanjay. So you mentioned zero copy cloning in Snowflake. Is it a read-only copy of the database?
Well, it is to begin with. It is it copies just the it does not copy the physical data. It is just a reference to the data. So to begin with, it is a copy of a copy that is available to you, but it is definitely not read-only. You can definitely write on top of it, and you are paying only for that changes that you have made. Otherwise, the copies that you make, you don't incur any cost for that storage. It's only the compute that you pay for.
Okay, thank you. And we have next question from Abdul. So it's very hard to explain the technical debt to management and to buy time for refactoring. We do on our own in OKRs and face blame sometimes when something goes wrong. So can you please share some light in this time?
This is a wonderful question. Yes, it's often very hard to explain this to the management because they don't know about programming. And this is a real problem from my point of view, that management, especially the management for the IT part of a company, has never seen any programming, and the pain that is in there when you don't get time to rethink your ideas and refactor the system. So I really, really know what you're talking about, what you're feeling. What I'm trying to do is, you have seen what I was talking about, and I was talking about how complex this is and what this does in the brain. And with this idea, I sometimes can reach the managers, and they understand. And this is sometimes a bit like an eye opener to see that it's not such a weird thing to program. It's just about complex structures, and people need time to rethink it. And if you reach that point, and if you don't, you have to look at the managers with an eye of somebody who has his own right of being and working. And what we are trying a lot as well, is to try to get out some numbers, to really think about how much it costs to stay with these technical debt, to not refactor them, and how much a refactoring would cost. And if you do a good calculation and you can explain what you're doing and why this is expensive and why this would help to reduce costs, this is the level where they are working on. They will understand. They will prefer to pay less money in the end. We have to get on their level, and I know it's difficult, but it's possible, especially if the management had the experience how difficult it is to get a legacy system on track again, to get it to work with a different interface or with a different front end or whatever. But it's a lot of work, and we have to change into the view of the management to be able to convince them. This is for sure. Sometimes it helps to ask some consultant to come and explain. Sometimes this doesn't help so much, but these are some possibilities I think you have.
Yes, thank you, Carola. Sanjay, maybe you have some tips to share, something to add on this?
Well, no, she's the Carola is the expert, so I'll just leave it to her.
Okay. So our next question, I think it's to Sanjay again. So what are the typical challenges in adopting Snowflake?
The challenges are, to begin with, a lot of people, they just think this is a new tool, and adopting to new technologies is always a little bit of challenge. It's just getting started is the biggest hurdle that I see. Once they get started, I don't see so many challenges. Because it already brings in so many connectivity to rest of the ETL tools and productivity tools. What other challenges do I see? So another challenge that I see is cost overrun sometimes when they don't use the resources appropriately. For example, virtual warehouses. If you start a huge virtual warehouse by accidentally and you just kept it running, that's when you may run into cost overruns. So those are the things that can be tackled by putting some resource monitors and managing the cost. So those are some of the beginner challenges that many customers face to get adjusted to the environment and control the cost and be productive in the beginning.
Okay, thank you. And here comes the next question. So, hi Carola, do you use SER architecture trade-off analysis method for architecture evaluation?
Yes, yeah, we do. We do this if we want to find out with a customer what kind of trade-offs they have. Because, I mean, if you look at a quality model, there are so many different qualities that are actually, you can't fulfill them all. You can't be flexible and very performant and things like this. So you have to decide what you want to do in your architecture. And to find out what is important for a client, we use architecture trade-off analysis method in workshops as well. But if the customer tells us, well, I have a maintenance problem, I don't need to do it because I know how a system should look like. That is easy to maintain. This is what I talked to you about. Of course, there are some other aspects. Is there a lot of technology in there? And I mean, you can go much more into detail, but to see if a tool, a system, a software is maintainable, I don't need to create scenarios with the customer that describe the fulfillment of a quality issue, because I know how a system should look like. I mean, this is the good point about maintenance and code. If we do performance analysis, what we do as well, this is another story. There is no general standard process to find out if a system is performant. It depends on what you want. And then we do have to do it in ATEM as well, of course. So it depends on the question. And for maintenance, for this question, I was happy to write my doctor thesis about this theme and find a standard answer, which you can't find for all the quality issues. I mean, usability. Is there a standard? No. There's a lot of work there. Maybe one day we will have standard procedures for all these different quality measures, but
maybe
these days we don't. So we have to do ATEMs. This is it.
Okay, thank you so much.
Wonderful question. Wonderful question.
Thank you. And next question. So, Sanjay, can you speak a little about how to successfully ingest data from CRM platforms and bring it together in Snowflake?
Absolutely. So if you have your data in any CRM, depending on how frequently you want to bring the data in, sometimes it could be once a day you want to ingest the data. Not necessarily everyone wants to get the data as soon as it is available. So if you have batch processing needs, you could use tasks, and you can schedule a job to bring that data using any of the standard ETL tools such as Talend, Alteryx, or there are numerous other tools, or Matillion. There are numerous other tools that you can use to push the data from any of the CRM systems into Snowflake. And if you have streaming requirements, you could use Kafka connector or something like that. Or if you have, some other micro batch related requirements, you could also use Snowpipes to ingest the data into Snowflake. And once it is available there, and you can always join it with the rest of the data that you already have in Snowflake, or vendor provided data and then run the analytics and serve the needs of reporting or data warehousing or your IT departments.
Okay, thank you. And next question to Carola. What is the best percentage of code test coverage and which parts should be covered first?
Yeah, very nice question. Well, test coverage is for me is really important, and it's like a double net if you are programming to start your unit tests and see what you have changed. From my perspective, for the domain, I mean, the most important bit is the domain layer, the domain. I mean, if you have an idea of an architecture like an onion or like a hexagon, the thing in the middle is the domain, is the source code that reflects the domain and that programs all the domain knowledge inside. And this part should end up with 80% at least of test coverage. And then an amazing thing happens, because the whole team loves to find bugs and write new tests and see that and repair the system and see that the rest is still working. And you love it if someone outside finds a bug and you like to change the whole thing. You are not afraid anymore. So please, 80% at least. And for the technical software around the domain part, of course, I would love to have 80% or more as well. But sometimes it doesn't work because it's too difficult to do the testing. So do it as much as you can. It will save you so much time, so much effort, so much frustration in the future if you have a high test coverage. And the architecture is better, by the way, if you have a good test coverage, because if you want to test something and it's a really big class cycle or a big ball of mud, you get problems to do the testing. So you start to get a better structure. And this is why do testing as from the first day, just do it.
Thank you, Carola. Okay, let's see our next question right now. So what are some best practices for managing Snowflake compute cost?
Great question. So one of the very first thing you should always do is set the resource monitoring so that you allocate certain credits, Snowflake credits to each resource. Let's say Sanjay gets 10 credits per week or per month or something like that, so that you always restrict them at first, and then you can always increase it as needed. So other best practice you can always do is always start with the smallest warehouse size, so that you can keep increasing it as in how you really need to improve your performance. And for production workloads, you can always set up multi-clustered warehouses wherein it can automatically scale up and down. So when it scales down, when there is no load on the production, you always save the cost. So these are some of the best practices that we found. Apart from this, there are various custom queries that you can write to figure out which warehouses are getting queued, or the queries are just queuing and not serving the customers as fast as they're supposed to be, or there could be some warehouses that are not getting used. So you can figure out these kind of statistics with some custom queries. I also love to keep digging into such details. I would suggest you all to look at such statistics and optimize your cost utilization of your resources, and optimize the cost.
Great, thank you, Sanjay. And our next question, I think Carola might started already this answering on these questions in our YouTube chat, but again,
yeah.
How do you manage to make those architecture improvements even in times of great urgency? I mean, do you use a technique to prioritize those refactors over other enhancements?
Yeah. of course, I mean, I've answered shortly in the chat as well. But now I can do it a bit more personally and a bit longer. Well, the question is actually how big is the urgency in that moment? And generally, in my teams, I have like 14 teams in parallel, programming from 3 to 10 or 15 people in those teams. And we are trying to have a ratio of 80% new features and 20% improvement. This is what we try to do, and I think it's reasonable. I think you have to do it to keep your system in a good shape. But of course, in my team, sometimes this doesn't work, and it's frustrating for everybody because we have a real big urgency. For example, we are programming a software for the state of Hamburg, and the politicians in their wiseness have done some kind of new rule or new law, and this law says that someone needs this and that information, and this and that has to be said and shown and done, and within half a year. And then all of a sudden you have to create some enhancement to your software system so that everybody can see that data, and this is difficult to do in half a year, and we have to rush. And then we discuss it with the team, and we try to write everything down that goes wrong and have a phase afterwards of refactoring. So my teams talk to me openly about these problems, and of course, as a manager, I have to decide. And sometimes I don't fulfill all their wishes, or they're not wishes. They are real pain, and I understand. But sometimes we have to follow the urgency, and sometimes we can do what we want to do. So in general, 80-20, and if it doesn't work because of something, just run for it and do it sometime later, like after 2 or 3 months or half a year. This is as much as I can say, you know. And then it depends.
Of course.
Like always. I hope this helped a bit, Rodrigo.
Thank you so much. That was a really nice answer. Okay. And here we go with the next question. So what ETL tools can be used to connect to Snowflake?
Sure. There are a number of tools that can connect to Snowflake, including Talent, Alteryx is there, Matillion is there, and a whole bunch of them are there, especially the open source ones. They all connect. Very few proprietary ETL tools do not connect directly, but then many of them can connect through ODBC or JDBC drivers too. And you can also write your own custom code if you are interested in either in Python, Node, or Java, .NET, any of these. So it provides very good connectivity to a whole bunch of other tools.
Okay, thank you. Thank you for your answer. And now I think this will be probably our last question for the moment because we are running out of time. And here it is. Hi, Carola. What are some signs that your bounded context is too large?
Yeah, so this is a DDD, a domain-driven design question, which is another talk that I should give some other time. But anyway, Rehan, it's as well difficult to have an answer for that because it depends on the complexity of the domain. And well, some people say it should not be more than 30,000 lines of code, but I'm not in it. You know, I prefer to look at the domain and find out which things belong together. And there are some indicators to know when you have to cut a bounded context. One is, of course, the team size. If the team gets too big, you have to cut the thing. But cutting is hard and difficult and will go wrong in the first place as well, like everything in software development. Sorry for that. But so you have to have a look at the team size. You have to have a look at the domain. And if you look at the big picture of the process that the software is supporting, there are some indicators where to cut, and this is a very, very long story to talk about. On the website of my book, there is a speech of me where I talk about domain-driven design, and I think I talk about that problem as well. If not, I'm gonna write me a letter or an email, an email or something, and I will find the right place to point you to some speech that I actually did in English. In German, there are a lot, but the English ones are not so many that they are easy to find. So maybe this is a possibility, or some other geek show will have me on that topic another time.
Of course. Thank you so much. Thank you, Carola. I actually think that we have one more question right now in our chat. Let me check. Yeah. So this will be probably our last question for this session. So, what are the tools and framework available for data governance? So I'm not sure whether it's for Carola or Sanjay. It just appeared in the chat.
I'm sure. Or maybe for somebody else who's not here. I don't know.
Well, not for me.
So for data governance, Snowflake does provide some, not inbuilt tools, but there are tools that can connect to Snowflake and provide the data governance. There is a very nice tool by Datalytics that it's called Data Ops that can connect, as well as it can show very nice diagrams also about how the data lineage is, and provide some kind of governance. So there are other tools also. I haven't explored all of them, but yeah, I'm sure, pretty sure that there are more tools. There is one by Talent also that helps you do the data governance. All you need to do is hook up to Snowflake, and you should be able to generate those.
Okay, nice. Thank you so much. Thank you, Carola. Thank you, Sanjay. I hope you enjoyed this your speech as well as this session as much as did I, and I'm sure our audience loved your responses. I see that someone is already going to buy your book, Carola. So, which is definitely.
Of course, I can only recommend it.
I'm also looking forward to read that book, Sustainable Software Architecture by you, Carola.
Thank you, Sanjay. That's very, very nice.
Thank you so much. It was a pleasure having you with us here, and I think we'll definitely see you again on our future events and on our next time zone, I think.
Yes. And thank you for this great conference, and I'm looking forward to tonight.
Thank you, and goodbye. See you soon.
Thank you.
Bye-bye, everybody. Have fun.
Bye.
So, hello again, our dear audience. For the moment, I would like to announce you that you still have 30 minutes till the end of the happy hour ticket for the React.js Case Study Festival. Take a chance to register now at the lowest price of only $30. I will share the link with you right now in the chat so you can follow and don't miss this opportunity to buy the ticket for this incredible event. So, also, I think it's time for us to show you the results of our Geekle challenge. I hope you remember of that one. Yeah, take a picture in front of your screen while watching a Geekle event and post it in social media with our hashtags. So actually, we already would like to, we are ready actually to show you the first post, which got a lot of likes. And let me share my screen with you and show you this. And here we go. And this will be this picture by Sergei Dergatsev. I hope you can see it. And I really like it. Thank you so much. And all of you, our amazing audience, don't miss the chance to be featured there. Featured by Geekle and stay with Geekle. I would like to remind you that we are starting our new subscription platform. So if you want to see all the videos from our previous events, from this event, from the speakers that have been already presented, and for the speaker who will present, so you should definitely subscribe. And I also would like to remind you that after my shift, which is ending right now, the time actually flies. You will have to switch to another YouTube link, which you can find in the comment in the description of the video, and also I will share it with you in the comments. Thank you so much for being such a great, active, and amazing audience. And I'm passing my shift to my colleague Anna, who is going to be the next moderator. See you soon.